Hey everyone, good morning. Thanks for coming so early. So my name's Josh Gordon,
And I'm Lawrence Moroney.
and we're here today to speak with you about TensorFlow's high-level APIs. And I have a lot of good news for you, and I hope this talk will be concrete and useful. So one area I'm particularly passionate about is making machine learning as accessible as possible to as many people as possible. And the TensorFlow team has been investing very heavily in the same thing. So we spent a lot of energy making TensorFlow easier to use. And I'd like to show you basically a demo of what is, in my opinion, the very easiest way to get started with TensorFlow today. So there's three things that are concrete that I'd like to walk you through. And the very first is, even if you're brand new to TensorFlow, you're brand new to machine learning, even if you're new to Python, one area that seems silly but is non-trivial for a lot of people is actually just installing TensorFlow in different dependencies. And I know for Python developers, it's just pip install TensorFlow, but that can be hard for people that are brand new. So I'm going to show you something called Colab, and I'll walk you through Colab. It's basically a Jupyter Notebook server running in the cloud. It's free of charge. It has TensorFlow pre-installed, comes with a free GPU. It's awesome. I'll walk you through how to use that, how to get started with TensorFlow. The next thing, TensorFlow has many different APIs. But my personal favorite, and what I'd strongly, strongly recommend to you, is something called Keras. And Keras, the Keras API is completely implemented inside of TensorFlow. It's great. I can't tell you how much fun I've had using it. So I'll walk you through writing Hello World in Keras. The same API is also useful for TensorFlow.js. And then I'm going to point you to some educational resources to learn more. Cool. So these are the APIs that I want to briefly introduce. So Keras, it's basically Lego-like building blocks for building and defining models. TF.data, so when a lot of people start learning ML, they get really hung up on, OK, they learn that a neural network is composed of layers, and they find out that they can adjust the number of neurons per layer, and there's different hyperparameters like the optimizer and stuff like that. And they spend a lot of time on what I call modeling. But something that's really, really important but doesn't get enough attention is actually how do you get your data into the network? And writing input pipelines is non-trivial. So I'm also going to show you an API called TF-data, which is a relatively easy to use, but also very high performance way of writing your input pipelines. And then I'm going to show you eager execution. If you're new to and Lawrence is going to give you a lot more depth on eager.
Yep.
By the way, when you hear the word eager execution, if you're new to TensorFlow, just ignore that and just think of this as this is the thing you always do. So you should always write and run, so develop and debug your TensorFlow programs eagerly. And it makes TensorFlow feel just like regular Python. This is a short talk, so I'm not going to go into all the details of how TensorFlow works under the hood. But this is the right way to do it if you're learning TensorFlow today. So briefly, this is what I would do if you want to try TensorFlow and Keras and TF-data and eager execution in the fastest possible way. And I should tell you off the bat, so all these APIs, they're fully implemented, and they're working well. We are just now starting to write all the samples and docs around them. So I have a feeling the samples I was able to cook up for this talk they're quite rough. But stay tuned and check back in the next few months as we flesh this out. But let me just show you how to dive right in. So if you go to this website, it will bring you can we switch to the laptop for a minute, please? Thank you. It will bring you to this GitHub site. And if you scroll down to the README, you'll see a sequence of a few notebooks. And I just want to show you how easy it is to get started. If you just click on one, what happens is they open up immediately in Colab. And so now you have a Jupyter Notebook. It's running entirely in the cloud. You can hit connect to connect to a kernel. And now I can start running these cells. And I'll walk you through this in more detail in a few minutes. But if you go through the first notebook, this is going to show you how to write your first neural network using Keras. There's a little bit of pre-processing code, but the notebook is very short. The next notebook will show you how to do the same thing using Keras in combination with TF-data and eager execution. And then we go into a little bit more depth. So it's literally that easy to get started. It will take you. So using the Keras API, this is the complete code minus a few lines of pre-processing, just formatting the data to write, train, evaluate, and make predictions with your first neural network in TensorFlow. So if you were using TensorFlow about a year ago, it would have been substantially more code. And there's other great high-level APIs, including estimators, which are really, really wonderful for doing machine learning in production. But at least for learning ML, I'd strongly recommend this. So I will walk you through exactly what all of these lines are doing. And one point I want to make is that the code it's concept heavy, but code light. So writing the code itself should no longer be a barrier to getting started with ML. I hope that far fewer people are going to spend energy and time on the syntax and debugging. And now you can spend more of your time and energy thinking about what you're trying to do and why. Oh yeah, and before I dive into the code, I want to make a really, really important point. So machine learning is a broad field. By far, another mistake that a lot of students make when they're learning is they learn how to train an image classifier, like we're going to do in a moment. And they find out when they write the classifier, they start evaluating it. And they see these numbers like 99% accuracy. And then they find out that by tweaking the network, you can get to like 99.6 or whatever. And in reality, it almost never matters. The most important thing you can spend your time on is designing the experiment. And what I mean by that is concretely thinking about what are you trying to predict and why? How will it be used in practice? What could go wrong? Where does the data come from? Thinking through the design of your system as you would in any type of software is much, much more important than messing around trying to get higher accuracy. I'm not going to cover this today. There's a whole talk on that. But today I just want to show you the code. But always think about what and why in addition to how. All right, so before I dive into this, a couple cool things. Not enough time to introduce TensorFlow. I just wanted to call out the community is the most important thing about TensorFlow. In addition to the 1,000+ folks who have contributed code, there are many, many more who are doing things like teaching, organizing events, writing articles. And these things are incredibly valuable, too. There's a few new things that I just wanted to call out. This came out 2 days ago. So there's another library called TensorFlow.js. It's part of TensorFlow in JavaScript. Uses the same APIs, the Keras API that I'm going to show you today.
Weren't you going to act out this slide?
I was going to act this out. There's a great sandbox where you can try it. Yeah, I could dance it out. Anyway, it's TensorFlow running in the browser. And this runs in real time. There's 2 links on the bottom if you check this out at home. There's a really great demo you can play with on our blog. And you can actually find the code on the website. Another thing, there's a pair of links here which I'd really encourage you to try. So this is Magenta. And Magenta is a project that uses TensorFlow for experiments in art and music. And here, this is computer-assisted drawing. So Magenta is helping me draw a duck. So I'm drawing the duck with the mouse, and Magenta, it's sort of like autocomplete for drawing. There's a great game called QuickDraw, which I'd encourage you to try. It's great for kids. It's, yeah, QuickDraw, and the Magenta demo is great to try. Just some fun stuff before we get into the code. And also, before I get into the code, in a personal note, one of the reasons I care about machine learning so much is because of a project called CellBot. And CellBot is a project from 2004. It was in a biology lab. And CellBot uses a neural network to identify specific types of cells in solution and then sort them. And what was so cool to me as a student working on this is that machine learning is not just for computer scientists. The fact that biologists were trying to do something useful using technology that originated in our field was really meaningful to me. It's how can we use machine learning for medicine, for art, for healthcare, just to do useful things in the world. So that's kind of the thinking behind everything I do with ML. It's what can we do to help people, basically. All right, so Colab. The URL for Colab is colab.research.google.com. Colab is short for collaboratory. It's inspired a lot by Google Docs. It's a Google Docs-style code editor, and you can download. Basically, you can save Jupyter Notebooks in Google Drive. You can download them back as regular Jupyter Notebooks, so there's no lock-in. I know a lot of people, by the way, are not from Python. So I just want to spend a minute and introduce Jupyter Notebooks. So broadly, here's Colab, and there's 2 types of cells. There's markdown cells, which contain markdown. And if you edit a markdown cell, like I'm doing with Hello World, and you execute it, it just renders the markdown. The other type of cell is a code cell. And if you edit the code and execute the cell, it executes the code. That's all it is.
And there's one really cool thing as well, is that they give you access to GPUs.
Yes.
Right? I've spoken with a lot of people who either find it very difficult to set up their GPUs, or maybe they're in a university environment and they don't have access to expensive GPUs. And if you're using a Colab, you can actually connect it to a GPU in our data centers so that you can test out your code running on GPUs.
Exactly, with no
Super
install
cool.
at all.
Yep.
It's a really good point. The other thing you can do if you're new to Jupyter Notebooks is you can create visualizations in line. So here I'm using Matplotlib to plot some data, and the graph goes right in line with your notebook. And this is really important because it's a great way to share results. Another thing that I wanted to mention quickly is you can pip install libraries. So you're running in some container sitting somewhere on GCP, but you can install whatever libraries you need. So here I'm pip installing matplotlib, so you have root access to it. And then the last thing, a lot of people miss this feature, but it's super useful. It's called snippets, and it's conveniently hidden in the table of contents. But what I'm doing in this notebook is I'm going to create some data, and then I'm going to download the data off of Colab back to my laptop. And to find out how to do that, I click on this snippets thing, and I start searching for downloading data. And Colab, can't totally see it on the screen, has a snippet of code that I can just copy and paste directly into the notebook and run. So it has examples of how to install libraries and everything like that. It's super useful. Don't have time to talk about this. Colab is great for reproducible examples. All right, so let me jump right into what it looks like to use Keras to write your first neural network. And I talked about this earlier, but no one has ever looked at the code to write your first neural network. Regardless of how smart you are, it doesn't matter if you have like a PhD in physics or whatever, and it's just gone, oh, I get it. It's impossible. It takes months to learn this stuff. So it's completely normal to see lots of concepts and have no idea what they mean. But let me just at least introduce you, and then I'll point you to a course you can use to get more depth. Oh, the other thing, I should probably look at my slides, right? So you'll see lots of parameters when you define these networks, and really only one or two are important to spend your time on. And I'll point you at what those are as we go. So there's broadly 5 steps to write Hello World in TensorFlow using Keras. The good news is steps 3, 4, and 5 are literally one line of code. So that's all the work of training the network, evaluating your accuracy, and making predictions. Collecting the data set in reality takes a long time. Pre-processing the data takes a long time. That's just getting it into the right shape. And building your model is where a lot of the concepts are. So let's see what this looks like. So we're going to use MNIST. I know for people that are machine learning experts, you know MNIST cold. And the reason I picked it is just so we don't have to worry too much about the data. If you're new to MNIST, it's sort of the hello world of computer vision. It's a data set of about 60,000 plus, very low resolution handwritten digits. And our goal is to train an image classifier to classify or recognize digits that it hasn't seen before. So here's what we'll do. We'll import TensorFlow. And you can see that on the second line, we're importing MNIST. And this is easy because the data set is already, we have a loader for it that's baked into TensorFlow. And if you're new to using Keras with TensorFlow, you can see that it's just included. You can do tf.keras, and now you have access to the complete Keras API. So there's nothing else to do. It's just there. And this is awesome. By the way, there are many, many awesome advanced things you can do using Keras and TensorFlow. Like, it's great. Here, I'm just trying to show you the straight, easiest possible way. Here's the format of the data set. So as imported, it's divided already for us into train and test. Train is about 60,000, test is 10,000. The top right, I have a diagram of the format of the images. If you look at the notebooks on that workshop directory, the best thing you can do when you import a data set is to spend a lot of time asking really basic questions. So literally, when you import the data, print it out. Print out the shape. Print out a single image. Look at the format. What's the data type? Is it floating point? Is it an integer? What are the dimensions? How many do I have? Spending a lot of time just understanding the format, the plumbing, will save you a lot of headache later on. So it's always OK to ask really basic questions. In the bottom right, there's many neural networks that work with 2D images. Here, we're going to make a simplification, and we're just going to unroll the thing. So instead of a 2D image, we're literally going to unstack the rows. These images happen to be 28 by 28 pixels. When we unstack them, we get a vector that's 28 times 28 equals 780-something pixels in a line. So it's a simplification. That's all it is to import the data set. I didn't show the code, which is just NumPy to reshape it, but it's in the notebook. So now we're going to build our model. And here's concepts that will be probably entirely meaningless to you if you're brand new to ML. One funny thing about neural networks, so there's many different types of classifiers. And most of my background, I was really invested in tree-based models before deep learning was a thing. And the reason I like tree-based models, like random forests, is that I can look at a tree, and intuitively, my brain understands exactly what the tree is doing to classify the data. Like, I get it. It clicks. Neural networks can be a little bit counterintuitive. It's hard to describe in 30 seconds. But let me just tell you what we're doing, and you can take the course to learn more. So here we're defining a fully connected deep neural network. There's going to be 2 layers that you can see. So first, we're defining our model. We're saying we're going to use the sequential API, which is the simplest API to define your model. It literally means our model is going to be a stack of layers. The first layer that we're stacking on is going to be a dense layer. Dense means it's fully connected. And I'll show you a diagram of this. I'm sorry. This is a one-layer network. But the notebooks have an exercise where you can add a second layer. And then we're adding an output layer with 10 outputs. And each of those outputs is basically going to gather evidence that the image that we feed through this network corresponds to each of the digits. And this slide, I was editing these slides last night, so this slide is actually a little bit different. But here we actually do have 2 dense layers. The point that I want to mention, there's a couple points that I want to make. One, this is the complete code to define the network. So it's code concise. 2, broadly, the more layers you add to your network, and the more neurons or units per layer, the more capacity your network has, meaning the more types of patterns it can recognize. The problem is, the more things your network can recognize, the more likely it is to memorize the training data. So in machine learning, there's always this tension between memorization and generalization. You don't want to just memorize the training data. What you want to do is learn patterns that are useful to classify digits that you haven't seen before. So it's very easy to get very high accuracy on the training set by building a deep neural network with many neurons and training it for a long time. It's not necessarily the right thing to do, though. So when you're messing around with these architectures, start as simply as possible and then slowly expand from there. The next thing you have to do is compile your network. This is the last step of building it. It's just one line. There's 2 concepts. I'll get into the optimizer in a sec. The loss function is basically the objective that your network is trying to optimize. The good news here is this is a fancy word, categorical cross-entropy. But what it literally means is your network is going to make a prediction. So you feed an image of a 2 through your network. And it gives you a probability distribution over all the digits that it could be. So maybe with 10% probability, it's a 0. With 5% probability, it's a 1. Hopefully, with like 90% probability, it's a 2. Anyway, this is a fancy word that compares the thing the network predicted to the thing you wanted it to predict. And what you want it to predict is all the evidence is on it, too. The other thing is the optimizer. And this is the method which you're going to train the network. The truth is, there's a whole bag of different optimizers you can use. You don't have to worry about what RMS prop means too much, because there are good defaults. So for this type of classification problem, basically, you're always using categorical cross-entropy. And RMS prop is a perfectly good optimizer to start with, using all the default parameters. So there's good defaults. Broadly, the way the network is trained is using gradient descent. So here's how I would think about this. What a neural network is, when we add those dense layers, there are many different weights connecting the pixels to the neurons. And you can think of all those weights as a parameter. So here's the simplest example that I had in my head. If you think of linear regression, line fits the data, and you can look at your error. And there's different ways to get your error, but maybe it's the sum of the distance from your line to the pixels. So by adjusting M and B, you can find the best fit line. Neural networks are trained in a similar way, except instead of M and B, you've got hundreds of thousands of parameters that you're trying to learn. And these parameters connect the pixels to the neurons and so on and so forth. And the way they're trained is using something called gradient descent. And there's a fancy diagram on the right that's showing something that's not relevant. But they all start at random values, and you slowly adjust them over time until the network becomes better at recognizing digits. Anyway, I'll point you to more educational resources in a sec. So here's the cool part. Building your model is where there are many, many machine learning concepts that you have to spend a lot of time learning. The next 3 steps, they're literally concepts that are basically involved with running an experiment. So here's the only parameter. So here's how you train the model. So it's one line. Fit is synonymous with train. And we're training it using the training images and the training labels. Here's the only parameter that really matters. And the good news is this concept is a little bit simpler. So epochs basically means an epoch means one sweep over all the training data. So we have 60,000 images. One epoch basically means that we're training the network on all of those once. Training a network is a little bit like tuning a guitar. So think if you have a guitar, and it starts untuned, and you want to tune the strings to hit a particular note. So you start tuning it, and like every time you twist the wheel on the guitar, you can think of that as an epoch. And you tune for a certain number of epochs until the guitar plays the right note. If you keep tuning past that point, it's no longer going to play the right note, and eventually the string is going to snap. So you have to stop tuning it at a certain point. And you stop tuning it based on the sound. Neural networks are exactly the same way. So there's basically one very simple plot, and it's this, which I'd recommend you look at while you're training your networks. On the y-axis, we're seeing this fancy thing called loss. That basically means error. Loss is the same thing as error. It's just a fancy word for it. What we're trying to do is minimize our error. On the x-axis is how long we're tuning the network in terms of number of epochs. The longer, if you notice, after a few epochs, the loss reaches a low. That's kind of when the guitar hits the right note. If you keep training, the loss will start increasing again. So to find the right number of epochs, you literally make a plot like this. You just plot your error. And then you take a look you look for the point of lowest loss, usually in your validation data. After that, you can evaluate it. And evaluate just means, given some new data, classify it with my network and take a look at the accuracy and other metrics. That's also just one line of code. And as called, this will give you your loss or your error and your accuracy. When you train the model, you can specify other metrics that you'd like returned. And then to make predictions on new data, it's also just one line of code. So there's some syntax here. So you can say model.predict, and you give it an image. The syntax here is a little funny. As it happened, the model expects what's called a batch of data. And a batch just means it's meant to predict on multiple images at once. So you give it an image, and you just wrap it in a list. And this is just syntax to make it happy. But we're making predictions on the very first image from the test data. And what the model gives you back is probabilities that that image corresponds to all the different digits. And basically, at the very lowest layer of the network, you'll have evidence sitting on all the output nodes. And if you do numpy.argmax, so you just find the largest element, that will be the prediction. So here it's predicting that it's a 7. I'm going to give you a really quick overview of TF data, and then I'm going to hand it over. Here's something to be aware of. In TensorFlow, there's many different ways of doing things. You should always do the simplest possible thing that's adequate for your problem. So never, basically, when you're starting with ML, and in probably 90% of settings, don't worry about performance. Just try and minimize complexity. So before, we wrote our hello world just using the MNIST data in NumPy format. That's fine. If we were working with a much larger data set, or if we were reading images off disk, or if we were pulling them from the cloud, there's a lot of complexity there, and performance starts to matter. For example, there's latency when you pull images over a network. So maybe you'd want to hit a bunch of different servers at once, or maybe you'd want a bunch of different threads. So TF data has all sorts of functionality to help you with things like this. Also, one funny thing that's happened, so GPUs and TPUs have become surprisingly fast. And the latency in training a lot of models is actually, can you keep the GPU fed? There's something called GPU starvation, where the matrix multiplier is so fast that it's just sitting around waiting for data. And so TF data has lots of utilities to get your stuff, like prefetching it to the GPU if you need to. Anyway, what we're going to do here is hello world. So we imported MNIST just from Keras. And just for demonstration purposes, I'm going to wrap it in a TF data data set. So I'm creating a data set from tensor slices, which is a fancy word which basically tells it that, hey, this is a list of things, and I want every element in the list to be an item of my data set. The next thing you can do, it has this very nice, clean API. I can say I also want you to shuffle the data. Here, TF data is designed to work with potentially very long lists of things. And it could be an infinite stream of data. You don't want to shuffle the whole stream. So shuffle has a size for the buffer. So here I have a buffer of 1,000 elements, and I'm going to just shuffle them as they stream in. And then I can batch it up. And that means when I call this data set, I'm going to get back a batch of 32 things. And so now I want to show you very briefly how do you use it. So to use it, what you can do, and this is the complete code, by the way. You can just say, like, for images and labels, print them out. So this looks obvious to me, and it's the way things should work. But if you're new to TensorFlow, it didn't used to always work this way. So if you have previous experience in TensorFlow, you can take a look and you notice nowhere in this code is there a session. There's no placeholders. I'm not mentioning the word graph. I'm just writing regular Python code, and the thing just works. So this is eager execution. In TensorFlow 1.8+, the only thing I have to do is the second line of code there. It's just I enable the thing. You need to do this at the start of the Python file or notebook. And now you're basically running TensorFlow eagerly, which, if you're starting out, it's just regular Python. And this is the right way to use TensorFlow. It makes debugging much easier. There's lots of reasons why you would use graphs, and we still love graphs. There's great talks from the TensorFlow Developer Summit that will go into them in lots of detail. But at least when you're hacking, definitely do this. Okay, so for more context on all of
Traditional programming. And in traditional programming, you feed in the rules, you feed in the data, and you get answers out. So for example, if you're writing something like an activity detector, am I walking, am I running, am I biking, am I driving? You know, you'd feed in rules about that, probably something based around the speed, right? I'm a very slow runner, so if it's detecting something going at 1.5 miles an hour, you know, it's detecting me as running. But I know Josh is a really fast runner, and you know, so it would probably think he's on a bicycle if you're using my rules. Those kind of things. You're feeding those data, you're feeding those rules in, and this is what we've been doing for years as programmers. But when it comes to machine learning, you've got to kind of flip the axis on this a little bit and change it to this. So when it comes to machine learning, this is all machine learning is. You feed in the answers and you feed in the data and you get back the rules. So when we talk about training a model, when we talk about like building these models, what we're ending up getting is this binary blob that you can run inference on. And this binary blob that you run inference on is effectively got those rules that will give them, you know, that will give what you need back out to you. So for example, in my example of activity detection, you know, if I walk a lot and tell it that I'm walking and it's measuring my sensor data when I'm walking, and if I run a lot, which would be really nice, right? And if I run a lot and like feed in the data, and if I bike a lot and drive a lot and go on trains and go on airplanes, you know, these kind of things, and feed in all this data and feed in the answers, telling it, okay, right now I'm walking, right now I'm biking, right now I'm on an airplane. Then the idea behind machine learning is it will build that binary blob for me, which I can then run inference on. And by running inference on that, then it's like, okay, what am I doing right now? And it will deduce what I'm doing right now from all of these rules. And so instead of me trying to write all this if then, if then, if then, if then, you know, I train a system with data and with answers, and it gives me back rules. So let me give an example of this. So what if we wanted to build something that would determine from a picture what's a cat and what's a dog? Okay, now if I was doing this with if-then rules, I could probably do something like, you know, if it loves you unconditionally, no matter what you do, it's probably a dog, right? And if it's right now plotting your murder, it's probably a cat. But right now, it's really hard to infer that from images. So I couldn't think of what the if-then rules would be. Like sometimes, like you might have an image say, well, if it's got pointy ears, it's a cat. But guess what? This dog has pointy ears. So you know, this is where we start thinking about. This is where machine learning starts opening up these new scenarios and these new ways that you, as a programmer, can bring value to your employers and to your business. So let's talk about the answers in this case. Okay. So the answers here is like, you know, this is a cat, right? You know, and this is I think it's a dog, right? Okay, and this has got really pointy ears, this little guy, but this is clearly a cat. This is a walking tongue, but it's also a dog. And this one is what happens if you feed a mogwai after midnight, I think. But this is actually one of the dogs in this set of cats and dogs. So like, you know, here, you know, I've got the data, and here I'm giving the answers. I'm telling the machine what all of these things are. So now, if I wanted to, as a programmer, all I have to do is train a neural network by giving it the answers, we call them labels, and giving it the data. But as a programmer, here's where it was tough for me, and I've only very recently been on TensorFlow, because what is it? You know, first of all, I have to start working in Python. Any Python developers here? A few of you. It's a lovely language, but you tend to work in a text editor instead of an IDE, and things like step-through debugging, because I came from a background of like Visual Studio and Xcode and Android Studio, so it was a big learning curve for me to get into that. And then with, if you started TensorFlow with graph-based execution, it was very strange, because you'd have all your code would like load up a graph, and then you'd execute that graph, and it's like, but what if I've got bugs in like reading my data, or if I'm not reading it properly, or if I haven't shuffled the data properly? And it's really important, as Josh was mentioning earlier on, to shuffle your data properly, or you can insert a bias into your actual training. And I'm not a very good programmer, so I generally like to write 2 or 3 lines of code at a time, step through them, make sure they work, then write another 2 or 3, step through them, make sure they work, and that kind of thing. And that was really difficult for me to do as a TensorFlow developer. So if we can switch to the laptop, I want to show why I'm really excited about eager mode. And the screensaver kicked in, sorry, I'm just signing in. So why I'm really excited about eager mode in TensorFlow is I've taken, and Josh has written a notebook with this cats versus dogs, so you can go and get this code online and run it in the notebook. But right now I'm running it in PyCharm. because, like I said, I'm not a very good developer. So I want to write a few lines of code, execute them, write another few lines of code. And PyCharm, if you're not familiar with, there's a free community edition, which is what I'm running here. If you've used Android Studio, it probably looks very, very familiar. And what I can actually do is I can go in and I can say run debug. All right, and then I'm going to go and I'm going to debug, and I'm going to debug cats versus dogs, and it's going to start executing, and look, I hit a breakpoint. You know, it's like this to me is magical as a developer. So now when I've hit my breakpoint, I can start stepping through my code and see what's going on in my code. So you know what, I've hit another breakpoint, I've set another breakpoint down here, so I'm going to execute my code down to that breakpoint. And now when I start stepping through this, I can start seeing that I'm doing things correctly. You know, like, okay, my data directory is set up properly, and I've defined my labels, and you know what, I'm going to put another I'll leave that breakpoint there, and I'll run down to this breakpoint, and I can start looking at what's going on in here. So I have my training images, and if I hover over that, you see it's like it's a little too big to print, but when I look at this in the debugger, I can now start seeing that. Look, I've started loading up these arrays of images, and I can see the image 0 here. Sorry if it's a little small, but image 0 here was cat number 921. And so if I then keep stepping through, and this is what eager execution is giving me. Whoops, sorry, I hit a break. I hit a breakpoint I didn't want to hit. So I'm just going to go down to here and continue running. All right, so, and if I then step over this, it should show me a cat. Okay, so like, okay, I've gotten this cat, I'm loading it in, but is this the right cat? You know, have I written my code badly? Have I got the wrong cat? So I can go, hey, look, you know, here's my training data. I can go look at my cats. I can find cat number 921, and hopefully it's the same cat, so I know my code is working right. You know, anybody else develop like this? You like to do it in little steps? Oh, good. It's not just me. Because I find it really, really difficult to write a lot of code in one sitting, so I just got to do it baby step by baby step. And cat number 921 is here, and there it is. It's the same cat. So I'm like, excellent. I know my code is working. I know I'm loading properly from my data. And I'll go through here, and I can see, you know, my load image code. What it's doing is it's reading the image, it's creating a tensor out of that image, it's resizing it to like a smaller image that we're going to use in training. And when you come from a world where like the hello world in machine learning is handwriting recognition, you know, for me, hello world was sprintf hello world, you know, that there's some very complicated scenarios and some very complex scenarios, but this breaks it down as a developer, and I can start poking through, I can start looking at data in the IDE, and I can understand really what's going on. So what I'm going to do is I'm just going to execute my code a little more.
And a really cool point about this, too. So this load image function, if you look at it, it's using TF operations. So we're saying like TensorFlow.readImage. And these are working exactly like they would work if you were using NumPy. Because we're running eagerly, this code is imperative, and it executes right after you hit the line. Also, you notice when Lawrence, which was really cool, hovered over it, and you can see the data. You can see the data, and it's concrete, not symbolic, because we're running eagerly. So.
And of course, if you're you know, in Python, you like to use the console as well. One of the nice things in PyCharm is that I've got a console window, so if my existing code is printing out to the console, I can do that. I'm just going to step a little bit further down, and I want to go just to the training. And one of the nice things that Josh was talking about is that this is just an iterator in Python. And you know, I can now step through, and I can take a look at what's going on in my training. I can look at this batch by batch. So if I've got 6,000 images that I'm loading in, I've split that into smaller batches. And then once I've done all of those batches, that's an epoch. So now I can just go through, and I can look at my actual epochs, and I can look at my training, and I can step into it, and I can see what's going on as I step.
This is great. Another quick point, too. To show you how fast these APIs are evolving, you'll notice that we're actually getting the NumPy value of the images and the labels.
Yep.
As of, I think, a few days ago, that's no longer necessary. So you can fit Keras models using tf.data datasets. So you no longer need that intermediate step, which is great.
But thank goodness it still works.
Yes, it still works. Yes.
And one of the really neat things about it, of course, is because TensorFlow is open source. If you want to know what's going on with your training, maybe something is going, maybe you've loaded data that's causing it to crash or something along those lines. As you're doing this and as you're executing these things, let's see if I can do it, you know, and I'm going to hit pause at some point, and I've now jumped into the TensorFlow source code. So not only can I step through my source to see what's going on, I can actually jump into the TensorFlow source. So maybe I've done something to trigger a bug in TensorFlow, or maybe I'm doing something wrong and TensorFlow isn't handling it properly and I can fix it and then contribute back to TensorFlow. So all of this has been made possible by eager execution in TensorFlow with Python. And as Josh mentioned, all you got to do is use TensorFlow version 1.7 or later and set up that executing eagerly. Can we switch back to the slides now, please?
Yeah, so cryptic error messages are mostly a thing of the past.
So your third promise, Josh.
Oh, yes. Thank you very much.
Thank you.
I like PyCharm a lot. I spent a long time in Eclipse before, yeah. Anyway, so to learn more about these concepts, so I'm going to recommend 2 educational resources. So first is we have a machine learning crash course. It's pretty good. It's short. So this is probably maybe a day or 2 days of your time full time. This won't teach you all there is about ML, but it's a very solid, thoughtful introduction to what is loss, what is gradient descent. Next, I'd like to recommend a book, which is by a Googler, and I'm going to badly mispronounce his name, but the author of Keras, Francois Chollet. It's a wonderful, wonderful book. It's called Deep Learning with Python. There are many, many books with very similar titles to Deep Learning with Python, but the one you want is written by Francois. It's published by Manning. And it comes with a collection of Jupyter notebooks, which are all freely available on GitHub, by the way, that will basically teach you how to use Keras. Because Keras is part of TensorFlow, all of that code will work with no changes other than the imports directly in TensorFlow. And that will give you a really solid foundation in Keras. And then later, if you're interested, you can learn how to use things like TF-data and other advanced features of TensorFlow to do even more. But it's a wonderful starting point. So takeaway, another thing too. So I wanted to also show TensorFlow.js in this, but we only have 40 minutes. With the Keras model, you can literally do model.save. It's one line of code. You'll say model.save and like foo.some path or whatever, foo.hd5. Now you've saved your model to disk. Using TensorFlow.js, if you go to js.tensorflow.org, they have tutorials that show you how to import relatively easily that saved Keras model into the browser. And so the same API is compatible across these platforms. So basically, links, check out Colab. Regardless of you're using TensorFlow or not, Colab is a really, really valuable resource. It's also wonderful in educational contexts. You know, if you're teaching after work or anything like that, students can just jump right in. Check out the workshops. In the next 3 months or so, we're going to be updating a lot of our tutorials in tensorflow.org to use Keras. But in the meantime, I'm just hacking some samples together so you can see what this looks like. TensorFlow.js, and we have an education website.
And some really fun demos on js.tensorflow.org.
Yes.
Like, there's one where you can actually train it to recognize your face going left, right, up, and down, and then you play Pac-Man by going like this. It's really cool.
It's super cool.
Yep. So take a look, and it's open sourced.
Yeah, so thank you very much, everyone. I know it's early. We'll be around afterwards for as long as you want to take questions. Really appreciate your time and hope this stuff is useful to you. Thanks.
Thank you.
That is not good. And in fact, we can track this. And we know that a significant percentage of media that starts playing when a user first visits a site without them interacting with the site at all gets shut down within 6 seconds. And that's shut down either by a pause or closing the tab or muting or doing something like that. We recently launched a new policy in Chrome to address autoplay. The policy applies when the user first arrives to the site. So this does not take effect after they've interacted with the site. If they click on the site, if they tap on the site, the autoplay policy is not being applied. But the policy applies when a user first arrives at the site. When a user arrives, muted autoplay is always allowed. So if you're wondering, okay, what can I safely do? The answer is you can do things that don't play audio. And if you have a video element, you can play it. There are a few cases where you can also play audio when a user first arrives. Of course, after a click or a tap, it's fine. You can play audio. But when a user first arrives, there are a couple of situations where you can play audio. The first is if your app is a progressive web app on mobile, and the user is launching it or has it installed from the home screen. In that case, when they launch a progressive web app, autoplay with sound is allowed. The second case on desktop is that Chrome is learning which sites users go to, and it looks to say, okay, wait a minute, if a user is going to this site and playing media most of the time they visit that site with sound, after a click or a tap, they probably want media with sound on that site. And so over time, as the user browses, Chrome will identify those sites and say, okay, we'll allow autoplay on a site where the media is usually being played with sound. This is actually an interesting case where Chrome does have the ability to personalize the experience for the user. And in fact, we launched this a few weeks ago, and as I mentioned, we get a really strong signal about autoplays that are not wanted. We know that the ones that are shut down quickly are the ones that users don't want. And when we looked at the results after this launched, what we saw was that about half of those autoplays get blocked. Now, that's not 100%. That's about half. Now, why only half? It's partly because Chrome is learning, and it doesn't always get things right. But it's a massive user benefit. I mean, we just cut out half of unwanted autoplays when users first go to sites. But for you, the developer, what this means is that you cannot always expect that audio will just work if you start playing it when the user arrives at a site. What this means is that when a user lands on your page, you will not know whether autoplay with sound is going to work until after there's a user gesture, a click or a tap. After a click or a tap, you're fine. But when the user first arrives, you won't know. If you're using a video or an audio element, the way to detect this is to look at the results from the play promise. You can tell by looking at the results whether or not autoplay started, and if it wasn't, if you tried to autoplay something with sound, you know that you can then try to play without sound. If what you're doing is hosting embedded videos, so videos that are in cross-origin iframes, and you want them to have the ability to autoplay in situations where they're allowed to, you'll want to add a new attribute to the iframe, the allow equals autoplay attribute. Now, this does not mean that embedded videos can always autoplay. What this means is that if you have an iframe on your site, and your site gets the ability to autoplay, then the iframe will get the ability to autoplay. If you do not include this attribute, any embedded videos in that cross-origin iframe will not be allowed to autoplay. Even if they say, we want to autoplay, they will not be allowed to do it. The policy will prevent that. So if you're embedding videos and you want them to be able to autoplay in sound when Chrome would allow it, make sure to use the allow equals autoplay attribute. The final topic I want to talk about here is web audio. What we're looking at here is an example of a web audio site, and it's reasonably typical, which creates the audio context on load. That's the top half of the code up top. Now, what the assumption is here is that audio will always work when the user first arrives at the site. And as I said, that's no longer a valid assumption. Now, the good news is that what will happen under the hood is something that you can react to with only a small change. If you start an audio context and you don't know whether or not it's running, what you can do is look for a user interaction on the site, a click or a tap, and then call resume on the audio context. At that point, the audio will continue to work. The other thing you can do, and I don't have the code sample up here, is you can actually check the state of the audio context to determine whether or not it was blocked by the autoplay policy. Check the state. If it's running, then audio is playing. If it's suspended, then it's not. And that gives you an opportunity to do things like update mute controls to reflect whether or not audio is actually playing. I want to pause for a second to say, our team is working very hard to improve things for both users and developers. As part of that, I want to acknowledge that we could have done a better job of communicating this policy change to developers who are using the Web Audio API. If you have any questions on this particular change, we are available both at the Web Audio office hours at 12:30, and in addition, we have media office hours today at 6:30 and tomorrow at 1:30. And if you're not here at I/O, if you're watching at home, or if you want more information about the policy changes, the link on the bottom on this slide has everything I just talked about. It also has more information that you will want as you're debugging your website, including instructions to completely disable or completely enable the autoplay policy so you can try out the different user interactions and different experiences. If you don't have this link, or if you don't get a picture before I move to the next slide, you can also go to developers.google.com and search for autoplay. Now, let's talk about what we recommend as far as what the user experience should look like. The ideal situation, from our perspective, is that when users arrive, and if you're not allowed to autoplay with sound, mute the media and play it to drive user engagement. And then, when you get a user gesture, ideally give the user a control where they can unmute the media and they can turn on the sound. Tapping or clicking on that control will give you autoplay policy, and it will allow you to start playing with sound. Another alternative is to move to a click-to-play model, so capture a user gesture and then start playing sound. This is common. We've seen this for a fair number of video sites. It will also work under the current policy. And that's it for autoplay. So now let's switch to Jennifer, who's going to talk about something completely different, which is multitasking.
Thanks, John. Hi, my name is Jennifer, and I'm a software engineer on the Chrome team. We've always multitasked while consuming media. This could be anything from watching a movie while responding to emails, to listening to live sports commentary while cooking. In fact, some of you on live stream may be tuning in while doing something else. Now, as we started to spend more time on our devices, multitasking has evolved, where the screen that we're using may also be the media screen, or at least the one used to control it. Last year, we introduced the Media Session API, which allows you to show metadata and images on lock screens and on wearable devices. This experience is great for users because they'll know what's playing and they'll also be able to control it. So let's take a quick refresher on how we can use it. First, we'll check to see if the device or browser supports Media Session, and if so, we'll use it. To make things appear, we simply need to provide the metadata, the title, artist, album, and artwork. And that's all you need to customize the media notifications for your web app. We can also set up action handlers to respond to these controls: seek backward, seek forward, play, pause, next track, and previous track. We may also want to control the playback state. So if you're serving custom controls, you can also reflect the media session state outside of the lock screen or the notification. Now, what about the desktop experience? Personally, I spend the majority of time on the computer consuming media. At the same time, I like to keep busy, such as messaging friends or reading the news. I find that whenever I want to watch a video on the computer, I'll resize the window to be really small and then move it to the corner of the screen so it doesn't get in the way of everything else I want to do. At the same time, I struggle with inevitably covering that window with one of the many other windows that I have open. Sound familiar? Today, I'm excited to share that we're bringing picture-in-picture to Chrome. The floating window will appear on top of other windows, allowing you to consume video while continuing to interact with the other content on your device. You'll also be able to interact with the window, such as with the play-pause controls, resizing, and moving to the window to your liking. You may remember that last year, we launched picture-in-picture on mobile with Android O with the native API. Today, we're building a web API that will allow developers to create and control the experience around picture-in-picture. This will be available for Chrome, on desktop, and on Android. So let's take a look at how we can use this. First, we'll need two things. We'll need the video, and we'll need a way for the user to interact with it. Today, we'll use a button. To start us off, let's enter picture-in-picture. We'll start by adding an event listener to our button. And when the button is clicked, our video will request to enter picture-in-picture mode. But why stop there? Let's make this button toggle entering and exiting picture-in-picture. We'll first check to see if the document's picture-in-picture element is our video. And if it isn't, we'll send a request to enter picture-in-picture mode. Otherwise, we'll leave, which means that the video will appear back in the original tab. The request picture-in-picture function returns a promise, and when if our video fails to enter picture-in-picture mode for any reason, we should let the user know. Showing the user feedback is a great way of letting them know what's going on. We can also listen for two events: enter picture-in-picture and leave picture-in-picture. By setting event handlers, we can define the experience for our users, such as showing other content on the page more prominently. This could be anything from showing a catalog of videos that the user could later watch, or surfacing a live stream chat. And finally, in cases where picture-in-picture is not supported, we can hide the button so that the user doesn't try to interact with it. While picture-in-picture is still under development, you can check it out today on Chrome Canary with these flags enabled. The first one will enable the access to the web API, while the next two will be used to enable the feature. You can also find out more about the API and implementation status at these links. Now let's say we have multiple screens. Imagine if you were presenting in a meeting and you wanted speaker notes, or you wanted to share photos and videos to a large group of people, but you only had a small laptop. Presentation API makes displays such as monitors and TVs available to the web. Previously, this was only available for remote devices such as Chromecasts, but today we now also account for wired displays such as HDMI monitors. With Presentation API, we can build experiences for our users to see and control local content while presenting something else on the other screen. And in other words, we won't just be mirroring what's on our screen to the other monitor. Let me walk you through how to use the Presentation API to present a web page on a secondary screen. There are two components needed to get this to work: the controller and the receiver. The controller is the page that we'll use to interact with on our primary screen, while the receiver contents will be displayed on the other screen. And today we'll call these components controller.html and receiver.html. So let's start by putting together a controller page. First, we'll create a presentation object, which will contain the URL that we want to show on our secondary screen. This could also be an absolute URL, or we could also pass in a list of them. But today, we'll just use receiver.html. With our presentation request, we can get the availability of the displays, or the second screens, and handle them however we want. We should also continue to handle display availability changes by adding an event listener for the change event. This might happen when monitors are disconnected, or we move to a network without devices. To show a presentation display prompt, we require a user gesture, such as a click on a button. And with that in mind, let's start a presentation request when a user clicks on our button. We'll wait for the promise to resolve once the user selects a display. This promise will return a presentation connection, and when that happens, the page that we passed in earlier, receiver.html, will be presented to the other display. Once we have this active connection, we can do two things. We can either close it or we can terminate it. Closing the connection allows us to reconnect later, and terminating the connection means that it's gone for good. So how do we reconnect to our presentation? We do this by simply calling reconnect and passing in the presentation ID of the previous presentation connection object. And there are two options of how we want to handle this. We can either automatically reconnect when the controller navigates, or we can reconnect when the user clicks on a button. We can also register event handlers for the presentation connection events: connect, message, close, and terminate. And with that in mind, we now have the components ready for our controller to work. Next, we want to have the controller and the receiver interact with each other. So on the receiver side, let's first retrieve all the existing connections and listen to any incoming ones. And we'll keep track of these as they come in. Every time we add a connection, we'll add event listeners, such as message and close events. And so what does this look like put together? Our team published the sample web app called PhotoWall, which showcases the presentation API. We use a controller to select photos that we want to add to a slideshow, and we use a receiver to present it. To get us started on the controller, we'll use the presentation request and retrieve the list of receivers. We'll then select one to create a presentation connection. And once we're connected, the controller will prompt us to add images to the slideshow. And what's more interesting than searching for photos of dogs? Here, picking a photo will add it to the queue of images to share on their slideshow. And how do we get that information to the receiver? Calling connection.send will send a message between the controller and the receiver, and vice versa. This message could be a string, a blob, an array buffer, or an array buffer view. And in our example, the controller will send the description, or the name of the dog, as well as the image source to the receiver. Upon receiving this message, the receiver will then handle it by updating the slideshow to include the image. So what happens when we send Peanut, Nuka, and Elsa to the receiver? We'll get something like this. And that's all you really need to get started with Presentation API. This API is already available on Chrome, so be sure to check it out. So Media Session, Presentation API, and Picture-in-Picture. We believe that these are all great additions to the web media story. You can check out all the APIs at these links. And we always love feedback, so let us know what you think. Now I'll hand it back to John.
I think I heard somebody go, whoop, for picture-in-picture, whereas I was saying, I didn't know you were putting my face up there. Thanks for that. Anyway, so the Presentation API, and that's actually a really interesting example of how Chrome can work across multiple displays. And so if you have multiple displays, Chrome can use Presentation API. There's another capability in Chrome for doing things with other displays, and that's Cast in Chrome. Cast in Chrome will let you play media or mirror your tab or your desktop to cast devices such as Chromecast or a TV. Now, let's talk about mirroring for a second. The thing about mirroring, like if you're mirroring a tab, what you're doing is you're rendering the tab, and then you're capturing it, and then you're encoding it, and then you're sending it over to the remote device. And if you're playing media, that's an awful lot of work just to capture the media, grab it, encode it again, send it over to the device, which is then going to decode it. There's been an important change here, which just landed in Chrome. During tab mirroring, if the user goes full screen with a video, Chrome will send that compressed video directly to the device. And that eliminates most of the steps that I just mentioned. There's no need to decode, there's no need to capture, and there's no need to encode. Chrome is still in the middle. It's sending the video frames directly to the device, though, without modifying them in any way. From a user perspective, they'll still have playback control in Chrome like before, but instead of the video playing on their local display, they'll see this. Now, this is good in most cases, but there are some cases where you won't want Chrome to remote a full screen video. For example, if you're doing 360-degree spherical video, what you're likely doing is taking a canvas and rendering with WebGL on top of it a piece of geometry with a video mapped onto it, and that's good. Behind the canvas, some of you might have a full screen video element which includes the entire video, which is effectively a texture map. And you probably don't want that video to be sent to the television. If you see this on your site, it's very easy to prevent it. There's an attribute you can add to any video element called Disable Remote Playback, and Chrome will respect that. So if you don't want media remoting to work on a video element, add this attribute. So why are we doing this? Well, it's because it's a significant optimization and it happens automatically. If you look at the middle metric, you can see that the CPU consumption goes down dramatically because we're skipping a decode and a compression step entirely. If you look at the top two metrics, especially the top one, you can see that playback smoothness increases significantly and freezing gets better as well. And then the bottom two metrics show that the video quality itself gets better because we're not decoding and re-encoding the video. The less that Chrome touches the video, the better, and it lets you send the original compressed video directly to the device. Now, of course, that original compressed video is only going to be good if your settings are good and the algorithm you're using for compression is good, which is a really good segue for me to pass it over to Zoe, who's going to talk about updates on AV1.
Thank you, John. So today, I'm going to talk about the new video codec, AV1. Video has been one of the significant experiences over the web, and that has been mainly manifested by the extensive bandwidth usage by the users. compression are the technologies behind the scene that power this growth. So why video codec mattered? Let's look at an example. Here is a 5-minute high-definition video with the size of 300 megabytes. This is what we observed. Indeed, it's a compressed version, as opposed to its uncompressed version, which is as large as 25 gigabytes, almost 100 times large. For a 4K video, it could be even 10 times larger. Therefore, compression are the technologies that is requested. Without compression, there's almost no possible for any video service over the internet, and our users notice the result. Back in 2013, Google rolled out its previous video codec, namely VP9. As opposed to, at the time, state-of-the-art codec 8264, VP9 has achieved on average 30% performance gain. So here is a global map of the YouTube watching time of VP9 compared to that of 8264. As can be seen from the slide, the darker of the slide, the darker of the color is the longer watching time attained by VP9 as opposed to 8264. The reason for longer watching time of VP9 are mainly threefold. First is the faster loading time. Secondly, it's a lot less buffering. And thirdly, which is the higher quality delivery. So the success of VP9 has been responded by our users with their longer usage. The success of VP9 has not gone unnoticed. The most recent video codec has been developed by the so-called Alliance of Open Media, short as AOM. They named its first-generation codec as AV1. AOM, as can be seen from this slide, has included the top media and technology in companies from almost every aspect of the industry. So here you can see we have the web platforms, content providers, and hardware makers. There's three goals of AOM to develop AV1. First, we want to develop a codec for the web, even though that has been increasingly overlapped with the TV, security media, and all the other industries. The second target of AOM for AV1 is to have open, royalty-free codec. This is a significant change for the industry that has been mainly scarred by patents. And the last goal of AOM is to have a real deployment. So it's targeted to be supported widely across all platforms and to be developed at a much faster pace. So here's a landscape, pretty complicated, because that represents one of the major areas that we have been touched during the development of AV1. We have developed over 100 compression technologies for AV1. Today, I'm mainly going to talk about two of them. We're going to have a little bit deeper dive of the following two technologies. The first one, we name it as wedge-based interprediction. Let's look at an example. So here's a clip from here's a frame from a video clip. And there's the next one. So for these two successive frames, it can be seen there's a lot of similarity between them. The major task of a video codec is to remove the similarity between them. One of the most commonly used tools is called block copying. So you can simply copy the pre-block for the current one to achieve a compression ratio. However, you look closely, this shape of the block, which is square, is not aligned well with the object boundary. So if you look closely, somehow, if we can introduce a wedge-based shape, which can be a lot better aligned with the boundary of the object existing in the frame, there could be a lot of potential that we can obtain a further compression gain. Therefore, here comes the compression technology that we refer to as wedge-based interprediction. This is the first time that has been introduced by the video codec. AV1 for the first time introduced both the square-based and rectangular-based wedge codebooks for the interprediction. Because it's better alignment with the boundary of the object, as we just showed, there is a significant gain that has been obtained. The next tool we're going to talk about is about the warp motion. Let's look at another example. So here is a frame, again, from a video clip. And there's a rotation for the next frame. So how do we describe this rotation? And then to obtain a compression. So the general user tool is to describe the motion info of all the blocks that covers this rotated object. It can be, there's a lot of information that we need to signal. If we look closely, there's another way. If somehow we can only signal those motion info for those blocks located in the top left boundary of this rotated object, well, if there's a way that we can derive the motion info for all the remaining blocks of this object from the surrounding blocks within the causal window, there could be a lot of potential for us to obtain a better compression. There comes another tool introduced by AV1 named local warp motion. So AV1 has used a mathematical model here as an example, a fine model, to first horizontally and then vertically derive the motion info of the current block from those motion info of the surrounding block within a causal window. In this way, a more effective and efficient compressed technology are obtained so that a better code gain can be achieved. So summarize all the technologies that we have introduced in AV1, here's the result. To compare AV1 with its predecessor VP9, generally, there's a gain of 30% performance improvement for AV1 for both two scenarios, the video on demand and the live streaming. Here's another presentation of this result as for comparing AV1 as opposed to VP9 obtained by Google. An independent evaluation has been conducted by Facebook, mainly on top of their user-generated content uploaded to their Facebook website. A consistent gain has been attained and achieved can be observed from this slide. Furthermore, you can observe that with the increment of resolution, a larger advantage of AV1 can be observed as opposed to VP9 and another state-of-the-art codec H.264. It can be expected that AV1 can have a larger gain for larger resolution. A last evaluation that we are demonstrating down here is conducted by Moscow State University. MSU indeed rolled out an extensive comparison result report for almost all the top video codecs they collected. They usually conducted a very extensive comparison, especially considering different categories, such as the encoder speed, the quality metrics, as well as some of the rate control strategies, and also the algorithmic performance of the codecs. This year, they include a comparison with AV1. As can be seen closely, they report a consistent result for the advantage of AV1. Next, I'm going to show a demo to compare AV1 as opposed to VP9 encoding the same video clip to achieve the same quality level. So the left part is encoded by VP9, the right is from AV1, and the result of compression are shown in the slide. I think everyone has observed the light speed rate that has been resulted from AV1 as opposed to VP9. And the current status of AV1 is we have already selected all the coding tools, and we have frozen our code base, and we have released our spec. The next step, it is expected that Chrome will support AV1 later of this year, and for the hardware support, it is expected in 2 years, in the year of 2020. For everyone who's interested in the AV1, you're welcome to visit our website shown this slide. From there, you can download the code base, as well as you can access the details of the specs. Because we are open source community, you're welcome to evaluate as well as to contribute. Next, let me hand it back to John.
Thanks, Zoe. AV1 is pretty fantastic. We're really excited about the bitrate savings and the storage savings that it is going to offer. And we're also really excited for it to start rolling out. But at the beginning, it won't be available everywhere. And in fact, if you look at even VP9 and H.264, there are varying levels of support for codecs, where some devices do hardware decoding, other ones do software decoding. And this can affect how smoothly and power efficient the video decoding can be, how efficient the playback will be. Fortunately, there's a new API available that will let you detect this ahead of time. And then what it lets you do is ask the browser not just whether decoding is supported, but how performant it will be. Let's see how it works. So in this case, what we're going to do is create a media configuration, and we're going to test Opus Audio at stereo and VP9 video at 1080p. And what we'll do with this media configuration is we'll pass it in to the Media Capabilities API and ask it for information about the decode. Now you can see that you get 3 values back. The first is, can it decode? In a lot of ways, this is kind of similar to can play type, but it gives you a strong signal as to whether or not the codec is even supported. The other 2, the second and third, smooth and power efficient, are brand new, and they're really exciting. They will tell you whether or not, for example, is it going to be smooth? Can the GPU or the CPU keep up with the resolution and the frame rate that you're going to be providing it? It's really new, and it can make a big difference. How much of a difference? Such a big difference that YouTube ran an experiment with the API, and what they found was that by surgically adjusting the experience for just a few users, the improvement was so big that it affected the overall average across all users. So let me explain what I mean. You can see that it improved mean time between rebuffers by 7%. It improved the rebuffer rate by 10%. Those are big aggregate average changes. But it only adjusted the average video height by 0.4%. What that means is it actually wasn't affecting a whole lot of users. It was only focusing the ones that actually could have used a change, and it improved their experience a great deal. So to summarize, this is worth looking at right now, and it's going to become more and more important as AV1 becomes available. So we've covered a lot of things, and some of you may be wondering, that's a lot. How can I get access to all of it easily? There are a lot of answers to that. I want to cover 2. The first I want to talk about is the open source Shaka player and the packager, which offer an easy way for developers to adopt these best practices. We at Google are constantly updating Shaka, and if you're using it, you're going to get a lot of these new features we've listed here automatically for free over time. For example, recent improvements to the Shaka player with version 2.3 include support for HLS live video and on-the-fly transmuxing between transport streamed and fragmented MP4. This summer, the team is planning to launch a player user interface layer, which will make it a lot easier to deploy the player. On the Shaka packager side, version 2.0 added support for VTT and subtitles. Support for creating content that is ready for ad insertion is also coming in version 2.2. So both Shaka Player and Shaka Packager give you a way to deploy easily, but then also keep up with changes as they roll out and new APIs as they roll out. Similarly, the AMP team has been working to implement many of the best practices and looking at some of these APIs as well. And these are taking effect in AMP Video, as well as other related video tags in accelerated mobile pages. On the user interface front, Rotate to Full Screen is already done, and they're working on in-page docking, which will be coming soon. So again, this is another way that you can get a really great video playback experience without having to write everything yourself. For both Shaka and AMP, the goal is to make it easy, so they're both worth looking at. More generally, as I mentioned before, this really is the decade of video, and as consumption patterns are changing and they're evolving, it does mean there's API changes and new APIs to learn, but it also means that you're going to have more meaningful experiences for users, and we'll see watch time continue to increase, whether it's picture-in-picture or offline playback or cross-device playback. And this gets even more exciting when you layer video compression advances on top of it, where you don't need as much bitrate to get great quality, or you can send higher quality video at the same bitrate. And you also don't need as much storage on the device if you're doing offline video. We are really excited about what's coming. It's a very exciting time to be in media, not just as things become higher quality, but as some of these new use cases evolve and people start consuming in new and exciting ways. So with that, thank you very much for your time. As I mentioned before, we have web audio office hours tomorrow at 12:30. We have media office hours today at 6:30 and tomorrow at 1:30. And we will also be available for questions at the web sandbox. Thank you very much.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot. So it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year. So they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow.js, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning. We want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning as we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision based stoplights that just allow people to go when it's safe to go. And that would be like a simple improvement in the world that would improve lots of people's lives.
Thanks for joining me.
Thank you.
And thank you for watching I/O Live. To learn more about what Google is doing in AI and ML, head on over to google.ai. And to catch more videos like this, head on over to g.co/io/guide.
Cassava is a really important crop. It provides for over 500 million Africans every day.
When all other crops fail, farmers know that they could rely on their cassava plants to provide them food.
There are several diseases that affect cassava, and these diseases make the roots unedible. It is very crucial to actually control and manage these diseases.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our solutions. The app that we've designed can diagnose multiple diseases. It's called Nuru, Swahili for light, the light that farmers can use to see their problems and find solutions. You wave your phone over a specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, we have an option for you to get advice and learn about the best management practices.
The object detection that we use through TensorFlow relies upon our team annotating images.
We've collected over 5,000 high-quality images of different cassava diseases for this project. We use a single-shot detector model on a mobile net architecture. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
We need something that can be deployed on a phone without any connection. TensorFlow is able to shrink these neural networks to be able to fit on your mobile device.
The human input is absolutely critical. We're really building something that augments your experience and makes you better at your job.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers the prospect to fundamentally transform the life of hundreds of millions of farmers around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
So the whole point of the AIY projects team at Google is to build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year we released the voice kit, Train Fast, which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year we're releasing the Vision Kit. It does not need an internet connection. It does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow. So this is our MobileNets neural network. This is an object classifier, and it's got 1,000 different common objects in it. We have a banana, and let's see, a screwdriver. Yeah, it's got that pretty good. It's got an apple, not just an apple, it's got the type of apple as well. And even the water bottle, which is tricky because it is a clear thing, so it's not really a thing, it's just reflecting other things. So learning how to use these things and how to make it detect what you want to detect is going to be part of the fun. Our face detector code tells us not only that there is a face in the image, but it also tells us where the face is. It gives us the geometry about the face. So we can use that to build a tracker that can follow me wherever I go. We've shown you face detection, object recognition, and face tracking with the Google AIY Vision Kit. But this is just the beginning. Click on the link below to learn more. We're really looking forward to seeing what you build with this kit.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot. So it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year. So they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow JS, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that.
Hi, everybody, and welcome to the What's New in Wear OS by Google session. My name is Dennis Stroper, and I'm the product director for Wear OS, and I'm really, really excited to be here today. Let me start with a little bit of history. By the way, I need the clicker. You know, when we first started Wear OS 4 years ago, we went out to see what people were wearing. And what we found was a tremendous amount of diversity out there. People really care about what they wear. It evokes their passion, their style, and their personality. The same goes with what you wear on your wrist. It's a really, really personal choice. And so from the start, we made a decision to bring lots of choice and diversity into the wearable space. Today, we couldn't be more pleased how this strategy has played out. We have over 50 watches that are powered by Wear OS today out in the market, from top brands like Louis Vuitton, Michael Kors, Fossil, and many, many others. Let me show you some of the recent launches of watches that we introduced in the market with our partners. Back in the fall, for the holiday season of 2017, Misfit launched the Misfit Vapor smartwatch. The Misfit team did a great job with this watch. Has a very sleek and stylish design. It fits great on your wrist, and it makes for a great fitness watch. Then this past January, Kate Spade launched the Kate Spade New York smartwatch. It's a beautiful watch, and users are really loving the Choose Your Look app that matches your outfit with your watch face. And then this past March at Baselworld, Hublot introduced a limited edition smartwatch called the Big Bang Referee 2018. This is a beautifully crafted smartwatch. Its body made out of titanium, and with a theme that celebrates the most popular sport in the world, soccer. Actually, really excited about this watch. I'm a big soccer fan myself. And get this, referees are going to be wearing the Big Bang Referee at international matches to help them connect with the latest goal line technology. That's really, really cool. So we're really excited about all these new watches that are coming to market. We've built a lot of momentum with our partners. To give you a sense of that, in 2017, we launched 26 new watches. That's twice the number of watches that we launched the previous year. And an interesting stat, we're now seeing a lot of iOS users in the Wear OS platform. This past year, in 2017, we grew 148% year over year in iOS users. And today, 1 out of 3 new Wear OS users activate their watches with an iPhone. And so this is why last month we decided to change our name from Android Wear to Wear OS by Google. We want a brand name that really reflects the great diversity of users that we have in our platform, as well as the wide range of choices of watches that are out there. We're really happy with this new name. Our partners are really happy with it, and our users are loving it as well. So, you know, we've learned a thing or two over the last few years working in the wearable space, and I want to share a key insight with you guys. It's a simple one, and perhaps an obvious one, but the way people use watches today is very, very different from how they use phones. They're very different in how people interact with them, how long they use it, how often they use it, and what they use it for. With a phone, first of all, you carry it with you all the time. And you have 2 hands to interact with it. It has a large screen. And you can spend a long time with it playing games, doing social media, or responding to email. With watches, it's a very different story. With watches, you use it, you carry with you on your wrist all day long, but you use it very sporadically. And when you use it, it's just for very short moments to get some information, and then the faster you can be back doing what you're doing in the real world, the better. So, you know, we've taken these learnings to heart in how we think about our platform going forward. And we're now focusing on 3 very important areas to improve the user experience. Let me walk you through them. First is connection at a glance. Second is health and fitness. And thirdly is convenient help from the Google Assistant. Let's start with connection at a glance. You know, in this day and age, people are expected to be connected all the time. As I said before, we carry our cell phones most of the day, but there are some cases in which pulling out your cell phone is inconvenient, or sometimes we just don't have it with us. For example, when you go out on a run or on a bike ride, or if you go to a fancy dinner dressed in an outfit with no pockets. But in any of these occasions, you still want to be connected to the people and the information that you really care about. You know, I myself, I'm the father of 5 kids. And I also like mountain biking. And I can tell you from experience, having to put my cell phone in my backpack where I carry water is just really inconvenient. Watches, smartwatches, fill this gap really neatly. You know, they're very easy to access. There's a lot of computing power in here. And this is one of the key reasons why users love wearing Wear OS watches, is to help them have the peace of mind that they can be freed from their phone, but still be connected to the information or the people that they really care about. And so this is an area that's really important, connection at a glance, and we're doubling down on it to increase the user experience and bring more to our users. To give you just a few examples of things that we've introduced recently in the areas of notifications and complications, let me show you real quick here. Very recently, we introduced adaptive text sizing, which essentially allows the glanceability of the notifications to be much, much better. Because when you receive a short text, the size of the text gets bigger, so it's easier for you to read it. We also introduced recently darker backgrounds and a new font type so we can increase the readability and fit more information onto the screen at a glance. We've also done things to improve our complications. You know, complications are these bite-sized chunks of information that they sit right on your watch face, and they're very handy little tools. I use the agenda complication a lot. It really helps me many times during the day to tell me where I need to go next for my meetings. So we've done more because we think this is an important area for people to stay connected. Very recently, we introduced the notification preview complication. This is a very handy complication that brings the top ranked notification right on your watch face. Things like breaking news, a chat message, or your next appointment will be right there on your watch face with this complication. And we also introduced another complication that we called the recently launched app complication. This is one where it's very handy when you have types of information that you like to access very frequently during the day. For example, the weather or checking the scores of a live game. So this is just a few examples of things that we're doing to increase connections, increase the experience for connections at a glance. And as I said before, we're doubling down in this area, and you should expect a lot more from us in the months to come. Next is health. You know, health and fitness is one of the most important reasons why people buy a smartwatch today. People want to be healthy, of course, and we at Wear OS are very committed to helping people lead healthier lives. So we're doing more with it. We're working tirelessly to give users the ability to track their health much better than ever before, and also to offer them a superior experience to track their active fitness. Let me show you just a few examples of things that we've done recently. Very recently, we launched a feature called Touch Lock. This is a great feature, for example, if you go on a swim or you go out on a run on a rainy day, and you're tracking your workout with Google Fit or any other application like MySwim Pro, Strava, or Runkeeper. With Touch Lock enabled, what happens is that your screen basically gets disabled, your touch screen gets disabled, to avoid any unintended behaviors while your watch is in constant contact with water. To disable Touch Lock, all you have to do is click on that button, and you're back into normal mode. Next is music. You know, music is a huge deal for many people when they're working out. It helps them stay motivated and energized. And so we've made accessing the music media controls much, much easier than ever before from the Google Fit workout screen. All you have to do is scroll down from that screen, and you get to the media controls, where you can choose the next song that will help you power you through the rest of your workout. We're also doing a lot more with the heart rate sensor. We recently introduced continuous heart rate monitoring, so you can check your heart rate many times during the day, and you can also compute your resting heart rate right from Google Fit. So this is just a few samples of things that we're doing in health and fitness. We're, as I said before, helping people lead healthier lives is core to our mission. And we're working really hard in many aspects of health and fitness, and we're going to be bringing a lot new features in the coming months, so stay tuned. The last pillar that we're focused on is the assistant. Convenient help from the assistant. You know, today, unlike traditional watches that only give you, they're very good at giving you the time, with smartwatches, you expect to get the best out of the time. For example, in my case, I'm very busy during the day. I could quickly look at my phone and be able to check when the next train leaves to San Francisco so I can be home in time for my daughter's soccer game. We're working really hard to improve the experience for the assistant, to optimize for the wrist form factor. In a few short minutes, I'm going to invite Tom to come on stage. He's going to tell us a lot more about what we're working on here with the assistant. So there you have it. These are the 3 areas that we're focused on to improve the user experience: connections at a glance, health and fitness, and convenient help from the assistant. But in order to do this really well, we require a very solid and robust foundation. Here I'm talking about things like power, connectivity, performance, the companion apps that go along with the device, and so on. Let me just highlight 3 of them very quickly. First, iOS. As I said before, we're welcoming a lot of new iOS users. And we want those users to have a great user experience, just like anybody else that is wearing a Wear OS watch. Very recently, for example, we introduced a brand new iOS companion app that brings Google Fit summary stats right on the app so you can see it from the comfort of your iPhone. This is just one example of many things that we're doing to improve the iOS experience. Next is power. Power is really, really important when it comes to smartwatches. And we're working across the Wear OS stack to optimize battery consumption. Right after Tom, we're going to invite my colleague Rati. She's going to tell us a lot more about what we're doing with Android P and how this has a positive impact in power. And lastly, I'd like to highlight that we're bringing faster and more frequent updates to the platform. That's really, really important for our users, that they get continuous improvements to the watch constantly throughout the year. With Wear 2.0, we made changes to our architecture so that pieces that were considered to be traditionally part of the OS are now updatable platform components. And as a result of that, this past year, in 2017, we were able to do 11 releases to the platform and introduce 49 new features and improvements. This year, we're on track to do the same or even higher. We're introducing a lot of features really, really fast, and we're really excited about that. So, as I said before, the Google Assistant is one of the key pillars that we're working on, really, really important for us, and I'm going to invite Tom on stage to tell us a lot more about it. Thank you.
Thanks, Dennis. Hi, I'm Tom, and I work on the Assistant for Wear OS. We want the Assistant to follow you across all of your devices. And when you interact with the Assistant, it should adapt to the device that you're using. And for Wear, we want to provide an awesome Assistant experience right on your wrist. With our last update this week, we've completely redesigned our UI and have 3 major improvements that I'd like to talk to you about. First, we have an always-present microphone, which automatically reopens to continue the conversation with the Assistant hands-free. Second, support for text-to-speech. if you have a paired Bluetooth headset or a wearable device that has a speaker, when you talk to the assistant, Now can speak right back to you. And lastly, my favorite, support for suggestion chips. Suggestion chips allow you to breeze right through a conversation just by tapping. But the biggest new addition for Wear is support for Actions on Google. Actions on Google allow anyone to write a great wearable experience without having to write a single line of Android code. Even better, most existing actions already work on Wear OS today without any changes. So let's take a look at how this works. You may have already used Dialogflow to build actions for the assistant. It's a platform provided by Google that helps to turn natural language into a format that you can just go and build cool stuff with. And starting this week, you can also use Dialogflow to create actions for Wear OS. Best of all, we've already done all the hard work of building out response templates that are appropriate for wearable devices, so you don't even have to think about it. If you haven't used Dialogflow yet, it's super easy. Just yesterday, I was creating my own action. I only had to define this action once, and it will work across all supported devices. Here's what it looks like on mobile. This might look pretty familiar. There's an action icon at the top, a tappable list of the Google I/O sessions I plan to go to, and a suggestion chip at the bottom. And this is how it looks on Wear. All the same components exist, but now they're tailored for a smaller, wearable form factor. I didn't have to do anything special for this to happen. It just works. And now, even if you're going a little bit deeper and you're using the Actions SDK or a webhook for fulfillment, we still have you covered. In this case, I'm adding a new card to the conversation that has a little more information about this session. And this is how the card will render on both phone and Wear. It automatically resizes and looks great regardless of which device is being used. So over the past few months, we've been building and testing a lot of actions. And we've come up with some best practices to help your actions look really great on Wear. Let's start with an example. OK, Google, ask Bay Trains when is the next BART from Fremont to Hayward. There's supposed to be an animation
There will be a
here.
BART from Fremont to Hayward leaving today at 11:21 a.m.
Cool. So as Dennis mentioned earlier, we want users to have glanceable interactions. We want users to get tasks done quickly. We want to allow users to complete a task with a single phrase. In the previous example, I was able to get the information that I asked for by speaking a single phrase. Imagine if I had to specify all that information separately. The train that I wanted, the station, the direction of travel. That would take way too long, and I'd be far more likely to just pull out my phone. Keep your dialogues short, concise, and task-oriented. Now, there are cases where having a back-and-forth dialogue is important and maybe even required, and that is fully supported on Wear today. However, try not to make it part of your core user journey. As you may have just heard, Wear now supports vocal responses, and they don't have to be the same as the visual. In the previous example, both the visual response and the vocal response tell me when the next train leaves. That's what I asked for. But the visual response goes a step further and shows a more detailed list of departures. That information would probably be a little bit too dense to read aloud vocally, but visually, it works really well. Independently, both the vocal and visual response make sense, but together, they really complement each other and make an awesome experience. Keep in mind that not all devices support vocal feedback, so you can use Surface capabilities to really tailor your experience to the device that's being used. So vocal responses are cool, but my favorite new feature is suggestion chips. So I have to admit, I'm a little nervous. Last few times I came to Mountain View, it rained, and I forgot my umbrella, got soaking wet. I know it looks like a nice day out there today, but let's ask the assistant to see how things look. OK, Google, do I need an umbrella today? Right. Cool. not expected to rain. This weekend, I was planning on going for a hike, and I can use suggestion chips to get that information quickly, the weather for this weekend. I can just drag up on the bottom drawer where the microphone is located, which will reveal suggestion chips, and I can tap on weather this weekend to quickly get the forecast for the weekend. The weather looks great. I should bring my sunscreen. I love suggestion chips. Not only are they a great way for guiding users through a conversation, they also allow users to discover what your agent can and cannot do. Provide example chips whenever possible to guide users through a conversation. When thinking about how to build your action, be user-centric. Someone might be using your action in a lot of different ways. They might be on the go, their hands might be full, and vocal responses might be more appropriate. Or they could be somewhere noisy, and suggestion chips are the easiest way for them to tap through an interaction. Design with all these use cases in mind. We've had a lot of fun building support for Actions on Google, and you can get started building your own agents today. I'm so excited to see what you're going to build. And if you need some inspiration, we have a lot of great partner demos in our sandbox, and you can come by after the session to say hi and check them out. And if you're interested in building actions, I definitely recommend to check out the Design Actions for the Google Assistant session, which starts right after this one on stage 2. But don't go just yet, because up next is Rati to tell you about our platform updates.
Thanks, Tom. Hi, I'm Rati. I'm a technical program manager working on Wear OS. Tom just showed you how to build really cool assistant actions on Google's for Wear users. Now let's move on to the platform updates that we have. With the new Wear OS release, we are introducing platform features that would help you to offer delightfully stable and battery-efficient experiences throughout your apps, and help you build really cool watch faces with just a few lines of code. To begin, I'd like to talk about an Android P feature that is going to impact you as a developer. Android P is adding restrictions on accessing methods and fields unsupported by the SDK to improve app compatibility and to prevent apps from breaking. Wear OS is adopting these restrictions with the goal of making app behavior deterministic and stable. This is very similar to what the developers on my team face just before a product launch. The deadlines and restrictions can make people a little unhappy as they're dashing to meet the deadlines. But come launch date, the team is really happy when they're able to launch a stable and reliable product that meets our users' needs. So check out the app compatibility link, g.co/dev/appcompat, to understand what these changes mean for your apps. Moving on to battery. Battery is precious on mobile, and even more so on Wear. Last year at I/O, we highlighted that most watches have just 1/10 the battery capacity of a phone, and we shared some best practices on improving battery life. We also indicated that we would be looking for ways to be more aggressive than the phone in addressing battery usage. This year, we're moving beyond the mobile platform and introducing features to reduce background activity, aggressively turn off radios when the user takes off the watch, and enhance battery saver mode. Let me walk you through some of them. Here's a snapshot of the app standby feature that was introduced in yesterday's talk, What's New in Android P. On Wear OS, we are experimenting with a more aggressive platform change. Apps that are not active will not be able to create jobs or alarms when they're not on the charger. Now, even when they are in the active bucket, they can only start jobs or alarms if they are in the foreground. What do you mean by foreground? Well, an active app running in the foreground is an example. A watch face currently active on your dial. complications on your currently active watch face, and in very rare circumstances, say if you're a health monitoring app, a foreground service running on the watch. All of these can create jobs and alarms. If you are a Wear app developer, be sure to experiment with these changes in the developer preview and provide us with feedback. Another platform feature that is being revamped in the upcoming release is battery saver mode. We are enhancing this mode to go beyond the phone platform to aggressively squeeze that last ounce of battery and prevent the watch from turning off on users' wrists during the day. In this enhanced version of battery saver mode, we would be turning off all radios, touch, and tilt detection, and would be defaulting to a battery-optimized watch face. Users can short press to read the time and long press to resume full operation. Now, this could be particularly helpful if your watch is running low on battery, but you want to quickly be able to turn it back on to, say, make a payment or to check an important message. Continuing with our efforts on improving battery life, last month, we moved to using a dark theme for our system apps, as Dennis mentioned earlier. Now, this theming has the dual benefit of improving glanceability and accessibility while reducing power consumption. In P, we're bringing these changes to the platform and updating the default system UI to use the dark theme. So try these changes out on your app using the current developer preview. I'd like to leave you with some best practices for watch face design. As you know, watch faces are the most active apps and frequently are doing too much, too often. As developers, you have the ability to influence how long users can experience and enjoy your watch faces using simple coding techniques to save battery. Let me share a few best practices with you. Display, CPU, and network are the most battery-intensive components of the system. Be mindful of the frequency at which you are reading, processing, or displaying information on a watch face. For example, if you're reading a sensor and doing calculations every minute, or sending an RPC to the companion every minute, this can significantly impact the battery life. And once you have the new data from the sensor or the network, you would also have to wake up the system to process it. Processor wake-ups are more expensive for battery life than the power consumed by individual sensors like the accelerometer. So, batch your sensor requests and network calls. Batching can go a long way in conserving battery life. Finally, moving on to some developer tools. Last year, Android, and as a result, Wear OS, officially started supporting Kotlin. Now, you can already take advantage of a lot of language features like compile time null checks and Lambda support. But to get the best out of Kotlin, we need to go beyond what the language offers by default. On Wear, we are experimenting with creating a domain-specific language, or DSL, for watch faces, so you can get rid of a lot of the boilerplate code. The initial results are quite exciting. We reduced the watch face creation code of 600+ lines to just under 15 lines of code. And here's a snippet of what the DSL looks like. This simplified interface allows you to focus on the design and customize your watch faces using just a couple of lines of code, while incorporating best practices to boost the performance and battery life of your designs. We're very excited about the opportunities that Kotlin provides and are just beginning to scratch the surface on simplifying development on Wear OS. We look forward to your feedback while we work towards adding this to our official SDK. Check out the Code Labs at I/O and visit the Wear OS sandbox to share your feedback and ideas. To summarize, Use officially supported methods and APIs instead of private APIs to improve compatibility and stability of your apps. Design your apps and watch faces to be battery efficient. Remember, batching is your friend. Download the P Developer Preview and check out how your apps are impacted by the battery-saving features that we are introducing. And finally, give Kotlin DSL a spin using the Code Lab and let us know what you think. With that, let me hand it back to Dennis for closing.
Excellent. Thank you, Rati. All right, to recap, we're working really hard to improve the Wear OS experience in 3 key areas: connections at a glance, health and fitness, and a Google Assistant experience that is optimized for the wrist. We're also improving the platform with new battery-saving features and new tools for developers. And also, you can expect a lot more and frequent updates from us during the year. Today's session is just the beginning for us here at I/O. At 2:30 p.m., we have office hours, where you can meet with our engineers and our developer relation folks. Come on by if you have any questions. They'll be really happy to receive you and talk to you about anything that you'd like to talk about with regards to Wear OS. And at 11:30 a.m. tomorrow, we have an app review session where you can bring your Wear app, your complications or watch faces to get feedback from our engineers. And we also have a sandbox. Here's a map of where it is. Please come visit us. Tom, Rati, and I will be there right after this session, as well as many of our colleagues at Wear OS. We also have some cool demos there to show you, and a full lineup of some of the most recent Wear OS watches. That's all. Thank you very much for coming, and have a great I/O.
I'm hoping, waiting, wishing on a star.
A little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, I'm challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. Okay. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Matthew Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab, and I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All three of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, it's part of why I get into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is I/O Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life because it's not going to be impossible. And I think that that's such a huge, important part of my work and my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are female, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class, using Black Panther as an example of sort of our vibranium and our you know, sound science that we use in the movie, and to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and yeah, I can do this is, I mean, you can't ask for anything more. And so you know, I've always thought like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, you know, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, you know, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud, and that, you know, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So you know, and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, you know, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, you know, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda. And I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working a pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing, at the Human Engineering Research Lab. And I thought, man, I got to go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All three of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, it's part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is I/O Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life because it's not going to be impossible. And I think that that's such a huge, important part of my work and my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are female, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our, you know, sound science that we use in the movie. And to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and, yeah, I can do this is, I mean, you can't ask for anything more. And so, you know, I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, you know, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, you know, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud, and that, you know, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So you know, and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, you know, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like.
Let go. And don't try to tell me now how you think I missed out. Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing. And this thing can't stop me now. We were so young, we couldn't help but love each other. But now I know nothing hurts deeper than a first love, a first love. And don't try to tell me now how you think I missed out. Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing. And this thing can't stop me now. Rise up, 'cause I can't go on hoping.
Wait.
This thing ain't working.
You gotta get started. Hi, everyone. Thank you for joining us here at I/O today. Hello to everyone on the live stream as well. My name is Rob. I'm an engineering lead on the Android Things team, and I'm joined today by Shika, who's a
Hey,
product
everyone.
manager on our team. This is a Lenovo Smart Display built using Android Things. You can think of it as a visual Google Assistant or like a smart speaker with a display. You probably heard in the keynote already, or maybe in Vince's talk earlier today, that these devices and others from JBL and LG will be available on store shelves starting this July just a couple of months from now. Today, we're going to tell you the story of how we built these devices from prototype up to the production devices that will be available in a few months. Before joining the Android Things team, I spent most of my career writing software that ran on other people's devices, probably like many of you. But building a new piece of hardware at scale is different from the kind of work I had done before, and it came with a lot of new challenges. And today, we're going to tell you about some of them. Our hope is that you leave this talk with a better idea of what it's like to build consumer hardware at scale and how Android Things makes it easier than it's ever been. It's not that scary once you know what to expect, so I hope that our story of prototype to production can help you build a device of your own.
If you are a software developer thinking about building consumer devices, here are a few things you probably care about. First, you want to build your product features without having to worry about the underlying platform. You also want to be able to swap out underlying hardware seamlessly without affecting your application layer as the technology or product needs evolve over time. You obviously want your devices to be secure. I think it's obvious why security is increasingly an essential requirement for smart devices. They hold the keys to our homes and our personal information. What's probably less obvious is why it's hard to provide this kind of security. It's incredibly expensive to harden products out of the gate and to keep them updated over time. Meanwhile, there's immense cost pressure from end customers, and it's hard to amortize costs without large volume. We know this at Google, since we've been doing this for many products. Coming back to you, finally, if you're building a consumer device, you'd want to manage release and update channels over time. Android Things was designed with all of these needs in mind. We provide turnkey hardware in the form of pre-certified system-on modules, or what we call as SOMs. The SOM includes the CPU, Wi-Fi, Bluetooth, memory, and other critical hardware components. Think of this as a small computing platform that you can use to build a variety of IoT devices. We bring up the operating system on new SOMs, test it, and certify its suitability for production devices so that you don't have to do any of this. Later on in the talk, we'll give you an inside look into some of this work that Google handles for you. You provide the application code and wire up the peripherals, and Google takes care of the rest. What you see here are smart displays from Lenovo, LG, and JBL. As Rob mentioned, they are built using Android Things. In fact, if you look under the hood, all three products have the same SOM, which is pretty cool. These devices have far-field microphones that can hear you from the other side of the room, and built-in speakers that can answer back across the room, just like a smart speaker. But now, we also have a touch screen, which makes it possible to see visual results. This is quite cool if the result happens to be a list of restaurant nearbys or a map showing you your commute conditions. We announced this earlier this year at CES, and we're very proud of the reception we received. Let's dive a little deeper and see how we built these. About a year back, we at Google were wondering if we could build a visual Google Assistant. This would enable deep integration with other Google services such as YouTube, Photos, Maps, and so on. Building a consumer device, though, is typically a long process. But for a fast-evolving space like smart home devices, time to market is extremely important. We wanted quick turnaround time, and this is exactly where Android Things shines. Our goal is to make it possible for software developers like you to build consumer devices at scale. But that's a hard thing to get right in a vacuum. It takes real-world experience in building and shipping a lot of devices to know that you've really done it. This project would give us the perfect opportunity to do that. In this case, our customers were software developers from other internal teams at Google, such as the Google Assistant team. For smart displays, while they took the lead on building application software, we iterated on the platform. As a result, we were able to get these from prototype to production super fast, and we now have a stronger platform for you to build on. We started by building some proof of concept hardware for smart displays. Our goal was to learn from that and to use the device to kick off broader discussions across the company. So we took a few weeks and some spare parts and built this.
This is our first proof of concept hardware. This is running on some hardware that we had used previously to deliver an Android Things-powered smart speaker. I built this case with my son. Cost me about 2 Pokemon cards. He still wonders when he's going to get his bricks back, though. This device doesn't have all of the hardware that ships on the final devices. For example, it's missing a camera. It doesn't have the volume up-down buttons or mute of any sort. But that wasn't the point of this device. For this one, what we were trying to do is show just the basics of what we thought we could achieve with the Smart Display product to get some conversation started. The mic on this one in particular was kind of tricky to use. It wasn't meant for this kind of use case. You needed a quiet room, and you had to stand in just the right sweet spot. But with a little bit of practice, it was possible to pull off a pretty convincing demo with it. On top of the Android Things platform and the smart speaker code that we already had, we built a small Android application to drive the display and show off some of the key use cases we thought were going to be important for this kind of device. One of the first things we did with the display is to transcribe your query as you spoke it. It was a basic proof that the whole speech recognition pipeline was up and running properly, and it looked pretty cool in a demo. Next up, we added some support for a rudimentary, what we call a knowledge card, that'll show a brief snippet of text and a photo along with answers to certain questions. This device couldn't play video yet because it didn't have the hardware required for that, but it could stream music already, just like a smart speaker. So we added title track display and media transport controls like pause and skip. And then finally, we took a rough cut at the ambient screen, which is what the device does when it's not doing anything else. It showed a photo slideshow and a weather forecast. So like I said, just kind of a basic set of functionality that we could use to show people what we thought we could build out of this. It only took about 2 weeks and a small team of people to get this working. But the result was actually surprisingly close to the architecture of the final products that are shipping in a few months. The changes between what we built here and what we're shipping are basically incremental changes. Fundamentally, what we built and what we're shipping involves the smart display application at the top of the stack, running on top of Android Things on top of a certified, what we call a SOM. Android Things brings the hardware support, the security, the application framework, and the update mechanism, while the Smart Display application brings all of the Google Assistant integration and the visuals for the device. Don't get me wrong, there was definitely a lot of work to do between here and what we're shipping this summer. But as I said, the fundamental architecture is the same, and it was a matter of incrementally building out the feature set from here. We practiced the demo routine with this device and set up meetings across Google over the next few weeks. People got a kick out of the brick case that we built, and we had a lot of great discussions and some debate about product features we should support, about Android Things, and about what we should do next. Overall, the demos went really well, and we got the buy-in that we needed from key stakeholders across Google to move on to the next step with this project.
Now that this was going to be real, we kicked off a few steps in parallel to scale up our efforts. First, our business development team started discussions with potential OEM partners. In this case, an OEM, or an original equipment manufacturer, refers to a company that will build and sell the device. They come up with the industrial design and the physical look and feel of the product. They also pick parts like the display, camera, microphone, and other audio out components. If you were to build a device on Android Things, you will be the one responsible for case design and component selection. In place of this step, you might find an industrial design firm to work with or a factory to build your product. A lot of details here were handled by our OEM partners, and we are not going to cover them today. In parallel, we started finalizing the hardware requirements for the product. The proof of concept device used a SOM that we had used to build smart speakers. But you can build anything else from it that has similar requirements as well. For smart displays, though, we needed something more powerful to support use cases such as video playback. Fortunately, we had some SOM options in our roadmap that we started evaluating. Finally, in parallel to the OEM selection and SOM selection, we got started on the application software. Google had already built out the Assistant backend and client software for smart speakers, but turning a smart speaker into a smart display isn't just a matter of plugging in a touch panel. There's a lot of new work around the home screen, the video playback experience, the maps and photos integration, and essentially all the other visual features that we were trying to build with this. Turning the application software from a humble proof of concept device into a production device was going to take a lot of time. Most of the software work was responsibility of developers outside our team, and they needed to get started right away. These engineers, who are software developers like many of you, don't want to have to think about the underlying platform or the hardware. But because we are building this on Android Things, they don't need to. Like we mentioned earlier, we can decouple the two. The application engineers work on top of the Android framework, just like any Android developer would. Their application can run on any hardware with Android Things support.
So at this point in the project, it's July of last year. We're about a month and a half into the work. We've got our proof of concept hardware. We've got some business development work underway. We've got the hardware selection underway. And we're nearly ready to get started on the application software development in earnest. But in order to really kickstart development, we need to get some actual hardware into the hands of engineers and product managers and other folks at Google who are going to actually build this out. But as we said before, the hardware that we used in that proof of concept device was just a little too slow to use for more than just a demo. So we looked through the SOMs that we had in our pipeline and found one that met the requirements for this category of devices. And it happened to also be very easy to buy in quantity over the internet. And we had Android Things already kind of running pretty well on it. So we decided to use this as the basis for some provisional hardware that we would build to unblock the application engineers so that they could get started on their job while we finished out the hardware bring up. We knew that we would swap this hardware out later when it got closer to production, but that didn't worry us because, as we've said, we're building on Android Things, and that gives you the isolation from the hardware that you need to be able to do that. The second problem we had, though, with the provisional hardware was that it was a development board kit, similar to the IMX7 kits that we're giving out here at I/O, which means that it had a display and a camera connected to the baseboard through FlatFlex ribbon cables. You can obviously work like this, but it's a little difficult to manage if you have more than one on your desk, for example. And we wanted to give these out to a lot of Googlers. For the first few weeks, we literally held the thing together at our desks with cardboard and rubber bands. But that wasn't going to scale to the quantity that we wanted to deliver. For that, we needed a more solid enclosure to keep everything in one spot. And by the way, if you do complete the scavenger hunt here at I/O and you get an IMX7 kit, make sure to keep the packaging. It turns into a handy stand so you don't have to build one yourself. So this is the enclosure we came up with for our first provisional hardware. Honestly, Android Things didn't really help or hurt either way in the building of this case. But I had a lot of fun making it, and I learned a lot in the process. So I hope you don't mind if I geek out for a few minutes and tell you a little bit more about this design and how we built it. It looks pretty plain from the front. The point is that it's just enough to keep the hardware together and give you a rough sense of the form factor that we had in mind. There is a camera module at the top, some microphones that we had manufactured locally here in Mountain View in the middle of the top, and of course the big touch screen in the front. Here's a quick view of the back. The SOM and the carrier board are mounted in the back of this big piece of wood that I called the bezel here. Just like most of the rest of the hardware, you can get to most of the ports easily from the top. And there's a little access for the reset button on the side, which is very important when prototyping. I want to point out here, though, that pretty much none of these components match the final hardware. Obviously, as we've said, the SOM is different, so is the camera, so are the mics, so is the display. But again, not an issue because we're building Android apps on this, and they don't really care so much about the specific hardware underneath. Building this prototype was my favorite part of the project because at the time the deadlines were far enough away so that they don't make that crushing sound they do when they get a little closer. And we were still a small team that needed to be scrappy and pretty resourceful. So I literally built this case in my garage over a few weeks. And the best part of that is that I got to buy a new tool. Not just any tool, but a 60-watt laser cutter, which of course I got off the internet. I literally learned how to use a laser cutter for this project. I iterated on the design in my garage over the course of a few weekends. It was my first time using any kind of 3D modeling package to do this kind of design, my first time ever using a laser cutter, and I basically learned by watching videos online. And the point here is that if this is the kind of thing you like, yes, you can do it too, and you'll probably have a lot of fun doing it. The material that I tried first was this birch plywood. It's about 3 millimeters thick. You can get it in quantity from the net very easily, 2-day shipping in stacks of 25 or 60. If you go for the bigger, if you go for the batch of 60, it's maybe $1.50 a sheet or less, so it's pretty cost effective. When I first tried building this out, I wasn't very efficient with my material use. It would take maybe 2 or 3 sheets of plywood to build enough parts for a case. But eventually, you want to get a little more optimized, waste a little less material. And as you see here, I managed to fit the whole case into a single 12-inch square sheet of plywood. I did have to fit one of the sides inside of the bezel to make that work. It was a lot of fun it was a big challenge to figure out how to get this all into one sheet of plywood. A lot of fun to overcome that. But laser cutters only cut in 2D, which meant it's a little hard to work a fastener like a screw into the design. So this one is all friction fit. I came up with a tab and slot design where you could put it together by hand and it would stay together pretty securely. And the best part of that was that it was actually real easy to service in the field. If a connector comes loose or you need to change a jumper, you can snap the thing apart with your hands. You don't need to find a screwdriver. You fix it, you put it back together, and you're good to go. We tried a few variations in other materials, such as the acrylic you see here. I think it looks much better than the wood. Obviously, this semi-transparent red is really cool. But what we found is that in acrylic, the thickness, for us at least, the material we had, the thickness varied too much across color and even within color, so that when we put some of the cases together, they'd just fall apart on a desk, or they'd fit together so tightly that the acrylic would snap at the weak points, which turned out to be the 90-degree cuts in the material. So we decided to go with the wood after all, because it was going to be more robust for us. I cut about a dozen, enough parts to make about a dozen of these cases. We brought them into the office, had some people assemble them so that we could try out the design. We iterated on it a bit, eventually settled on a final design and sent it off to an internal shop at Google with a laser cutter that can cut these in bulk. If you happen to work for a company that doesn't have a laser cutter shop, not a big deal. You can find plenty of places on the internet where you can upload your CAD files. They'll cut them and send them back to you. If you've never worked with a laser cutter before, though, I recommend you try one out first before you send it off and commit to a bulk order and get a feel for what works and doesn't work in this kind of design. But again, the moral for this part of the story is that you can build an enclosure too, and laser cutters are cool, so you should try one out. One more thing before we move on, though. I mentioned we wanted to build a lot of these. We built 75 in the first batch to spread around Google, and we thought that was going to be more than enough. But they were so popular that we built another 75, and even that, frankly, we could have used a bit more. So once you have this many devices, and honestly, once you have more than, say, 1 or 2, you want a way to disambiguate them, to tell which one's which, because at some point, someone will have a problem. They'll say, hey, man, can you look at this device? And you'll say, sure, I'm busy right now. Drop it off at my desk. And maybe they'll put it next to one that looks just like it while you're away. And then you end up looking at the scorch marks on the case to figure out which is which. So think ahead. Give each device a serial number. Keep track of it in a spreadsheet somewhere so you know how much inventory you have left to give out, or who's got what, or maybe what the history of individual devices are.
So we now have the hardware prototype to hold over our application developers for a short term. In parallel, we were working on finalizing the SOM for smart displays. We evaluated certain options in our roadmaps and kickstarted another series of discussions, only this time it was with the SoC vendors. We eventually selected a Qualcomm SOM called as the STA624 for the Lenovo, LG, and JBL devices that are launching this year. Powering this is an 8-core A53 with an Adreno 506 GPU that supports display and camera. It's plenty capable of driving a smart display, and of course, a bunch of other potential devices that you may want to build as well. On the STA624, Google will offer free stability fixes and security patches for 3 years with options for extended support. To give you a more concrete idea of the hardware we are talking about here, here's a photo of the top of the SOM. You can see the SoC, the Wi-Fi, Bluetooth module, the memory, all mounted on a discrete board. Here's the underside of the SOM. The main thing going on here are those 3 high-density connectors with 100 pins each. These pins make up the SOM's interface to the outside world. Here's a little deeper dive into the SOM's pin-out interface. The pins carry power, GPIO lines, and a wide variety of peripheral buses in and out of the SOM. Wow, looks a little overwhelming, doesn't it? However, you wouldn't need to worry about designing this if you were using Android Things to build your devices. Pin assignment has been standardized along with the rest of the SOM so that the underlying platform know what the expectations are. In some cases, you'll also have the option of laying out the SOM circuit flat onto your board exactly as specified according to this interface. However, it's much faster and easier to just build a carrier board that the SOM module can plug into.
So if you get one of our development SOMs, it'll come with a carrier board that has some common I/O pins broken out onto standard size header so that you don't need to deal with any of these high-density connectors. But when you build a device for real, for mass production, you'll likely want to spin your own carrier board that connects to whatever hardware you need for your device. For smart displays, we came up with a reference carrier board that we asked our OEMs to follow. You can see in the slide here that in the middle we have the SOM, which again is the CPU, the Wi-Fi, and other important parts, and the peripherals are connected around the outside. We standardized on button and sensor connections in this reference design, specifying which GPIOs they should connect into, for example, to simplify our work on the software side. Because we're working with 3 OEMs simultaneously, we wanted to avoid as much as we could unnecessary customizations across OEMs. So everybody, for example, plugged their volume up into the same GPIO on the SOM. One other thing we specified in the reference design here is that the microphone mute circuit should be external to the SOM and implemented in hardware, so that when you mute these devices, the mics are electrically, physically disconnected from the SOM, so that even in the face of some sort of successful software exploit in the future, there's no way to unmute the device in software. Similarly, we specified as part of the reference design that the camera mute should physically cover the lens of the camera so that there's no way to unmute the camera, so to speak, in software. We did leave some room for OEM customization. For example, they could select their own microphones. They could build their own audio output stages. And they had some leeway on display choice as well. This is the next revision of our development kit. This is what came after the wooden kits that I showed earlier. This one is built according to the reference design, and it's using a lot of the production components that we have in real devices. This time around, the entire front assembly was put together by an outside firm, and we didn't have to do any of that. This case happened to be in acrylic. As you can see, it used friction-fit grommets to connect the standoffs to the back. These sometimes came loose if you over-tightened them, but you could fix it with a little bit of super glue if you had to. From the front, what we have here is the exact same touch panel, camera, and microphones used in some of our production devices. We added this acrylic back at Google, which held the speaker in place and really just gave the front something to lean up against so that it was at a similar angle to what we were expecting for the production devices. Inside, these are essentially the Qualcomm SDA624 SOM plugged into a carrier board that matches the reference design. This is actually one of the earlier versions, which we called the FEP1. And in these versions, the amplifier and the display interface were on daughter cards that plugged into the carrier board. But on later revisions, we had it all flattened down onto a single carrier board. We completed these kits in the beginning of December of last year. If you're not aware, CES is January 9th. So we basically had just a month to go before the big show where we were going to show off these devices at CES. So it was a little nerve-wracking, especially in those weeks leading up to the delivery of these devices where the CES was getting closer and closer. But in fact, the application engineers had gotten off to a great start with the wooden devices. And we sorted out the platform bring up on the Android Things side relatively quickly. So it's really kind of amazing that 1 month before this huge demo at CES, we were able to completely swap out the hardware. We moved the entire development team, platform, and application engineers from those wooden prototypes over to devices running on a completely different SoC without a hitch. And this is because, thanks to Android Things, the smart display application is totally independent of the platform. You can see how this was useful to us because we had this kind of provisional situation where we needed to bring up temporary hardware before the real stuff was ready. But this can be really useful in production devices as well. You may ship this year with a certain profile, a certain piece of hardware that you need, and then next year maybe you want to cost it down, or you may want to add new features and switch to a more powerful piece of hardware. And because of this, you can easily reuse the application software across a wide variety of hardware platforms.
So around the same time as our reference hardware was being completed, our OEM partners Lenovo, JBL, and LG were busy building out their own devices based on the reference design that we showed before. Those arrived at Google even closer to CES. We got them with just about 2 to 3 weeks to spare. But again, the transition was relatively smooth. We hit a few bumps. For example, on one of our devices, the camera looked green, which we eventually traced to a missing capacitor, but essentially nothing that we couldn't sort out on time. CES was a lot of work. I remember cursing whoever it is who schedules it so close to holidays. This is a picture of our war room that we set up a few weeks before CES. We spend a lot of time here planning the demos, adding features, and fixing last-minute bugs on the device and on the backend servers that make it work. On the demos, we plan to show rich integration with other Google services, such as YouTube, Photos, and Maps. This is a picture of a little kid's room that we set up in Mountain View, which had Nest cameras pointing at it, and we could check in on our little Android baby all the way from Vegas. Our hard work and careful planning paid off, and the demos pretty much worked like they were supposed to. We had some issues setting up the venue and a few hardware glitches, but we brought backups expecting that to happen. The reception we got from the press and users at CES was very encouraging. When you're hard at work on something in secret, it's hard to gauge how the outside world is going to react to it. Getting this kind of positive feedback was a great shot of motivation for the team and helped further galvanize the effort. After CES, it was time to get out of the demo mindset and back to the work of shipping. At this point, we were flush with hardware from our OEM partners, and the program was ramping up. Up till now, we were handing out a single software build to all our developers, but now we needed to expand out. Fortunately, Android Things makes this super easy using what we call as channels. Our developer console allows you to manage, release, and update channels over time. You can get a lot more details on how this works in Adam and Amy's talk tomorrow. So for smart displays, we established multiple channels for our internal user segments depending on their needs. For example, our developers have medium to high risk tolerance and can replace components as necessary. We have a dev channel for them. We also have a canary for high risk tolerant developers where we roll out daily builds. Of course, we have a different channel for our QA or testing teams so that we can give them early access to builds that we want tested. At this point, we also have hundreds of Googlers who are testing out smart displays and giving us feedback on features. These people need more stable channels, and they have low risk tolerance. So we roll out stable weekly builds for them with known good functionality, and we skip builds in case there are issues. We are getting close to the end of the talk, but I want to cover one more thing before wrapping up. In this day and age, if you are shipping software, you never really need to be completely done with it. If you are building a website or a mobile application, you can roll out bug fixes whenever you want. But when it comes to hardware, you only get one shot at it. Once it's in the hands of the user, that's it. There are some things that even software cannot fix at that point, so you better get it right. You also just cannot keep the factory running continuously, though, making small tweaks here and there. You need to purchase your building materials in bulk, and since it's still early in the process, you're not going to be ready to buy in mass production quantities. Also, the tooling and testing takes some time to set up and change. So this process usually happens across a few builds that are standard in the hardware development lifecycle. You can read up more about those on internet, but I'll cover it briefly today. So we already talked about the prototype phase. The next phase is the EVT, or the engineering validation test. For this phase, you're trying to validate that you got your schematics right, you don't have any layout issues, and your components work with each other the way they are supposed to. If you're still considering different design options, you can iterate on them. This is a good time to do so. This essentially represents the first attempt at building your boards the way they'll appear inside your final device. The enclosure is typically still not final at this stage, so you may want to keep the boards hot glued, screwed, or taped just to keep them from flipping around. The next stage is the DVT, or the design validation test. The purpose here is to verify your production processes and equipment to ensure that they are meeting your final specifications. The devices we got for CES were what we called as pre-DVT. They were soft-tooled, which means that the molds used to cast the plastics were made of a soft material like silicon. Again, you may want to do a few builds here until you get to a point where you know that there are no fixes that would need a hardware respin. You ramp up quantities as you get more confidence, and eventually you want to get to a run with hard-tooled plastics. The PVT, or the production validation test, is typically the last build that transitions into mass production. Hopefully, by now, you've logged in the final software that you will be flashing in on these devices. At this point, you're also hoping that your factory is pretty much running on autopilot without any manual intervention. Finally, your product is ready to go to mass production, which means it's ready to be on shelf. At this stage, you're ramping up production and focusing on making process improvements to improve the yield. You obviously want to continue testing it for the next few months, though, as well as establish some sort of reliability testing. So that's how we build smart displays from prototype to production. To reiterate, having Android Things as the underlying platform helped us in every step of the way. First, thanks to the Android framework, our software developers could focus on building application features without having to worry about the underlying platform. Our system on module or SOM solutions allowed them to swap out underlying hardware seamlessly as we moved from one prototype kit to the other without affecting the app layer. And yes, while we needed it to do a lot of work to bring up the SOMs for smart displays, you don't need to do any of this. The smart display SOM will be ready for your use soon. Our update and device management features allowed for fast iterations and easy maintenance of multiple devices on the field. And finally, our security features mean that our OEM partners and users don't have to worry about the security of these devices.
So we have a lot more to show you at I/O. Come and see us at the Android Things Sandbox Dome, which you can see on the left side of the map here. The entire dome is filled with Android Things demos, and it's open after hours as well. You can see how we leverage machine learning, Firebase, and the cloud platform. And you can also have an up-close look at the prototypes and the devices that we talked about here today. By the way, you'll notice Android Things-powered devices outside of the Sandbox Dome as well. There's survey boxes all around I/O that are built on top of Android Things, and a large human-sized robot roaming around ready to take a selfie with you. So you can come to our code labs as well, shown sort of in the middle area of this map. We have code labs showing how to work with TensorFlow, how to work with Cloud IoT, and how we made the survey boxes that are around I/O, and even more. There are 7 more sessions on Android Things coming up today and tomorrow that go even deeper into some of these topics. Finally, have some fun at I/O. We have a scavenger hunt going on, shown at the link here, g.co/IO search. I won't give away too much, but you'll run into some machine learning enhanced flowers, which are pretty cool. And if you solve all the puzzles and make it to the end, then you'll get a piece of developer hardware to take home for yourself. With that, I'd like to invite you to go build some hardware. And I hope that we're leaving you with some new confidence that you too can build a device with Android Things. Go to the link mentioned here to get started today. Thank you.
Representation in a social aspect for young kids, young girls, and the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake, and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together, and then pulling from nature. That was a huge one, and thereby keeping everything organic in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it, and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing, because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda, and I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, I'm challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes, I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab. And I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All 3 of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
feeling like we're supposed to. Now the sun's out, sun's out. And 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 now the sun's out, sun's out.
Welcome, everyone, to our talk today on the future of the web and immersive computing. My name is Brandon Jones, and I'm a developer on the Chrome team that's been driving forward immersive web standards. So we feel like 2018 will mark the true kickoff point for what we've been calling the immersive web. The technologies involved have all begun to stabilize enough that we can begin exposing them to the web platform with confidence. And while the APIs that we'll be discussing today are still in development, if you start learning how to use them now, they'll be shipping in stable browsers by the time you're comfortable with them. So what do we mean when we say the immersive web? Well, it's a collection of new and upcoming tech that prepares the web for the full spectrum of immersive computing, which includes virtual reality and augmented reality. More generally, we think of the immersive web as anything that gives the web a sense of depth, volume, scale, or place. Here's how we think about these technologies in general. Virtual reality, or VR, can take you anywhere, while augmented reality, or AR, can bring anything to you. We'll be covering both in this talk. First, I'll cover how we're bringing VR to the web today. And then John Pallett will come up and show you our upcoming efforts to do the same thing with AR. So let's start with virtual reality. Chances are you already know about VR headsets like the Daydream View, the HTC Vive, or the Lenovo Mirage Solo that was released just last week and is on display here. They use a combination of head tracking, screens, optics, and controllers to make you feel like you're present in a different place when you use them. Last year at I/O, we presented the WebVR API as a way for web developers to communicate with these devices. WebVR was really well received, but it also had limitations that became apparent as the VR ecosystem grew. Since then, we've been collaborating with content developers, device manufacturers, and other browser vendors to address those limitations. And the result is the new WebXR device API. WebXR replaces WebVR, evolving the concepts that it introduced to meet the needs of a growing immersive computing ecosystem. It'll serve as the foundation for the immersive web, exposing not just VR, but soon AR functionality as well to web developers. But it also goes beyond the headsets to make those immersive worlds accessible to as many people as possible. Of course, we recognize that migrating existing code to a new API is a bit of a pain, but we also think that the benefits will be well worth the short-term inconvenience. The WebXR API was designed by listening to lots of feedback from developers of real-world content just like you, and explicitly addresses many of the issues that they reported. Additionally, the new API provides a platform for AR features and will be more forward compatible with a wider range of devices. It's also cleaner, more consistent, more predictable, and enables browsers to apply more optimizations. So, what do I mean when I say optimizations? I really like this part. The design of the WebXR API has allowed us to better tune the rendering pipeline. We do it by doing things like reducing the amount of texture copies that Chrome makes internally when presenting VR content. As a result, we're seeing that on Android, we can default to using 50% higher resolution render targets than WebVR did without impacting the application's performance. And all of that technobabble means that we're pushing twice as many pixels to the display versus the same content in WebVR. Put simply, your immersive content looks better and runs faster simply by using the new API. So when can you start using it? Well, today. Developers who want to try virtual reality features on the web can do so today in Chrome 67, which is currently in beta. There are two ways to get started. First, the WebXR device API is available as an Origin trial today. Origin trials are a way for Chrome to allow developers to deploy features to users that aren't quite finalized yet by embedding a token in your page header. In return, the developers agree to provide feedback on the feature so that we can improve it prior to shipping. Now, if you're not interested in actually deploying content today, but just want to play around with the API, you can also enable it via Chrome's About Flags page to start testing. And if you enable the API through either of these methods, you gain access to a variety of different ways of viewing immersive content. First, WebXR in Chrome 67 gives you access to mobile VR devices on Android, which enables users to slide their phone into a headset like the Daydream View or Cardboard and instantly turn it into a virtual reality headset. Of course, we recognize that there's a wide variety of mobile devices and browsers out there, which is why we're also making Cardboard compatibility available for other browsers like Mobile Safari via JavaScript polyfill. As you might expect, there are some limitations to going that route, but it allows developers to guarantee a baseline functionality to all users. Next, Chrome 67 also supports high-end desktop headsets like the HTC Vive or the Oculus Rift on Windows. These represent the highest quality VR experiences available to consumers today and provide an excellent opportunity for progressive enhancement of your immersive apps by adding things like room scale movement and 6-degree of freedom input. And finally, Chrome 67 also supports what we call Magic Window content. Magic Window refers to viewing the scene on a 2D web page that still tracks the device motion. It provides both a hint to the users that there's a larger world to see and a way to consume the content even when a headset isn't handy. So let's take a quick look at how we can use this new API to create a simple virtual reality application on the web. We're going to assume that you already have a WebGL scene that you would like to make viewable in virtual reality. First, we need to detect if there's any WebXR devices available, and if so, we need to advertise that functionality to the user. To do this, we'll start by calling the navigator.xr.requestDevice function. The promise that it returns will resolve to an XR device, which may represent a mobile device with VR and AR capabilities, a wired desktop headset, a standalone headset, or some other type of immersive computing device. Next, we check to see if the device supports the mode that we want to use. In this case, because we want VR content to display on a headset, we ask if it supports exclusive access by the page. If it does, we add a button to our page to advertise the XR feature. And when the user clicks on that button, we'll request what's called an XR session. The session is what gives us access to all of the actual capabilities of the VR or AR device. You get a session by calling request session. You call that on the XR device we retrieved previously, specifying again that we want exclusive access to the display. Then, once we have the session, we need to create two supporting objects, a frame of reference and a WebGL layer. The frame of reference tells us how to position objects in the scene relative to the user. Here we're asking for a stage frame of reference, which attempts to place the scene's origin on the user's floor. That way, it's very trivial to line up your virtual floor with the user's physical one. Next, we create a WebGL layer, which gives us a surface to be rendering our 3D scene into. You can think of this kind of like a canvas element that's visible from within the headset. Then, once our setup is done, we're going to kick off an animation loop by calling request animation frame on the session, which is very similar to the window.request animation frame you're already familiar with. Now, with that, we're almost ready to begin rendering, but first we need to understand a new concept introduced by WebXR, and that's views. The WebXR renderer loop provides your application with a list of views that must be drawn every frame in order for the scene to appear correctly on whatever device you're viewing it on. A view provides all of the values needed to render a single image of the WebGL scene, such as view and projection matrices and frame buffer viewports. Most headsets will require you to draw 2 views, one for each eye, while a Magic Windows scene will only require 1 view. And you can imagine in the future we might have more exotic hardware that could require you to draw even more views than that to account for different display configurations. The benefit is that WebXR can use a unified rendering path for a huge variety of different devices and display modes. And here's how that looks in practice. Our request animation frame callback is given an XR presentation frame object, which contains the list of views that we need to render. It also allows us to query the pose of the XR device, which is its position and orientation in space. To display our scene on the headset, we're going to bind the frame buffer provided by the WebGL layer that we created previously, and then begin looping through each of the views that's provided by the frame, drawing into the viewport that each of the views describes, using the view and projection matrices that they provide. And when we put it all together, we can now provide an immersive virtual reality experience with the WebGL scene that we had previously that works on mobile, desktop, and standalone VR devices. But of course, your users aren't content to just look. They want to interact with the immersive worlds that you're creating. So we need a form of input. Now, WebXR took to heart a lot of the feedback that we got about the difficulties handling input with the WebVR APIs. And it attempts to address them with a new unified input system that works across all of WebXR's various form factors. The basic idea is this. Anytime you're interacting with a scene, whether by tapping on a Magic Window, looking at an object and clicking a button on a cardboard-style headset, or using a controller to point and click, all of these interactions can be described by a ray, a point of origin and a direction into the scene. By using the rays that WebXR provides, you can trace into your scene, determine what objects the user wants to interact with, and respond appropriately no matter what input method they're using. So let's see how that looks in code. First, the user needs to know what they're pointing at. So we'll visualize whatever input method they have by going through and querying and iterating the list of input sources from the WebXR session. And then for each input source, we'll get its current pose, which describes the direction the input is pointing in, and, if it's applicable, the position and orientation of the controller as well. Then, depending on the type of input source that we're dealing with, we'll render some combination of a controller model, a pointer ray, and a cursor to show where the input is pointing. And here you can see an example of how an app might visualize a tracked controller. It's rendering both a representation of the controller itself and a pointer ray and cursor to help the user better target their input. If we were using a gaze-based system like Cardboard, we'd only render the cursor because it is fairly distracting to have a laser coming out of your forehead. Thank you. Now that the user can see where they're pointing, we need to be able to respond to what they're clicking on in the scene. And to do this, we listen to the select event. This fires on the XR session and tells us which input source fired the event, which we can then use to query its pose at the time the event happened. This gives us the pointer ray. The application can then use the ray to perform a hit test against its internal representation of your scene. And if we detect that that object was selected, we trigger the appropriate behavior, which will depend on the context of your app. And this allows us to provide users with a way to easily point and click and interact with any object in the scene and have that interaction be consistent across all of the various devices that they might be using. WebXR's input system also allows for grabbing and moving objects by listening to the select start and select end events. And crucially, the select event also is considered by the user agent to be a user activation event, which was not the case previously with WebVR, and one of the issues that we heard about from developers most frequently. This means that applications can start media playback with WebXR input just like they would a mouse or touchscreen. So we now have an interactive VR experience that lives on the web, and that is awesome. But not every user has a headset. And even if they did, not every user is using a browser that supports WebXR yet. Now, we want your content to be accessible by 1 billion+ users. And that's why we're expanding the immersive web's reach to 2D screens via Magic Window and to non-WebXR enabled browsers with our JavaScript polyfill. So first, let's talk about Magic Window. As I mentioned earlier, it's a mode that lets users view immersive content on their phone without a VR headset, tracking the orientation of your device to let you look around. It's like you're holding a little portal to another world in your hand. And with the WebXR Device API, we've put a lot of effort into making the creation of Magic Window experiences as frictionless as possible. Let's rewind just a little bit and look at our XR session creation code from earlier in the presentation. This code indicates that it wants to start displaying content on the headset by specifying it wants exclusive access to the display. But with Magic Window, we want our immersive content to show up as part of the page and not on the headset. To accomplish this, we only need to make a few changes. First, we create a canvas that we want the Magic Window content to display in, which can be attached anywhere you want in the document. And then you need to get an XR presentation context from that canvas. This works just like getting a WebGL context out of the canvas. That gets passed to the session request as the output context. This binds the session's rendered output to that canvas. Now, you'll also notice that we've dropped the exclusive argument from the request because the session's output isn't intended for the headset. And honestly, that's it. Like, everything else is the same. The render loop we described earlier now knows to only request a single view. The input system now fires events that correspond to screen taps rather than controller clicks. And everything else just kind of works. Even better, it's easy to use both Magic Window and VR on a single page, so you can let users transition frictionlessly between the two at the touch of a button. Now finally, let's talk about the WebXR polyfill. For browsers that don't support WebXR, the polyfill provides an implementation of the API in one of two ways. First, it offers a JavaScript-only implementation that works on any mobile browser that exposes orientation events, even mobile Safari. Secondly, if a browser implements the older WebVR API, the polyfill can actually emulate WebXR on top of it, taking advantage of the native hardware features that WebXR or WebVR already exposes. This means that you can instantly make your new WebXR content accessible to a much wider range of users simply by adding one script to your page. And WebXR isn't the only way that we're bringing immersive computing and the web together. With the Chrome 67 beta, you can now launch a VR-optimized version of Chrome straight from Daydream Home. We've put a lot of work into making browsing the traditional web a great experience in VR, but it also really shines as a way to browse immersive web content. The ability to hop from the 2D web to VR content and back at the push of a button makes discovering new VR content online really easy, fluid, and honestly, just a little bit magical. So, as we've shown, Chrome is fully embracing the immersive web, both through VR browsing and through VR web apps. But what about augmented reality? Well, to talk about that, let me hand it over to John Pallett.
Thanks, Brandon. My name is John Pallett. I'm a product manager on the Chrome team, and I'm going to talk to you about augmented reality. For those of you who don't know what augmented reality is, if you've tried out AR stickers in photos or used Pokemon Go, or if you've used Snapchat filters, you have already used augmented reality. Unlike VR, where you're completely immersed in a virtual world, the idea with augmented reality is that it overlays information into the real world. So if you've used any of these experiences, then you've already tried AR. Now, what's great about augmented reality is that there's over 100 million phones and tablets already available that support augmented reality, and that number is growing rapidly. And generally speaking, those devices already have web browsers. That means that augmented reality can be a real convenience for users. They can walk around, experience augmented reality, and they don't need to install a new app each time. It's great for developers too, because if you want somebody to try out your AR experience, you can throw up a QR code or a URL, and then the user can jump right into it, do the experience, and then leave. The web is going to make augmented reality super convenient and accessible for everyone. So that's great. The web is a great fit for AR. How many of you are web developers in the audience? Can I see a hand? Yeah. How many of you have a website? I hope that's about the same number, given that you're web developers. So the flip side of this is, OK, great, web helps AR, but does AR help you, a web developer? So there are actually a lot of ways that augmented reality can help you enhance your site. And I'm not going to talk about it anymore. What I'm going to do instead is show you what I mean. And I'm going to give you a preview of what's coming soon to Chrome Canary. Can we switch over to the device, please? OK, in this demo, good, it's working. In this demo, it's actually somewhat of a true story. In this demo, my daughter and I are researching in Mexico City, the Templo Mayor, and it was the center of Aztec worship and built in the 14th century. And the temple was built for both the god of rain and agriculture and the god of war. And so what we're learning about here is the use of chacmol statues, which are used to make offerings to Tlaloc, the god of rain. And so we're learning about that here, and if we go down on this page, what I can do is jump into augmented reality mode to learn more. And so it's learning about the scene, and what I can do is I can place a chacmol statue right here into the stage in front of me. Now, this really lets me get in and get a sense of the real-world sense of scale. In reality, it's 45 inches long and 36 inches high. And we can see it's actually life-size. It's a life-size representation of a human being. You notice on the website and through some of the other websites that we saw that a lot of them have this 90-degree head orientation. And so if I go into here, what we can learn is that that 90-degree head orientation is actually fairly common. But so is the pose, because this chacmol you can see is reclining on its back with its knees and its arms bent. And that's traditionally, in art forms of this time, a symbol of humility, of submissiveness, of being a prisoner. In this case, it's probably humility to the deity. There's a bowl for making the offerings here. And what's interesting is I can see little bits on the arms and legs representing iconography. Let's take a look at that. So this is interesting. So if you have a chacmol and it's celebrating the rain god, it's normal to see frogs and marine life and symbols like that. So let's take a look around and see if we can find any. I don't actually see a whole lot here. There's something interesting on the cheek. But there's not a ton of that kind of iconography here. So it's interesting to wonder, okay, well, how did they know that this chacmol statue was actually associated with Tlaloc? Well, if we go down to the feet, what we learn is that the feet are red, and they have a hint of blue in the sandals. And this coloring actually helped researchers connect. Here, let's see if we can get a better view of the blue. You see it's tucked in right there in the corner. So this actually gave researchers the clue that they needed to connect this particular chacmol, which was the first full-color chacmol that was ever discovered with the original paint, back to other pieces of artwork from the same time period, which talked about the rain god. This chacmol model was 3D scanned by SciArc in 2016 in collaboration with the Templo Mayor Museum. The data is available for anyone. You can download it, use it for educational purposes through the Open Heritage Project on Google Arts and Culture. Now, I want to stress this is not available to all Chrome users today. These APIs for this are in development, but what we want to do now is show you how to use them and get your feedback before they become firmed up. Let's switch back to the slides, please. So what you just saw was the ability to take an existing two-dimensional web page and add an augmented reality experience to it. This is straight up the biggest opportunity for web developers with AR, because it means you can take amazing new experiences and add them to your existing website. And there are a lot of different websites today that can get some value for users by allowing you to place virtual objects in the real world. Let me give you a few examples. One of them is shopping. In this case, we're looking at a furniture website, and it would let me place furniture elements into the real world. My family recently bought a new couch, and we ended up cutting and measuring pieces of paper and placing them on the floor to make sure that the couch would fit. I could tell you from personal experience, this would have been a lot easier. As you saw, another great use case is education, where anybody can drop an object into the real world and look at it. This is great for statues. There's a painting at the Louvre that's double-sided, where you can get a much better sense of what's going on. And as we explored that statue, I hope you saw you can get a lot more information and learn a lot more than you can from just a static image. There are a lot of other opportunities as well, such as avatars, games, AR stickers, and more. In a mobile context, there are tools that we can provide right now to you that will make your web pages more delightful and increase their value to users. This is coming quickly, and it will make the mobile device a handheld window into a new reality. So let's talk about how these APIs are taking shape. They're being developed in the W3C Immersive Web Community Group. It's a cooperative effort with a number of companies, including Google, Mozilla, Microsoft, Samsung, Oculus, as well as other companies and web developers. This is where the WebXR specification is being developed, which includes the VR APIs that Brandon spoke about earlier. But there are also some more bleeding-edge APIs that are being worked on within that community group. Some of them are more baked than others. I'm going to spend most of my time talking about the top two, AR Sessions and Hit Tests, which were the two building blocks of the Shakmo demo that I showed you earlier. You'll notice that Hit Tests are in the experimentation stage, where the other ones are still being proposed. So what that means is they're more than just discussion, but not quite ready for origin trials. And practically speaking, that the demo that I showed you earlier will work in Chrome Canary within the next week or two. Basically, by the time you get home and you watch this again on YouTube, it should be ready for you to try. When you do that, you're going to want to enable the two flags that we show here, the WebXR Device API flag and the WebXR Hit Test flag. So this is great. This means an early version of augmented reality is coming quickly to Canary. So let me show you how you can actually get started using it. Well, good news. Because it's based on the WebXR API, a lot of the code that Brandon already covered around VR applies here as well. What that means, things like capturing device pose, device orientation, and position are exactly the same. And so switching from VR code to AR code, it's mostly doing the same thing. So what I'm largely going to focus on here are the differences. The first thing to point out is that AR sessions are still in the proposal stage. We're still having conversations about the best way to do this. What that means is that when you enable these flags in Canary, you're going to have a temporary way of enabling AR mode. And you may recognize pieces of this code because it's similar to what Brandon showed you earlier when creating a magic window session, when that is not an exclusive session. Well, if you enable the AR flags in Canary, we're going to make the assumption that you always want AR. And what that means is that the camera will be rendered behind our geometry and kept in sync with the device pose. In the future, the community group is still discussing how we're going to extend and allow the declaration of an AR session. It's likely that the properties will be part of request session. It's not finalized yet. So just for now, if you're trying this out and you enable the flags in Canary, know that it will go into AR mode automatically as long as you create Magic Window, and it will keep everything synchronized. One other difference from Brandon's example is the frame of reference. Where in VR, you were using stage, which aligned with the floor. Here, you're going to use eye level. And what that means is that the first recorded position and forward orientation of the device becomes the origin. And every other motion is relative after that. The y-axis is always aligned with gravity, so it's perpendicular to the ground plane. But when you use eye level, it starts wherever the phone is, and then everything else becomes relative after that. And it's important to use that when you're trying out AR mode. So now let's talk about the real building block that allowed the demo to happen, which is the hit test API. It's the foundation of the demo that I just showed you, and what it lets you do is cast array into the real world and detect real-world geometry and shapes. So if I were standing here, I could cast array, and it would tell me that there's a podium there. It would also tell me there's a backside to the podium and a floor. I don't think it goes all the way to the mantle of the Earth at this point. So to demonstrate how we use the hit test API, think about a reticle. If you haven't heard that term before, what a reticle is, it's an indicator that's drawn on a real-world surface. In our example, this was useful because it allowed the user to figure out where they wanted to place the object in the AR scene. Now, what you're doing when you're drawing a reticle is you're continually doing hit tests into the real world and then using the results to place geometry into the scene so that it appears as if it's on top of a real-world detected object. Now, before I show you any code for this, what I want to say is that we are using 3.js, which is a helper library for 3D graphics on the web. It takes care of a lot of the heavy lifting for 3D geometry management and rendering, and some of the code we're going to talk through is specific to 3.js. If you're interested in learning more, you can visit 3js.org. In this case, what we're going to do is we're going to create a mesh or some geometry for the reticle. So that circle that you saw on this slide and the Chuck Moll-sized box before is actually 3D geometry with texture on it. And it doesn't really matter what geometry you use, so I'm not going to go into the details, and neither does the permission when you create it in the scene. All you have to do is create it, add it to the scene, and what we're going to do is update the position on the fly as we get back our hit test results. Everything we do next is going to be part of the request animation frame loop. And this is basically the same as you saw in VR, and is brokered through the WebXR session. So you request a frame, and then you execute on it, and at the end you request another frame and continue doing things that way. Now, a key part of this example is that we're going to be using our 3.js camera for a couple of things. One is obviously for rendering, and what we're going to do is update it with the view and the projection matrix from the XR device pose. This ensures that the camera is aligned with our augmented reality device pose and is using the correct frame of reference. So important for rendering, but we're going to use it for something else as well. In every frame, we want something to place our reticle on. And as I mentioned earlier, the hit test API will allow you to cast array into the real world and get back intersection points with real world objects. But to do that, we kind of need array in the right coordinate system with the right frame of reference. And the great news is that 3.js gives us a way of creating that, letting us take our camera and generate array from it. What we'll do is we'll use 0, 0, which in the coordinate system here is the center of the screen. If you're going to try to cast array based upon a user tap, you'd use anywhere from -1 to +1. But in this case, we'll stick with 0, 0. That's where our array, center of the screen, is going to go. And then we'll pass that in to the camera and get back array. The next thing we're going to do is use our XR session to request a hit test. This is the new API that is available when you turn on the flag, and this is the one that is going to be coming to Canary in a couple of weeks. When we do the hit test, what it's accepting is both the origin and the direction of the array. So you can see above, we extract that from the array that we generated, and it also accepts the overall frame of reference as a parameter. And what we get back is a list of hits. And they're ordered in terms of how close they are to the camera. So the first hit is the nearest one to the camera, and then they're sorted by distance. But we want our reticle to be on the first thing that we saw, not the last thing, so we're going to take that one. And then what we'll do is we'll use the matrix that we generate from the hit result and then apply that to the reticle model. And that's it. At this point, the reticle is now positioning itself in real-world objects within the request animation frame as you move the device around. Now let's talk about how to place objects in AR. There's one slight difference here that we probably want to consider. When we get back a hit test, what we get back is both the position of the hit, but also the normal of the surface that the ray detected. And we didn't dissect that before because we wanted our reticle to appear as if it was on the surface. But if you're placing an object in space, you probably want to specify your own orientation, especially which way is up, and instead of using the normal on the real-world object that was detected. The good news is with 3.js, this is fairly straightforward. And what we'll do is use the decompose method, which will extract the position, the quaternion, and the scale from the 4x4 method. Now that these have been extracted, you can change the orientation of the object to be whatever you want, either by generating a new 4x4 matrix or by setting rotation on the object directly. The key point here is that there are situations where you'll want to decompose the hit test result and use pieces of it. In this case for object placement, but in other cases where you want to generate an understanding of the real world within your code, you can get a lot of useful information from these hit test results. The last thing that I want to cover is an API which is only in discussion at this point. This is not coming in Canary, but it's really important to augmented reality, and so I want to cover it so that you have an introduction to it right now. This is a core concept to augmented reality, which is why we're going to cover it here. The concept is anchors. Anchors allow the augmented reality system to keep virtual positions and orientations, poses, always correct and up to date as the system learns over time. So what do I mean by that? What I mean by that is that if you think about the augmented reality system, it doesn't have perfect information. Everything it's getting is from the camera and from sensors and so forth, but it's learning about the real world. As I move the camera around and as it gets more information, it's improving its understanding of the world. But what that means is that sometimes it was wrong previously and it learns that later on. So that's where anchors come in. Anchors allow the underlying augmented reality system to keep track of poses that you care about and improve their accuracy later. So to give you an example, suppose that the augmented reality system thought my camera was here when I did the hit test, but later it realized the camera was over here. What it could do with that knowledge, if I anchored the object, was adjust its location after the fact when it realized its mistake. Anchors are also useful in a lot of other places. For example, when real-world objects start to move. As you can imagine, the whole concept of anchors is both very useful, but it's also one that's deep enough that it's continuing to go in conversation. So it's not ready for you to try right now. How to do this as a web API properly is a topic of conversation. But even with a hit test API, which is all that you saw, the session was being created and then a hit test API, there's a lot of opportunities for you to start looking at how you might enhance your existing web pages. The hit test I showed you can let you do pretty much everything on this screen now, shopping, education, and more. And really, all I showed you was placing one virtual object into the real world. There's a lot of information you can get from a hit test and a lot of things that you can do with that. And frankly, we're all really excited to see what you come up with and ideas you have for ways that you can make your website better. But this brings me to another point. There are over 100 million devices that do AR today, but not everyone does. So what do you do in that case? Well, I mentioned earlier that there's a lot of code similarity between AR and VR. This is really important if what you want to do is create a new AR experience, but then also make it available in VR for users that aren't using a device that supports AR. For example, a desktop that doesn't have a camera, and they're not going to pick it up and move it around the room. In that case, what you might want to do is have the exact same code driving a VR experience on desktop with a magic window. In that case, you'd have to adjust your user experience and your user interface. So instead of walking around with your desktop, you would give them controls to be able to zoom in and zoom out. But if you think about the Chakmol demo, you could still explore the statue and learn a lot from it. That ability to do progressive fallback is super important on the web, and we're really excited that WebXR allows us to do that without having to rewrite the same experience twice. So just to recap, Brandon and I have talked about the WebXR Device API, both for VR sessions, which are available for Origin trials today, and AR sessions, which are still in discussion. We also previewed some augmented reality APIs, which you can try in Chrome Canary. Actually, one augmented reality API, which you can try in Chrome Canary in a couple of weeks. As I mentioned, the conversation is still ongoing for sessions and anchors. And if you're interested in tracking that conversation, this is the slide you should take a photo of. Because we would like you to learn about this. What we really want is your feedback. We'd like you to try it out and let us know what you think. If you try the API and you want to suggest changes, this is where you should go. If you want to track how things are progressing, this is where you should go. Please do visit the community and file issues if you have questions, or file issues if you find things that you think should be different. Overall, though, we're very excited to see what you create with this, both for VR as well as for augmented reality.
Mike?
Oh, one.
And one last thing that we wanted to mention is that a lot of the 3D media that you saw on the slides today was taken from Poly, which is an excellent repository for 3D assets created by tools like Blocks and Tiltbrush. They're all available under the Creative Commons license, hence the credits. And you can check it out at poly.google.com.
If you want to get started with development, there's some links on this screen where you can see how the community group is progressing, as well as seeing code samples. The AppSpot link there is the demonstration that I showed you earlier. It will not work today. If you pull out your phone and go to Chrome Canary and turn it on, it will not work. Give us a couple of weeks. But please do try it out and let us know what you think.
Yeah. And if you have more questions for us, we'll be available at the web sandbox, which is over on that end. And thank you so much for joining us today, and please enjoy the rest of Google I/O.
Welcome to Google I/O. For someone like me who grew up without a phone, I can distinctly remember how gaining access to technology can make a difference in your lives. That's why we've been so focused on bringing digital skills to communities around the world. We have trained over 25 million people, and we expect that number to rise over 60 million in the next 5 years. Healthcare is one of the most important fields AI is going to transform. We announced our work on diabetic retinopathy, and we use deep learning to help doctors diagnose it. We can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. We've been working with our partners using de-identified medical records. Turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours earlier than traditional methods. It gives doctors more time to act. We are bringing another feature to Gmail, Smart Compose. We use machine learning to start suggesting phrases for you as you type. All you need to do is to hit Tab and keep auto-completing. Another product is Google Photos. So we are bringing a new feature. If you took a picture of a document which you want to save for later, we can recognize, convert the document to PDF, and make it much easier for you to use later. Or if you happen to have a very special memory, something in black and white, we can recreate that moment in color and make that moment even more real and special. And we are adding, as of today, 6 new voices to the Google Assistant. John Legend's voice will be coming later this year so that you can get responses like this.
At 10 a.m., you have an event called Google I/O Keynote. Then, at 1 p.m., you have margaritas. Have a wonderful day.
I'm looking forward to 1 p.m.
Today, the Assistant is available on over 500 million devices. Now, by the end of this year, the Assistant will support 30 languages and be available in 80 countries. But one step that we've been working on is something we call Pretty Please.
Hey Google, talk to VoiceTron.
Daddy, you forgot to say please. Tell me a story, please.
Thanks for asking so nicely. You're very polite.
I know.
So the assistant understands and responds to positive conversation with polite reinforcement.
Now, sometimes the assistant can actually be more helpful by having a lower visual profile. So let's say I'm heading home from work. I have Google Maps showing me the fastest route during rush hour traffic. Hey Google, send Nick my ETA and play some hip hop.
Okay, letting Nick know you're 20 minutes away and check out this hip hop music station on YouTube.
Let's say you want to ask Google to make you a haircut appointment. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. I'm really excited to announce the new Google News.
With the new Google News, we set out to help you do 3 things. First, keep up with the news you care about. Second, understand the full story. And finally, enjoy and support the sources you love. Our AI constantly reads the fire hose of the web for you, the millions of articles, videos, podcasts, and comments being published every minute and assembles the key things you need to know. We're also excited to introduce a new visual format we call newscasts. You are not going to see these in any other news app. Newscasts give me an easy way to get the basics and decide where I want to dive in more deeply. Full coverage is an invitation to learn more. It gives a complete picture of a story in terms of how it's being reported from a variety of sources and in a variety of formats. This is by far the most powerful feature of the app. And here in the newsstand section, it's easy to find and follow the sources I already love and browse and discover new ones. And if there's a publication I want to subscribe to, we make it dead simple. Because you're signed in with your Google account, you're set. We're rolling out on Android, iOS, and the web in 127 countries starting today.
Growth of Android over the last 10 years has helped fuel the shift in computing from desktop to mobile. And as Sundar mentioned, AI is going to profoundly change industries. And this brings me to the new version of Android we're working on, Android P. Adaptive Battery uses on-device machine learning to figure out which apps you'll use in the next few hours and which you won't use until later, if at all, today. With Android P, we're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. What's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. Slices are a new API for developers to define interactive snippets of their app UI that can be surfaced in different places in the OS. With MLKit, you get on-device APIs to text recognition, face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies.
Our team has heard so many stories from people who are trying to find the right balance with technology. One of the first things we focused on was helping you understand your habits. Android P will show you a dashboard of how you're spending time on your device. As you saw earlier, you can see how much time you spent in apps, how many times you've unlocked your device today, and how many notifications you've received. Android P lets you set time limits on apps and will nudge you when you're close to your limit that it's time to do something else. If you turn your phone over on the table, it automatically enters Do Not Disturb, so you can focus on being present. No pings, vibrations, or other distractions. You can tell the Google Assistant what time you aim to go to bed, and when that time arrives, it will switch on Do Not Disturb and fade the screen to grayscale, which is far less stimulating for the brain and can help you set the phone down. Well, today, we're announcing Android P Beta.
Maps was built to assist everyone.
We've mapped over 220 countries and territories and put hundreds of millions of businesses and places on the map. We're adding a new tab to Maps called For You. It's designed to tell you what you need to know about the neighborhoods you care about, new places that are opening, what's trending now, and personal recommendations. We've created a score called Your Match to help you find more places that you'll love. Your Match uses machine learning to combine what Google knows about hundreds of millions of places with the information that I've added.
Let me paint a familiar picture. Your phone says, head south on Market Street. One problem, you have no idea which way is south. So you look down at the phone, you're looking at blue dot on the map, and you're starting to walk to see if it's moving in the same direction. Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and Maps to reimagine walking navigation. So here's how it could look like in Google Maps. Notice that you also see the map, so that way you stay oriented. You can start to see nearby places, so you see what's around you. Now, with smart text selection, you can now connect the words you see with the answers and actions you need. So you can do things like copy and paste from the real world directly into your phone. You're at your friend's place, you check out this trendy-looking lamp, and you want to know things that match that style. And now Lens can help you. You open the camera, and you start to see Lens surface proactively all the information instantly. And it even anchors that information to the things that you see.
Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination.
Hi, IO Live, it's Todd Kerpelman, and I am here with Asad Naweed, who is a software engineer on ARCore. So, Asad, what's new in the world of augmented reality?
Hi, Todd. So today at I/O, we're announcing 2 new features in ARCore that we're really excited about. We are announcing augmented images and cloud anchors.
Okay, those sound very impressive, but what are they? What's augmented images?
So augmented images is a set of APIs inside ARCore that allow developers to create AR apps that can recognize images in the real world and then anchor virtual content with respect to them. So if your app can recognize an image, let's say this portrait up here, then it can make that image come to life and overlay virtual content on top of that image and make it do interesting things that weren't possible before.
So what kind of apps do you see taking advantage of augmented images?
One other thing that I'm really passionate about is education. And children's education in particular, you could create an app that recognizes the images in a children's storybook. And if kids previously, when they're just reading a storybook, can now point their cell phones at the storybook and then see the story come to life on top of their books, right there and then.
Alrighty, let's check out one of these demos here.
Yeah, so this is augmented images. And we'll see that ARCore finds this image and then makes it come to life like that.
Whoa!
So this is what I was talking about when I meant immersive experiences, is that as we move the phone slightly at an angle, we see that the 3D model actually turns with us. And if we end up going a little closer, we'll see that the effect is much more pronounced. You can actually take a look at the structure of the cubes as they are there, and it's so much more immersive than the standard 2D painting because now you have this box that's reaching into the wall and the image is no longer there, and it's actually been superimposed by this 3D model that's dynamic and can move, and I can get different perspectives on it depending on where I am. So yeah, that's what's really exciting about this.
And is this a phone with any special hardware, any special features? What is this that we're looking at this on?
So this is just a phone that's running ARCore, and ARCore doesn't have any specific hardware requirements, short of maybe just like a good camera and a good gyroscope and accelerometer, but that's about it.
All right, and here we have another augmented image. Let's see what's going on here.
Yep, so this is another image that the app knows how to recognize. And now that it's done that, we can see what grows as we move the phone up. And this then grows into like a massive tree that an artist has put together that's rooted at the augmented image. So if you keep going all the way up, you'll see that it becomes like a really, really, really nice tree. And as you bring the phone down, the tree will ultimately sink back into the augmented image that it detected. So these are the kinds of visual experiences and like things that come to life rooted at images that the app knows how to recognize. And that's what we're really excited to see what developers are going to do with.
Wow, that is super cool. I could actually just stay here all day and watch the tree grow and shrink, but I think I have other interviews to do.
No, you're more than welcome to come back when you're done.
All right. Well, if you need me, folks, I'll be hanging out here making augmented reality trees grow. And then the second piece of technology we were talking about were cloud anchors. So what is that, and what does that allow me to do as the developer?
Cloud anchors allow you to create and host anchors, AR anchors, and share them between different people and different devices. And that's really exciting because then suddenly you have the ability to create apps that two people can use together to anchor content in the world and see where other people have anchored content in the world as well. One other thing that we're really excited about is that the cloud anchors are actually cross-platform. We're also really excited to announce that anchors created on AR Core devices will also be recreatable on iOS devices running AR Core on iOS. And that opens up the door to so many different possibilities and a significantly larger user base. So now iOS developers can also use AR Core cloud anchors.
All right. So basically, we are setting up a multiplayer game where both devices, an iOS and an Android device, are agreeing on the same augmented reality space that they're sharing. Is that basically what's going on here?
Yes, that's exactly what's going on here, Todd. I have in my hand an iPhone that's running AR Core on iOS. And Brian has an Android device, and we are going to play the same game together. And
all right, let's give this a try here.
You can see right there is where Brian has placed his board, and I will place mine here. And when I am ready, we are now going to play a game where I have to fire onto Brian's light board. And when I do that, it effectively lights Brian's board up. And then he has to color all of my shots, all of my dots before I manage to do the same thing for him. And he is seeing these boards in the exact same place that I am seeing them in. And I can see him playing the game with me, and the only reason why this shared AR experience is possible is because of the magic of cloud anchors. Woo! So yeah, just to kind of like reiterate, this is an iPhone, it's not an Android device, and we do have AR Core cloud anchors supported on both iOS devices and Android devices, and we're really excited to see what developers are going to do with this.
That is super awesome. I can't wait to play some really fun augmented reality multiplayer games around my living room.
Well, definitely, and yeah, it's a blast for everyone, like the whole family, yeah.
Oh my gosh, that was super cool. If you want to see more exciting videos like this one, head on over to g.co/io/guide for lots more videos featuring me and the rest of the IO Live crew.
Hello, everybody. Wow, it's a nice stage. OK, well, I am delighted to be here. I have a clock. We're going to get to see Hannah Beachler after me, so that's going to be super awesome. I am the warm-up act. I'm John Maida. Good to see all of you. This is something I made 3 years ago. Does anyone know this TV show? No, you don't know this TV show. Well, I spoke at the 50th anniversary of Star Trek, and it was a true honor. Didn't think about Star Trek a lot. I made this, and people were asking why Scotty. And I was like, well, Scotty is an engineer, and I wanted to be an engineer. And I was asked, well, why not Sulu? Because he's Asian. And I said, I don't want to be Sulu. I want to be Scotty. I want to be an engineer. But it was in that moment I realized the reason why I didn't want to be Sulu is because I thought he was weird. In the sense that I thought it was strange how Sulu didn't speak with some kind of thick Asian accent on TV. And I thought, that's weird. Something's wrong with him. It always stuck with me. Why did I think it was wrong that he sounded like a Californian? I never thought of it until that moment. And that's a general topic of this presentation. Now, if you have a question and you got introvert, just text me your question, 253-217-4017, and we'll be able to interact. Because the problem with this kind of conversation thing is it isn't a conversation. It's like a one-way thing. So go ahead and text me a question at 253-217-4017, and I'm watching the clock. OK, here we go. OK, Design and Tech reports. There's 4 of them now. They're long. So you can read them in the microtype, et cetera. The big conclusion after 4 years of work has been to ask questions about how can design and tech be more inclusive. If we can figure this out, we can unlock incredible possibility and profitability. The problem with the word design, however, is that it means too many things. So the report defines design as 3 kinds of design. There's classical design, like your glasses. There's design thinking, this idea of using Post-it notes to create structure of ideas. And there's computational design, the kind of design that is powered by Moore's law. It's a different kind of design. It uses a material that didn't exist 100 years ago. What's a computational designer? I've defined this as roughly 4 type of things you have to have as a computational designer. You don't have to know how to program, but you have to be technically literate. You also have to think critically about technology. For you, technology is a responsibility. So you wonder how things are being used. You also use all kinds of design. You aren't stuck in just computational design. And lastly, you're very curious about new things. Because designers love to learn new people, new customs, new anything, because it's how they learn. So designers are inherently diversity positive. It's a very important point. Now, if you think about the value of design, it's been demonstrated by all the M&A activity, the mergers and acquisition activity of agencies. So I reported on this report, over 20 agencies were acquired by consulting companies, because consulting companies are finding value in design for their clients, which is a big deal. Never happened before. Now, the problem, however, is that classical designers tend to diss design thinking. You know what I'm talking about? Like, oh, design thinkers, they have the Post-it notes and the Sharpie markers with a whiteboard. You know, classical designers don't think of them as real designers. But I always tell classical designers, well, they make more money than you do. So important to note, design thinking is not a bad thing. It's a different kind of design. Also, I found that being in Silicon Valley for a while, we tend to forget there's the rest of the world. So I'm a big fan of China and all the design work being done there. Design of cars, design of experiences, especially mobile, and more recently, using AI to design banners, designs. They're just so further ahead than many people seem to have the impression in the United States. And that's kind of an embarrassing problem. Also, the other problem I've seen in tech is that it indexes to younger people, which is a great opportunity. But there's also an incredible opportunity in the older generation. Because I don't know if you all know this, but you all will get older. Yeah, it's not a problem. It's a real thing. And as you get older, things change. The first thing that changes is your eyesight. So for all designers who love 6.5 point, better give it up. Looks awesome, especially in light. But you won't be able to see it once you hit 40-something. And at Automatic, we call this the bolder generation. Get it? Bolder? We like that. OK. Good news is that design is being used sooner in the process. It used to be in tech that you'd make the technology, and oh my gosh, it finally works. And you'd spray design on, called Make It Pretty. That was great 10 years ago, but because the competition is so fierce now, you have to bake design into the product. And you can see globally, we did a survey of 2,000 people, the trend is design is being used early in the process, which is a big deal. Now, when we talk about computational design, however, it's important to note that computational design uses the computer. And if you were, who was there in the 80s, come on, 80s people, right? People didn't like people who used the computer for design, right? You're made fun of, like Rudolph the Red-Nosed Reindeer. You were a bad designer because you were using the computer. There was a time. But the computer kept on getting more interesting. It came out of print. It became interactive. Who remembers Macromedia Director? Macromind, come on. Yes, yes. This stuff has been happening for a long time, interaction design. More recently, have these tools gotten more interesting, specifically by integrating things like machine intelligence. We can all feel it coming, and that's kind of exciting, but also scary at the same time. Let's see here. OK, so when we think about machine intelligence, my favorite demo, and this is all sourcing real data off the internet, this is Siri saying something in iOS 9.
1 liter is 33.81 fluid ounces.
This is iOS 10.
1 liter is 33.81 fluid ounces.
This is iOS 11.
1 liter is 33.81 fluid ounces.
Got really good fast, didn't it? That's what's happening. These quantum leaps are occurring. Linearity is being thrown out, and that's really important. And so when people ask in design, should I learn all these things? If you don't learn them, you'll be left behind. And so it's so key to stay at the forefront. Now, I also had this question. When do you expect AI to replace most visual designers? And it's interesting because the average says at least 5 years till visual designers get replaced. Not everyone, of course, but some design jobs. I think it's going to be much sooner, quite frankly, because all the information from companies like Google and companies in China as well are that a lot of rote things can be done by machine intelligence. Here are some of my favorites. I love that you can remove the watermark. I wonder why you want to do that. You can perfect contrast. This is MIT work. In a dark image, awesome image. You can also take 2 photos and make a new photo out of them, too. This is work from NVIDIA. You can also generate infinite variations of ideas just with pattern libraries in machine intelligence. You can also, as you all know, in this audience at least, you can change people's faces, and you can fix drawings. What's important to note, though, is that we see these warnings. Consider the photos. That's how you tell if it's fake. But it's so hard to tell if things are fake these days. It's going to get harder and harder. So we are human beings. We like to mess with the machine. So this is one of my favorite things. If you click on this button, this will randomly hit things so your browser gets confused. So we humans love to confuse machine intelligence. Put a pixel there. I don't know where it is anymore, says machine intelligence. So we'll keep looking for this to try to stop the inevitable, which is that computers are learning so quickly. And when they learn so quickly, they learn bad things. I'm not sure if you remember it, but in July 2015, the Wall Street Journal reported how images mistakenly tagged black people as gorillas was happening in 2015. The algorithm was fixed. Why did it exist? Because the database had more light faces than darker faces, so the database was dumb. And so these data dumbness is occurring all over the place as machine intelligence ingests more data, which contains incredible biases that we have unfortunately let sit out there for too long. So how do we change that? I think we change that by rethinking a few things. And that is, where does technology evolve the quickest? And in the report, we pointed out that there's 2 regions. You see the red regions, the hot regions? That's where all this stuff is happening, right? This region of the country, New York. But if you flip the map, this is a map of inequality, income inequality. If you flip it, you see the exact opposite, that where tech is not impacting is where poverty is growing the quickest, because the skills gap is so large. This audience here is probably in the 0.01% of the most advanced people in the world. That said, the entire world is behind in computation, understanding the impact of Moore's law. And this is a very subtle intellectual privilege problem today. So when we look at what technology has done, it's been able to be extremely smart at optimizing our experience, and therefore making nothing we understand, real or not real. And we all know it's happening, and it's amazing, but it's also quite disturbing. My mother, by the way, her favorite newspaper is the National Enquirer. So I'm always checking out the headlines. I just picked this up. Look out, Google. They know too. So is a digital divide related somehow to poverty and inequality? I think it's hard to say they're related or it's causal or correlated, but there's something connected that we cannot miss. And that is that if you don't have access to computation, you are excluded. And if you don't understand what it can do, you're excluded. And so technology keeps shooting off without them, us. So what's the solution? I'm passionate about remote work. I'm at a company that is all remote, automatic. Who works remotely? That's quite a few. So remote work is neat because it takes you out of these bubbles of tech. I guess I'm hopeful that at Automattic, we're trying to figure out a world where WordPress is a good design for all. How do we do that? We have to use the fact that we can go anywhere because we're remote. So for instance, let's see, I was visiting Appalachia. And in Appalachia, I heard the story about how it was a coal miner who's teaching code to ex-coal miners. And he said, you know, you people are from the 3-dimensional world. You're 3D. You live in cities with skyscrapers, you know, and if you're from a smaller city, you're in a town, you live in 2D. In 2D, you have like no skyscrapers, just streets. And he said, here in Appalachia, we live in 1D. There's one street, and we all live off of it. That's where I realized the neat thing about remote work is you're 0-dimensional. And by being 0-dimensional, you can travel anywhere. And so we're trying to use this advantage to go into all kinds of places, anywhere in the world, and to connect with people. And I can tell you that this experience of being remote is a very powerful way to reduce exclusion, because you can be including by just going anywhere you think is necessary. Now, this is my favorite quote by the lawyer Vernay Myers. Diversity is being invited to the party. Inclusion is being asked to dance. Say this over to yourself. It's such a powerful idea, because if you don't have both, nothing occurs. And so when you ask how to be more inclusive, it's quite easy. Just ask, where do you spend your time? Who do you hang out with? Look at the people in the room around you. Are they diverse in some way? If they're not, you're going to have to do something terrible to yourself. You're going to have to make yourself uncomfortable. And it's exciting to be uncomfortable. Oh my gosh, you say the dumbest things. And you stumble, and you become stupid, and you become smarter and a better person through it, I believe. So all of you who are not found yourself in this way, enjoy it. It's so exciting. I'm a big entertainment fan, and I've been tracking all the movies that have put diversity and inclusion at the center of them, and they're doing very well financially. Movies like Wonder Woman, directed by Patty Jenkins. Star Wars had a much more diverse cast. The Foreigner by Jackie Chan. Who's seen The Foreigner? The Foreigner, where the terrorists aren't dark-skinned people. That was brand new. And The Big Sick, of course. And these are doing really well financially. This is teaching machine intelligence and the business world that this is a pattern to take note of. I like Kumail Nanjiani's quote, there's so many movies from different points of view that are making a ton of money. Don't do it because it's better for society and representation, even though it is. Do it because you'll get rich. you'll get that promotion, right? This thinking seems crass, yet it sits at the center of how change will start to occur. And I believe that as we see more of these kinds of things, wonderful things will happen. I want to close on, my mother went to see Black Panther. This was her review. It went kind of viral. Hi, John. Just came back from seeing Black Panther. It was very good. And we actually went to see Avengers me and my mom. I was in Seattle. My mom's like 83 years old. She's like, little woman with a cane. We're walking out of Avengers. And I said, Mom, how was it? Oh, it wasn't as good as Black Panther. So anyways, thank you. And we'll have Hannah next, so please stay seated.
This is nuts. Look at all the faces.
Wow, I'm so happy. I get to interview Hannah Beachler. Yes.
Yeah, all right. Hey, y'all. Good to be here. And this thing is a little weird, so you might see me kind of being a little weird.
So how's it been walking around this area?
I'm sorry?
How's it been walking around?
Cool.
Wandering
we
around,
went, hung out at the auditorium, and walked around some of the tents, and ate, and sat on the grass, and it was fabulous.
Anything catch your attention?
I mean, I was just looking at everything. The area is beautiful, and I think everything has been great. I've been talking to some great people, and it's been awesome.
Hmm. So, my mother loved Black Panther. I'm sure you weren't surprised, though.
What? I'm sorry?
I'm sure you weren't surprised.
That your mother loved it?
Yeah.
Not really. Honestly, that was part of what we tried to do was, make it so everybody could love it. It wasn't really geared towards one specific anything. It was more about creating a feeling and a moment, and you know what I mean? I'm pretty into my emotions. I would call myself an emotionalist, if you will. And that's really what drives me is, creating things from a place that people can relate to. And then that, expands.
Had you heard of Black Panther when you got the job? Or?
Yes, I did. I had heard of the character in the comics, and I kind of knew it because I knew Marvel. I've certainly asked my son, who's 20, right away when I knew I was going to interview for the job that, tell me all about, the MCU and all of that. And he was like, here's a Marvel dictionary. And I sort of started from there. So I knew of him, but over that 14 months, I really got to know him.
So a superhero.
Superhero.
Was your reaction positive, yay, superhero, or superhero?
My reaction to it being superhero?
Yes.
I mean, I was really super excited because it was challenging. It's, I've done so many things that are so different from each other that anything that is going to challenge me, I instantly want in on, and working with Ryan Coogler, the amazing director, again for the third time, was, without question, I was going to be involved with that. So I never thought I would ever do something like a superhero movie. That's not where I saw my career going. That's not what I thought I wanted to do, but then that's life. It's not really what you think in the beginning. But as, I started to get into it, I was like, why not? I didn't think I would do a boxing movie. I didn't think I would work with Beyonce. I didn't think I would, work on a little $1 million movie that would win an Oscar. So I don't generally go into anything thinking anything other than how do I make this work? How do I make this the best it can be? And, for each film, it's something different. So for Panther, there was a reason behind it for Ryan and I, and same with all the other projects.
So you had to look 1,000 years in the future. And you didn't come to Silicon Valley to look at that future.
No.
Talk about that.
Well, first I had to look 1,000 years in the past. That was a big part of Wakanda, was the honoring of the culture and the tradition and the diaspora, the African diaspora, that really is what Wakanda is representational of. So I had to look backwards because I think the past is a very important bridge to what the future is. And that needs to inclusion in design, in this world of what I was doing for Black Panther. Looking into the future, I didn't know, and you know what, honestly, I didn't know that Silicon Valley could help me for my needs. I didn't think that I was going to find in there, and honestly, I didn't really know much about it. I live in New Orleans. It's a very small town. I don't live in Los Angeles. I don't live in New York. I live in a place where the population is like 250,000 to 300,000 people. You know, I didn't know much about Silicon Valley. I kind of knew what I saw on TV. Sounds familiar. But I didn't really know how that could help me create this technology, which you would think was kind of crazy. Because what I knew I needed to do was evolve something that Silicon Valley, to me, I felt had no interest in, which is this culture. So there was, you know what I mean? I felt like I kind of had to give an autonomy and to this story and a narrative that at times is restricted. Just in general by society, like the ability to tell communities' ability to tell their own story, how they want it told, and based on what they want it based on. So that was sort of me kind of being the person who made sure that the representation of the culture that we were digging into and creating a fictional one on top of it stayed to what I needed it to be, and I didn't know that Silicon Valley could help me. Now, I did reach out to a lot of experts about all kinds of stuff, geology, geography, archaeology. We talked to experts in architecture who were doing future cities, people who were sort of architectural archaeologists that could talk to us about some of the architecture, you know, pre-colonial sub-Saharan Africa, and then of course going to South Africa, traveling all over South Africa for 3 weeks and sort of understanding that, because at the heart of Black Panther was the question of what is it to be African, and so that's sort of, you know, why I felt like I didn't want to go or need to go to Silicon Valley. I don't know if that is like, and I mean, that's honest. That's the honest truth. And because I was so busy, I was like, you know, I'm just going to have to do this. I'm just going to have to figure this one out. And I didn't really know. 1,000 years into the future, here's the thing. It's hard enough to go any amount into the future and understand what you think might happen or how people would respond. So I found myself getting to this place where I started thinking about technology in the future, how Wakanda would use technology. Technically, Black Panther is placed in 2018. It's not sci-fi. It felt sci-fi because Wakanda, you know what I mean? We have to remember it's not science fiction. It's supposed to live in this universe, which is 2018. So I had to make sure it felt grounded enough that people weren't like, it's space. But it also had to be advanced enough where people thought, maybe this is something that's going to come around in 50 years, 60 years or something. It's not impossible, you know. And then you had to add sort of with the vibranium, the fantasy of it all. So, you know, and I'm rambling, so I don't even know if I answered the question, but, you know, that's sort of, I might have lost myself on that.
Actually, when you were describing that, I remember walking my mom out of the theater, because she can't walk very well, because she has diabetes and her feet are really, makes it hard. So she's walking really slowly and talking really slowly. And I remember when we just left the theater, she said, you know, Black Panther was so beautiful. All the scenery, everything was so beautiful. And it's a thing that stuck with her, how beautiful the movie is. And it's optimistic. And so where did that come from and how you were able to translate that?
I mean, I like to do things that are beautiful, you know, and I think that's another part of Black Panther is changing this idea of narrative of how we see things. You know, it was a challenge to me of how I saw Africa, what I thought about Africa. Just because I'm Black doesn't mean I'm an expert on African culture, right? So I really had to dig in and challenge myself about like, okay, well, what do I think? What are my biases? What was I raised with? From my American experience, this is a land that's 1,000 miles away, and as far as I know, my ancestry begins and ends at slavery, and then the culture that came afterwards was this bastardized idea, or we were told it was a bastardized culture. We're not African, we're not American, so it became this bastardized culture in a sense, right? And you go through all of these different points in time throughout American history. So I needed to rediscover like what that was, thousands of miles away from where I live, and how I'm connected to that, because oftentimes you feel like the hyphenate between the African and American, you're really not either one. So it was, what is it to be African? Because this is a movie, Wakanda's African, and it's not African American. And, one of the little things that Ryan was so brilliant at doing in the film with Killmonger's character, who's the villain, if you haven't seen it. Has everybody seen Black Panther? Is that a thing? Awesome. So Killmonger, played by the fabulous Michael B. Jordan, if you notice something about him is his names. And part of the reason behind him having so many names is because, our American ancestry is that we have been given so many names. We were Negroes, we were black folk, we were colored, we were Afro-American, we were African-American. And that's sort of how this has gone over time. So what Ryan did was he gave Michael Jordan the Njidaka name, but they also called him Eric. They also called him Killmonger. They also called him Eric Stevens. So he's that representation of African American, never having a true identity. From different places and different people called him different things. And that's the tie back. And those are the types of things that we were trying to do. That is a piece of representation in a sense. And we'll get to representation because I think that's mostly what we want to be talking about is how that is so important in Black Panther, right. Technologically, scientifically, through your STEM, and then also socially and economically. And so there's so many little things that we did in there. I mean, it goes so deep into how we brought in the representation, and that was one of them. And it was in such a small story way that you don't even really realize that's what's happening, because Shuri calls him Eric Stevens, T'Challa calls him Njidaka, his father calls him, Ross calls him Killmonger. His father calls him Eric, So it's he doesn't have an identity, and he's going to Wakanda to try to figure that out. And that's sort of the representation of where we are as sort of the lost tribe, as we called it. I'm
such a Ryan Coogler fan, so I'm like, I can see that detail. I didn't see it when you described it. When we were talking last week about representation, yes, you mentioned the production designer Wynn Thomas, and I looked up Wynn Thomas. I hadn't heard his name before. And he has credits for Hidden Figures, A Beautiful Mind, Analyze This, all of Spike Lee's movies. So you mentioned seeing him on television or something?
I saw he was nominated for an Academy Award for Mars Attack, the Tim Burton film. And I happened to be watching the Academy Awards that year, and I was like, oh, who's this black man doing this thing that I want to do? And that was really the first time that I really saw that. I was like, oh my goodness, what is this? Because I'd always been a big fan of Bernardo Bertolucci, who is an Italian director, back in the 50s, 60s, 70s, and in 80s. And his designer, Fernando Scarfiotti, was someone who was really a big influence to me. He was this Italian man way back when, but my design aesthetic, is highly influenced by his. But seeing him never made me feel like, yeah, I can do that, because he's this Italian guy. You know what I mean? Like, of course he can. He's an Italian guy. Like, I'm this farm girl from Ohio, who literally runs around with bare feet and riding my horse to the store to get Jolly Ranchers when I was like 6. Like, how do I get to that? Right. How do I get, there's no path for me there. So I kind of started thinking, like, what are some of the other things that I could do where there might be a path that's still creative, and that's how I had to think, knowing that that wasn't something that was for me. But then when I saw Wynn, which was much later in my life, I was that's when I realized, like, you know what, I can actually go for this. I mean, that didn't actually mean that I could go for it, but seeing it certainly made me feel that way. And I took that chance, and that gave me an opportunity to get into this industry and really go far. I mean, as I got into it, I realized, like, oh, this is really hard. I'm the only one, and I am the only one. And that's a really strange thing to think that you are the only black female who does this, who does what I do, and at this level. You know, there's one other one, Tony Barton, you know, and she's an art director working on television for Marvel. And I kind of saw her on Twitter, and I was like, you know, like, let's be friends. And she's like, I don't even know you. And I'm like stalking her on Twitter, like, I want to be girlfriends. And she's like, okay, maybe call my agent. Maybe don't. But we finally kind of, like, I broke her down, and she finally decided to be my friend. And we're kind of besties. Don't quote me. And don't go up to her and be like, Hannah said you were besties, because she'll be like, I don't know who she is. But that's, you know, you want to find likeness. You want to find relatability. And when you look at communities, I think, you know, one of the other things, too, is when you look at communities who are associated with not, like, having a lot of tech and not, you know, having access to a lot of tech, and you start relating, you know, your economic status to your racial profile, that all of a sudden, especially in poverty, the black community becomes associated with this idea of not being tech savvy or wanting tech or having that type of thing. Do you know what I mean? Within their community, and it's basically all based on accessibility. It's not there because how many representation is not just in front of whatever it is, you know, or like throwing the pretty on it that seems to be representing a group or a culture, but actually having the voices creating it. You know, is it how, you know, you look at it like, was it important for me to be the production designer on something like Black Panther? You know, or the Infinity Wars designer Charles Woods, would he be able to have then done that? And so I do believe that the representation behind the camera, I'll say, because that's what I do. I mean, behind the desk, I don't, you guys stand, or I don't, I don't, you know what I'm saying? Or however it goes, is as important as creating an app or creating something, you know, specifically as having the voices there that then has the experience in those communities. Because you really don't know what you don't know, and that's what I learned by going to Africa. Like, I don't know what I don't know, but I knew that I was going to look at it with beauty. I knew I was going to look at it with the lens of absolute modernism and beauty and capability, all the things that I wanted to put into Panther. Like, I wasn't looking for the commercial with the poverty-stricken children. I wasn't looking for the things that we're told the continent is. I was looking for the joy and the pride and the dignity of the people that lived there. And, you know, that's the choice we make for wherever we are, because I met people who lived in the rural parts of Africa just as much as people lived in the modern cities like Johannesburg, and you know, we were in Durban, we were in Cape Town. So it's you know, you could see someone dressed in their traditional Zulu or traditional Xhosa, and in the city. You know, just as much as you might see that in the rural areas. So I decided not only to find myself and realize that I think I've been African this entire time, but that I was determined to find all the beautiful things that I, you know, was told weren't there. You know, because that then really came back to who I am as a person. You know what I mean? It really related back to who I am and how I felt about myself and the confidences I had. So it all kind of, like, our fictional world building bleeds back into our realities.
We have 2 minutes left. Could you share a nonfiction story you shared with me that moved me very much, which was about the director Ryan Coogler, who I'm a huge fan of. And I've always, when in Silicon Valley we talk about leadership, you know, CEO, or the product manager is the CEO of the product, and all these CEO-ish things. I think of Ryan Coogler as one of the great CEOs of our time and creatives.
Yep.
And you shared a story about him. Could you talk about
when
that?
I was talking to myself?
Yes.
So you obviously know I'm kind of weird. So I'm going to tell this story. Don't hold it against me. But so we're working on Creed, and we're tech scouting, which is kind of we go to look at all these locations, and you can spend all day. And we had stopped at this coffee shop. And I got my coffee, and everybody was getting their coffee, but I was kind of working out a problem. And when I'm trying to work out a problem or solve a problem, I talk out loud to myself, because that's the best way to do it, for me, apparently. And, you know, my friends and stuff were like, poke fun at me, like, oh, you're crazy, you're talking to yourself. And so, you know, sometimes I do, and I don't even know I'm doing it. So Ryan comes walking over to me, and he was like, are you talking to yourself? And I was like, you know, a little like, oh, you know what I mean? I know you and love you, but yeah. And the first thing he said, he looked at me and he said, that's a sign of a really healthy mind and a really intelligent person. And he kind of turned around and walked away. And I was kind of like ready to get the hit of like, oh, you're crazy, you know, kind of funny joke, but a little bit like of a slight. And that's not at all where his mind came from. It looked for the immediate positive thing about the thing that I was doing that sometimes people think is weird or could make you feel a certain way about yourself that eventually starts beating you down and making, you know, defining who you are because you're hearing negative things about it. That is who Ryan is. He's the person that will constantly lift people up, you know, will constantly, and he's not perfect, I promise. There's days when I'm like, please make a decision. You have like 2 hours. But, you know, and he does all the things that directors do that can, you know, completely bother you or things that are like amazing. But he's the type of person, like we would be on set for Warrior Falls, which was the big waterfall where they had the big fight. And he gathered us all around in a big circle. You know, some people were in the water, and he really told us why that scene was important. This is before we even started shooting. He really started to say why that scene was important to him, and really talked about having all the fictional tribes of Wakanda in one place and represented by all the references that we use of the tribes, the different tribes in sub-Saharan Africa, and how that was a big part of him really feeling complete. And you know, you were holding hands and he's telling us all this and we're standing in this circle and you just feel like you can take on the entire world, you know, at that point. So that's who he is as a director and my friend. And he's a really important voice because his perspective on anything and everything is the most unique perspective you will, I promise you, ever hear from anybody. If you ever get a chance to talk to him because he will turn a situation and make you see it from a side you were never maybe even meant to see it from, and all of a sudden your world opens up. And so I can always, and he would be standing here going like, oh, please stop, but but he is really that great. So
well, thanks for sharing that story. What a leader and what a designer. Thank you, everyone. Thank you.
Hello, IO Live. Todd Kerpelman here, and I am joined with Abe Haskins, who is a developer programs engineer on the Firebase team. Hi, Abe.
Hi, Todd.
So what is this exciting game that we see going on behind us right here?
This is AppShip 2018. This is a Firebase-powered multiplayer arcade spaceship thrilling game.
Extravaganza.
Extravaganza, yeah. It's a phenomenon.
That's what I was thinking. And so how is this game making use of Firebase?
So we started weeks ago when we generated thousands of custom rocket ships that we turned into sprites, which we turned into cards, which we got printed. And we did that all with Cloud Functions and other Google technologies. And then once we had those printed, we built scanners that can scan the cards using the new ML kit from Firebase. Then we made a game which received updates from the scanner using real-time database. Once you're in the game, it loaded your actual sprites from cloud storage for Firebase. And once you're in the game doing stuff, it shoots out analytics to Google Analytics for Firebase. So it's all Firebase through and through.
Yeah, I noticed every attendee here is getting a appship.io card, each one with a unique rocket on it. Did you design all these rockets by hand?
I basically did, yeah. Whew. We made a tool that allowed you to go and mass produce rockets by picking and choosing parts that went together.
This is mine with my custom spaceship. And basically, when you scan it in at these scanners over there, everybody just sort of has their own spaceship magically appear in the game. Yep. And so that's all being powered through Firebase.
Yeah, it's all being powered through Firebase. Like I said, we use Cloud Functions to actually generate the sprites, generate the cards, and we had the cards printed, and we connected all the cloud storage, real-time database, so we're writing back when you scan it in. We have history on all the cards.
So there's a lot that's been going on with Firebase. What are your highlights of the things that have been happening with Firebase over like the last year?
Well, I personally normally work on Cloud Firestore, so I was super excited that we got to launch that. But we also have performance monitoring for keeping an eye on your app. We have A/B testing for trying out new things. We have ML Kit, which is obviously a huge, everything about ML is exciting and awesome, and I'm glad I got to use it a little bit here. Basically all that. We have so much cool stuff coming out.
Excellent. Well, I'll have to check out more of it after I play a little appship.io and I don't know, kick your butt in it. All right, let's give it a try. So every attendee at I/O this year has a unique appship.io card that they can get here at the Firebase booth, Dome, and every card has a unique rocket design on it. So when you scan this QR code at one of these scanners, my special rocket will appear on screen there. That's me.
No matter what kind of app you're developing these days, there's a good chance you'll want to store your data in the cloud. Maybe that's because your users want to share their data with their friends for some exciting in-app collaboration. Or maybe it's just because they'll want to access their data from more than one device. But storing data in the cloud isn't quite as easy as it first looks. You have to set up your own servers to host the data and keep them up and running day and night. You got to spend a lot of time on the client dealing with networking issues, including making sure everything still works when your user goes offline. You need to stay up all night wondering if you've gotten your security exactly right. And spoiler alert, you probably haven't. And then you need to make sure your service can scale no matter how many millions of users you might have. All of which is time you don't get to spend on building your app. This is where Cloud Firestore comes in. Cloud Firestore lets you store your data in the cloud so you can sync it across all your devices or share them among multiple users. And it comes with all the conveniences you'd expect from a Firebase product, like robust client libraries, full support for offline mode so your app will continue to work just fine whether you're connected or not, even on the web, a comprehensive set of security rules to help you manage access and sleep at night, and an easy-to-use data browsing tool. It also lets you structure your data in ways that make sense to you thanks to its powerful querying and fetching capabilities. Cloud Firestore works in near real time, automatically fetching changes from your database as they happen. Or you can request and fetch data manually. It's completely up to you. Cloud Firestore brings you the best of Google Cloud Platform's powerful database infrastructure with features like multi-regional data replication for extra reliability, strong consistency to make sure everybody's on the same page, and multi-document transactions so you can perform complex operations on your data. And we've designed it to handle the toughest workloads from the world's most popular apps so it can scale automatically to support yours. But it still integrates with other Firebase products, including Firebase Authentication for easy sign-in, and Cloud Functions, which lets you run all sorts of server-side logic in response to changes in your database. all of which means you get a truly serverless development experience. And that means you can spend less time on infrastructure issues and more time building your app. So give Cloud Firestore a try today. You can find all our documentation here, try a sample or two, and start building something great.
Stability issues can derail the success of even the best apps. Buggy apps make your users unhappy, and they might uninstall your app, leave a bad App Store review, or write negative social media. Apps can generate a lot of different crashes, and manually tracking them is time-consuming. Even if you're able to collect all of this data, it's difficult to figure out which crashes to troubleshoot and fix first. Firebase Crashlytics helps by automatically collecting, analyzing, and organizing your crash reports. It also helps you understand which issues are most important so you can prioritize those first and keep your users happy. It combines a real-time dashboard and alerts to keep you aware of your newest issues and any sudden changes in stability. The dashboard shows crashes ranked by overall impact on your users, giving you the information you need at a glance. Crashes are intelligently grouped across versions of your app, with individual stack traces easily explored in the dashboard. Sometimes you might hear about crashes from users that you can't reproduce. With the help of logs and key value pairs in Crashlytics, you can add some context to each stack trace and see what your app was doing before the crash. When the crash is reported, this extra information is sent to Crashlytics, becomes visible in the dashboard, and gives you the context you need to help pinpoint the exact cause of the crash. Non-fatal errors can be reported in the dashboard too, so when your code fails but doesn't crash your app, you can still get full reports in the dashboard. If your app is built with the NDK on Android, Crashlytics will capture native stack traces as well. Crashlytics is easy to integrate with 0 lines of code required on Android. With iOS, just use CocoaPods for simple integration. You can count on Crashlytics to help stay on top of the stability of your app, spend less time troubleshooting issues, and more time doing what you love with Crashlytics. And to learn more and get started with Firebase Crashlytics, check out the documentation right here.
right, how's everybody doing? Wow, you guys are very enthusiastic. Fantastic. My name is Terry Ryan, and I'm a developer advocate for Google Cloud Platform. And my mission today is to kind of walk people through what is a typical journey to taking an app that you've had somewhere else and bringing it to Google Cloud. And my focus is on virtual machine technology. So a pattern we see from a lot of people is when they first come to GCP, they want to do what they've done elsewhere, but on us. So how do you do that? How do you get started? That's my goal today. So if that's what you signed up for, great. If not, well, hopefully you'll stay. So before I get started, it's really important for me to know who everybody in the audience is, and I'll probably do this with just a show of hands. So who here is a developer all the time? Okay. Web developers, mobile developers, back-end developers. Okay. How many people here do systems work? I see some overlap with the developers. Is it because you love DevOps, or is it because your company won't hire more people? Which is it? Okay. Anybody else? Any other, are there designers or UX people, UI people? All right, fantastic. Anybody who tells any of these other people what to do? Any managers in the room? Okay. So there's a lot more of us than there are of you. So one, manager jokes fly. And two, I hear your systems people could use some more people. Just I hear that from the crowd. All right. So I know what jokes I can make. I know who you guys are. What are our goals? Our goals are to take someone from a journey. I've got an app, and I want to get it on Google Cloud Platform. That's my primary goal. My secondary goal is to sort of point out a whole lot of things about GCP along the way. But that's a secondary goal, so I'm going to fall way short on that. There's a lot of GCP that I'm not going to talk about. Hopefully, I'll point you in directions where you can, if you like it, you can start learning more and go that way. But just be aware that this is not super comprehensive. OK, so you have an app. You have it running someplace. We usually do what we call lift and shift, where we pick something up and just plop it on our cloud instead of running it on your own data centers. So I want to show an app here. So I'm going to switch over to my laptop. And this is a super, super simple app called Tagger that I wrote, just to kind of, it's minimum viable product, right? It's just to show what I'm trying to do off here. So you see you have a bunch of tags and a bunch of kids because, you know, you can always get points from the audience from showing cute kids. I'm going to go ahead and just show you that this is a real thing. It's running locally on my laptop, but it could also be running, you know, in a data center somewhere in my own on-prem center. So I'll hit Gladiator, I'll hit open. Nothing up my sleeve, I've got a real app here running. I'll upload, and there we are, app is working. Now, I'm going to switch back and talk a little bit about the architecture in slides. So, very, very basic, simple app. Again, written to illustrate this stuff. I've got one single box, which may or may not be the way you want to run your stuff. If you are, it's OK. And if you're not, please don't judge me too harshly. So I have a single server here, and it's running the application code, it's running the file system, and it's running the images, right? All of that is on one space. And I want to move this to make it cloudy. So our eventual destination with this will look like this, where my database is in the cloud and my files are in the cloud, but my app still sits on a VM, which also is in the cloud, but you know, is still a virtual machine. I'm not trying to get you to move to Kubernetes or serverless or anything like that. Well, I'll talk about those topics, but we're not going to move to them in this app. So, OK, so we talk about virtual machines on Google Cloud Platform. We call it Compute Engine. We have several engines. Compute Engine is our virtual machines. That has some properties and some things I'm going to talk about. You can dial in how many processors you need from 1 to 96. And then you have a range of memory based on that from 0.6 to 624 gigs. You have disks. You can install 64 terabytes of persistent disk, 3 terabytes of SSD, and you can go up to 208 gigs of RAM disk with the memory on your system. Now, we have images that go with these machines already that have operating systems already set up. But you can configure your own, and actually, I'm just going to show that off in the interface. So I'm going to switch to do another demo. And you should, it was working 2 seconds ago. No, all right. It's working. All right. So I want to go ahead and create an instance. I'm going to create a new instance that I want to run my stuff on. So I'm going to hit what's labeled here, create instance, kind of a little on the nose. So I'm going to go ahead and create instance. When I do that, I can give it a name, and I can put it in a data center. So why don't we do US West, because that's where we are. But note, we can go all over Asia and Europe and South America and Australia, but I'll stick to being close to here. Now, when I go to set up my machine, there's a whole bunch of set types of machine, like 16 core and 32 core. But one of the cool things about our platform is that you can actually dial in. If you have a use case where you really only need, let's say, 44 processors to really do the work you need to do, with other kind of choices, you'd have to go either 32 and be under-spec'd, or go 64 and waste all that money on processors you don't need. With us, you can dial in exactly to what you want, and you can see exactly on the right what the impact of those choices are, right? And I got a little warning at there you go. Oh, it came up. I didn't hit it right. But it basically a little warning and said, hey, you could probably get a better price if you could figure it this way, which is kind of cool. But I'm going to go and stick with our set images, because I don't want to pay that much. And then I'll go to the boot disks. With boot disk, I have a whole bunch of choices of different operating systems, Container OS and Red Hat and Windows even. Yes, you can do Windows on Google Cloud Platform. But I'm just going to go ahead and keep with the defaults. I'm going to hit Select. And you notice I have another couple of options. I can activate HTTP. I can open up the firewall. I'm not going to do it this time around. But one of the favorite things about this interface is down to the bottom, there's this equivalent REST or command line link. So after I configure this whole thing, I click on this, and I get this little box that says, here's exactly how to do this on the command line. So I can then configure it once in the interface, and then take this and automate it and use build scripts, and I don't have to write these things from scratch, which is really helpful. But I'm going to go ahead and create this. And we like to say these spin up in tens of seconds, meaning when I'm in my hotel room practicing this, because I'm doing it at I/O, it takes like 10 seconds. When I'm in front of people, it takes longer. I don't know how it knows, but somehow it knows. So hopefully, oh, all right, good. You don't register, so I'm happy. It doesn't know you're here. Shh. All right, so I'm going to hit SSH, and when I do, instead of having to pull down certs to connect to this VM, I can do it right through this interface, right through the web, which I love for, like, I can travel without my laptop. As long as I can get to a browser, I can take care and manage my stuff. First time you SSH into a box, it takes a little bit of time because it is doing that manual work you used to do. It's doing it automatically for you. So at this point, and I wouldn't worry about the text here too much, but I will blow it up a little bit. At this point, what I would do is go through and apt get update, right? And then it'll fail because I should have sudoed it. So I'll do sudo bang bang to run the same command. And there, I would go through, I would do apt get update, and then I would start rolling through and installing software. I feel like that would strain our relationship as an audience and speaker if I were to just sit here and install LAMP, because that's what's running on this other box. If I sat there and installed all those things over and over again, I feel like I would lose you. So I have a solution for that, which is that I've already done that on another machine. I've then taken that machine and created what we call a disk image from it. I said you could use ours, but you can also use your own. So I'm going to create a second instance here. And on this one, I'm going to open up the firewall. I'm going to open up the HTTP port. And when I go to select images, instead of using OS images, I'm going to use custom images. It's going to take a second. And we'll see here that I have one called Tagger Latest, which I already built. And I'll hit select. And now, when this app comes up, it will be running completely the whole software stack. None of my software is on there, none of my app is on there, but all the supporting software I need is there. So hopefully in a second, this will come up. Maybe, hopefully it has not identified that you're here. And when it comes up, you'll notice that I have these external IP addresses here, and some of them are linked and some of them aren't. The one I just created wasn't linked because it didn't open up HTTP, but on this one I did. So when I click on it, it should go right to the Apache Debian default page. So I've installed, I have software running on a VM. It's all set, ready to go. So one last thing I want to show you before I switch back to presenting is up here in the upper right, I've got this little command prompt. It's another one of my favorite features. instead of having to install all the SDK and all the stuff it takes to manage Google Cloud on my laptop, I can just use Cloud Shell. It spins up a little VM under the covers that I don't get charged for. It's got a home directory, so I can use it over and over again. I can save scripts there. But now I have a I have access to this without having to install all this stuff on my computer. So really helpful, really, really great for trying stuff out. So with that, I'm going to switch back to presenting and talk through a little bit of what I did here. So if you want to start doing this, programmatically and repeatably and kind of put it into your build cycles, you can do all of what I did here with gcloud command. So this one is gcloud compute instances create. That's how I create an instance. And then I would probably want to run commands on those boxes, so I can do that. gcloud compute SSH virtual machine name and the command I want to run locally or remotely. And then finally, I have files that I want to get onto those VMs. I can do that with gcloud compute SCP. So between these three, I can completely automate the creation and configuration of a machine repeatably. And I do a lot of this. I do a lot of scripting of this stuff because I don't want to do it by hand because I make mistakes. So we talked about virtual machines and disk images. So yep, you can start with ours like I did. You put all the software on it, make a disk, and then save it as an image. But you can also make them from scratch. You can use VirtualBox to make images from scratch and upload them to us. Networking, I talked about a little bit about that you get external IPs. But one of the things I didn't talk about is that you can always get an IP address and it'll always be ephemeral. Meaning, if the machine goes down, when it comes back up, it'll get another IP address. But any of those IP addresses, you can grab and say make static and keep. And so like if you start fooling around with a box and you set it to ephemeral, and you're now worried because stuff is now depending on the IP address of this box, you can grab it, hold on to it. We don't charge you for those. The only time we charge you, and this is something that members of my team just learned, is we only charge you for it if you don't use it. So if you have an IP address and it's in use statically, we don't charge you for it. It's when you park on it that we have like a little nominal charge, just a couple cents. It's just enough to make kind of disincentivize you from holding on to IP addresses for a long time. Or holding on to a lot of IP addresses for a long time. Showed off the firewall that you can create rules. I just did the HTTP rule, which we've kind of automated. But you can create arbitrary rules, and they get applied the same way. They get this tag that gets applied to your machine. And that's what'll determine whether or not your firewall is open on the machine. One thing I didn't show off is something called Cloud Launcher. Our VMs, our images start at the software layer, like the OS layer. But if you want, like, I don't know, like Cassandra or WordPress or Drupal or something like that on your machine, you can use one of these and sort of shortcut like having to do the whole build. Now, it's important to know that we don't manage it once you build it. We just help you build it. All right, I'm going to take a slight detour and I talked about Cloud Shell for a second. That's really important. Like I said, it's a little VM. And you have a home directory that follows you, which is like you shove scripts in there that you use all the time. That'll be there the next time you go to Cloud Shell. And it basically means like I never have to, like while I love having my laptop, I never actually have to have it somewhere when I might need to log into Google Cloud Platform. All right, we're back from that little diversion. So now let's talk about storage, right? Because that's the crux of what this app does. It stores files and it stores data. I'm going to start with the files part of it, the images. So for images, we call that blob data because, I don't know, that sounds gross, I guess. Cloud storage is the tool for that. So it's for files, for videos, for pictures, for unstructured documents. Now, there are 4 types, and I'll talk about them, but they all have the same interface. And the metaphor is you've seen with other cloud providers, the idea of a bucket and objects in that bucket. That's what that's how cloud storage works. So we have the 4 types. We've got multi-regional, regional, nearline, and cold line. And they all have different use cases and different costs associated with it. Long story short, multi-regional is for global data. It's for you pushing the data as close to the people that are going to be using it. So it's for people outside your company. It's for web presence. It's for web apps. It's for mobile apps. It's for streaming video. Regional, in contrast, is you want to keep the data close to where it's being used, just like in global, but for this, it's being used for internal purposes. It's for running data jobs and doing big data analysis on large data sets. You want that data near the computers that are going to be doing that, but don't necessarily have to be near the public. Now, another thing to note here is just because it's regional doesn't mean it's only accessible from the region it's in. It just means that it is fastest in that region. And you can still pull this data from other places around the world. So you're not restricted of where you can use this data from. Nearline and Coldline are long-term storage options. Therefore, in the case of Nearline, it's for backups and long-tail media, stuff that's going to be used regularly but infrequently. And for Coldline, it's things like compliance and disaster recovery. So if you're pulling down data from Coldline, you're probably also loading your resume in an editor, just in case, right? So that's sort of the distinction we use for these. Now, as we go to the right, the price goes down because it's less accessible and less easy to get to. The time to first byte for global or multi-regional versus Coldline. Coldline is a little bit slower, time to first byte. And so accordingly, the costs go down. But for Nearline and Coldline, when you retrieve the data, you get charged for it. And in this case, it's 1 gigabyte per, all those prices were gigabyte per month. This is per gigabyte. So when you pull down data out of Nearline, it's going to cost you a cent per gigabyte. And at a Coldline, 5 cents per gigabyte. The idea here is we want to encourage you to store stuff and hope you never need to use it. And that's why the pricing is set up that way, to sort of encourage that sort of use. Now I'm going to do a quick demo of cloud storage, so I'm going to switch back to my laptop here. I'm going to show how easy it is to sort of set one of this up. I'm going to go ahead and, like I said, it's a bucket, so I'm going to create a bucket. I'm going to call it Tagger 102, because the names have to be unique. I'm going to just go ahead and create it. It's multi-regional, so I'm now creating a multi-regional bucket. It's already ready for me. I'm going to upload the files. I'm going to take my files from here that I already had. I'm going to upload them. Let's see how our network is doing. OK. Wi-Fi network is, there we go. All right. So you'll see I have a whole bunch of images here now loaded in. Now, I can't get to any of these. I mean, Google Cloud can see these and share them among Google Cloud apps, but I can't, the public can't see them. The way I enable them to the public is I can just click this little thing here and say, I don't know, share publicly. And when I do that, I get a public link. So even though I just uploaded it, it's now globally available and able to pull down. If I were to URL hack and change it to, one of the other images was that kid in the Ewok costume, which is Ewok JPEG. I hit Ewok JPEG and it's not there, right? So you can be very granular with what you share and what you don't share. So I'm now going to switch back to presenting. Oh, wait, I'm not going to switch back. It'll switch back on this. And let's talk about a little bit what I did. I wanted to upload files, and you can do that with the gsutil command on the command line. That's how I do most of this, right? Because I don't want to manually put all my files through a web interface. I can also share publicly using gsutil. I can set up the settings. You can do them per file. You can also do them per bucket. That's how I tend to do it. I share the bucket, and then I try not to have shared and non-shared stuff in the same, even though you can. Just saying, for me, I don't want to accidentally share something, so I usually try to make that distinction at the bucket level. Now, my app was writing to file storage on the server. I now needed to write to cloud storage. So for that, I want to use our client libraries. Now, our client libraries, you'll see, there's a whole list of languages they're available for. If your favorite language is not here, one, I apologize. Two, we have a REST API, and it's pretty well documented. So you can sort of do this stuff without needing the client library. But this app was PHP, so I don't have a problem. So let's walk through this. Please don't judge me for PHP. I figured it was very readable. Move uploaded file, source destination. So something's been uploaded to the server. We move it to a file location. To do the same thing but point it to cloud storage, I have to pull in the storage library and then create a storage client and a bucket and upload to that bucket. It's a little bit more code, but not tremendously more. And dropping it in was relatively simple and painless to do. So that is client library. So now here's where we are. We've carved off images. We now have our application code and our database still together, and we need to fix that. So let's talk about databases. With that, we'll go to application storage, and we get the SQL versus NoSQL. And that is not anything that I want to wade into. I'm sure we all have beliefs about SQL versus NoSQL. It's OK. I'm not going to question any of them. But I'll talk about what we have for these two places, or these two types. So we have Cloud SQL, which is a traditional SQL server. It's MySQL or Postgres. And it's what we call vertically scalable. You can keep making the machine it's running on bigger and bigger, but at a certain point, when you need to scale out, these don't scale out perfectly well. You can do replica sets, and we make that easy to do, but it is still just good old-fashioned vanilla MySQL and Postgres under the covers. We just manage the backups, and we make it easy to set up replicas, and we take a lot of the pain out of running these machines. And we also have this other thing called Cloud Spanner, which, like, let me put in context, you would never use on this app. It's for gigantic worldwide companies that have, very high rates of queries per second. It is not for this Tagger app. But that's also available to you. It has a SQL interface. It's structured data, highly available, strongly consistent. Our network makes that work, where we can make those claims that it is both those things. And it's horizontally scalable. But keep in mind, it is definitely cost effective when you have the scale for it. At like this small app, it would be overkill. So now I'll talk about NoSQL. NoSQL, we've got Cloud Data Store and Firestore. I'll start with first. Anybody here use Firebase? OK. So Cloud Firestore has a lot of integration with Firebase, and there's a similar product called Cloud Firestore for I forget the branding of it, but it's the same thing. And basically, it allows you to use Firebase's APIs to write to a gigantic NoSQL store in the back end. It's really great when you're writing mobile clients and web clients that you don't want a back end at all. You don't want application structure at all. You just basically want the front-end app to talk directly to the data store. That's what Cloud Firestore is for. Cloud Data Store is more for I've got an app that I've written that I also want to store stuff to, and that's running on the back end, and that communication would happen between Cloud Data Store and the store, and your app. And then finally, Bigtable. You don't see it a lot in applications, very rarely. Like someone will come out and use this for an application because it's got very low latency. But where it really excels is big data jobs. You put a whole bunch of logs in there and store them and run through stuff in that. So that's Cloud Bigtable. It's another one that's only cost effective itself. So which one should we use? Well, I kind of set this up so that there is an obvious winner. I'm not going to rewrite all my logic from SQL to NoSQL. So I'm not going to use any of the NoSQL solutions. And Cloud Spanner is overkill, so I'm going to use Cloud SQL. We've got on the next one. And I'm going to use MySQL instead of Postgres because, again, I don't want to rewrite stuff. So I'm going to do a quick demo of this to show you what this interface looks like. I've got SQL here. I already have a database set up, but I'm going to create a new one. And you'll see I got some options, MySQL versus Postgres. And we actually kind of help you, like, what are you going to use this for? You're going to use it for development, for staging, for production. I'm going to use staging because among its many features, it has this, which is automatic increases storage. So when I set up my disks on the back end, it will automatically make my disk bigger if I start to run afoul of the size of the disk, up to 64 terabytes. So I'm going to go ahead and configure one of these. I can choose version. I can choose machine type. So I can make the machine bigger. They're based on our VM images. You can't customize them, but they kind of fit with the VM standard images. You can choose SSD or standard disk. But one of the cool things you need to know is that if you need higher read-write performance to your disks, you need to give bigger drives. And you'll see when I change this number over here from 20 to 200, all of a sudden I get more IOPS and disk throughput. So keep that in mind. You might need to make bigger disks to get better performance. OK, so I think that's what I want to show off about Cloud SQL. So I'm going to switch back to present mode. I'm going to switch back to present mode. There we go. Oh, I'm pressing the wrong button. All right, I'm all over the place. All right, so how do I get my stuff into Cloud SQL? It's relatively simple. I take it, I upload it to Cloud Storage, and then from Cloud Storage, I ingest it into Cloud SQL, which brings up something kind of important, which is this workflow, move it to Cloud Storage, and then pull it somewhere else is actually pretty common. You have a whole bunch of log data. You put it in Cloud Storage, ingest it into BigQuery. You have images that you want to analyze with our machine learning APIs, put it into Cloud Storage, and have them analyze it. And you'll see two tools here in the center. Cloud Storage is one of those that acts as a hub. The other one is something called Cloud PubSub. There's actually a really cool demo of PubSub in the Cloud Dome, in case you're interested. But what PubSub does is it's a messaging bus. You say, I'm a publisher, and there's a whole bunch of people who subscribe to the channel that you publish to. You send a message, a structured piece of data that does something, and it gets navigated, it gets communicated out to all the people that are, all the subscribers of that service. It's very high throughput, so basically it allows you to basically offload stuff to other pieces of the cloud when you need to, and do it with a queuing system that's really, really robust and fast. Okay, we'll segue back and talk about some common problems people have when they start running database servers on us. So one problem, and I filed a bug, but I feel like I should communicate it to you, is that when you run gcloud SQL to ingest the SQL, you might get an error, and that error is going to look like this, internal error. And then when you raise the verbosity of the gcloud command, you get that it's a SQL error, which is helpful, but not really, because we kind of knew it's SQL. So what you do is in the SQL interface, there's this tab called Operations. And in Operations, we can see that there was an error. We can actually see the line number. We see all the SQL data that we need to troubleshoot this. For this particular error, it was that I had done a MySQL dump like you normally do, but I had some super permissions, which you can't have on Cloud SQL, and so it balked at that. So just a couple of things that if you're switching over to this, you might want to know off the top of your head before you head desk trying to track down what this is. Now, what happens if we, Google Cloud, don't offer something that you need? Like we have MySQL and Postgres and our NoSQL solutions, but you want Cassandra or Mongo or one of the other storage solutions. Well, you do two options. One, you can build it yourself from build it yourself from scratch. Yeah, mixing metaphors. Or you can use Cloud Launcher to build one of our existing solutions like Cassandra, Redis, Mongo, CouchDB, and a whole bunch more. In each of these cases, it's important to note that we don't maintain the software for you. We maintain the OS. And so like in all the cases with Compute Engine, I didn't mention this earlier, but we do something called live migration. So when you update the machine, it will continue running even through the update. You'll never have downtime because we're updating the hardware. We migrate and solve that for you, so you don't have to deal with that. So in each of these cases, you get that with whatever solution you build, but we won't update the software or run backups for you for them if we don't say we do like we do with Cloud SQL. All right, so now here we are. We have taken our app, we've moved it to the cloud, we've put it on a VM, and then we've offloaded database and storage to different parts of the cloud. So now I'm free to start thinking like, well, since all of the data, all of the state of this application is elsewhere, then I can start making interesting decisions about how I run this. Do I want to run a group of VMs behind a load balancer to make sure that I've always got redundancy? I can do that. If I want to go to a serverless solution, I can do that. If I want to go to Kubernetes, I can do that. And I'll talk a little bit about how to do this with a VM. So how do I scale this system? So I'm going to switch to demo one last thing, I believe. And that's going to be something we call managed instance groups. So another error, just refresh. And there we go. So these take minutes to get rolling instead of seconds. So I'm not going to strain our relationship and do things that take that long in front of you. But I will kind of walk you through creating a managed instance group. So basically, I define a group, and I say, I want this to be a group of Tagger machines. I want them all to have Tagger on it. I want them all to run with the same software. And so what I do is I can say, well, I can put this in a single location or multi, so I can have these groups all around the world. I put it in a particular zone, and then I can be managed or unmanaged. Managed means that every machine is based on a template, and they look exactly the same. So we can do things like, say, auto-scale. So all the machines are exactly the same. If the CPU utilization ever gets above 60, spin up another one, and then spin up another one until it gets down below 60. And it can scale down. And so I can say things like, make sure there are always 3, no more than 10, and scale with 60% processor utilization, which is what I have for the one that I have there. And so I can build that, and you'll see that I did here in this interface. So I have these 3 machines, and if I click through, I can see that each one of these machines is running. Each one of these machines is open to the internet, and each one of these machines is running Apache just like I want it to. So we're all good. So where'd I go? So the next thing I want to do is take this and make it redundant, basically share it with the world. To share it with the world, I need a load balancer. So I'm going to pull in Tagger load balancer, which I've already set up. And again, this takes a little while to go, so I'm just going to walk you through the way it's set up. And it's pretty simple. I say, give me a front end. It's HTTP. It's on port 80, and serve it up on an IP address. And then I say, from the back end, serve this instance group. So this instance group, everything is open on port 80. You're listening on port 80. Combine them and make that redundant. So once I do that, I have this set up the way it is. Each one of those machines is answering calls to the internet. But if I go to this machine, this IP address that I get here, it's also up and running. And so like I said, these will scale. All of that scaling can happen usually within a minute to 2 minutes. So if you start getting a load spike, we can scale up load relatively quickly, but not necessarily instantaneously. Okay? So that is scaling out this application with a load balancer. So with that, I'm going to switch back to presenting and take you through a couple more things. So we talked about instance groups, right, which are, they can be managed or unmanaged. Why would they be unmanaged? Well, maybe you want to combine a 2 CPU box and a 60 CPU box. I don't know why, but you want to. That's cool, like no judgment. You're responsible for scaling and all that because we can't figure out CPU utilization, like what should we add? We don't have any of that set up. We're not using a template. So you can manage that. But if you use manage, we can auto scale, and we can also auto heal. If you have health checks on your app and it goes down, we can rebuild a VM for you and bring it back into the instance group. Networking, talked about load balancers. We have HTTP and HTTPS load balancer, which is equivalent of an L7 if you're used to that. We also do TCP and UDP load balancing, and we have internal only that are only accessible within your project. Now, that's how I scale VMs. But I do work for Google Cloud, and we use the buzzwords container and serverless a lot. So I felt like it was necessary to at least talk about these. How many people here are already using like Docker? Okay. How many people are using Kubernetes? Okay. All right. For those of you that aren't, I'll give just a quick what is containers at a very, very high level, and watch the faces of the people that raise their hands as they squirm and squeam through this really, really oversimplified definition. Containers are basically a package that contains all the code and runtime components to run a particular process, your app. And then there's an environment, Docker or Kubernetes, that will trick the process into thinking it's the only one running on the machine. And so you can do crazy things like have multiple versions of the same software running on the same machine. You can stack as many more processes on a machine than you can do VMs on the same hardware. So basically, there are a lot of efficiencies you get from switching to this model. We have two products that we say are container products on Google Cloud. They're Kubernetes Engine, which is managed Kubernetes, which if you don't know what Kubernetes is basically you have dozens or hundreds or thousands of containers all doing different things. You want to run them in a way that you're not managing individual containers. You put them into a Kubernetes cluster with instructions on how to run them, and it'll keep them running whether they're a microservice, a web app, or a batch job somewhere. App Engine Flexible is if you just want something, you have one app that you just want to scale, and it's already in a Docker container, you can push it to App Engine Flexible, and we will scale it for you from 1 to as many instances of it you need. What is serverless? So serverless is a marketing term. It is, right? Like there is a server there. It's not, there's not some beast living beyond space and time running your server, your load for you. But it describes, like, I think, a really important distinction, a different type of app, which is you pay as you go. Whatever you use, you pay for. If you don't use it, you don't pay for it. And you don't care about the underlying infrastructure. You don't have to know about number of servers or number of nodes or anything. We will just run it for you as much or as little as you need. So when we talk about serverless on Google Cloud Platform, we're talking about two things. We're talking about cloud functions, which the unit of abstraction is a function, right? And you attach that function to some sort of event. Someone drops a file somewhere into a bucket. Someone sends a message to a pub/sub queue. You respond to it with that simple cloud function. We also have a serverless solution that's app-based. Now, it's very restricted in terms of what you can do. You can only use certain languages. You can't use third-party code. You can only use code in that language. But what you get for that restriction is incredible scaling. App Engine can scale from 0 to pretty much infinite in a relatively short period of time. I have a demo where I will scale an app that's cold, like I didn't use it, to about 8,500 QPS, queries per second, in about 5 minutes. And to put that in perspective, 8,500 QPS is what Wikipedia gets. So I'm able to go from nothing, cold, to like a Wikipedia scale application in 5 minutes with App Engine. But again, it comes at a cost, restricted abilities to do things. So the question is, should I switch over to one of these? That's like a whole talk. That's like a whole separate talk of whether or not it should go serverless, virtual machine, or containers. But I'll say for this app, without any context, no, right? Like, it's working where it is. I'm bringing it over someplace else. I don't necessarily want to put a lot of effort into it. Lift and shift is absolutely fine. If I have plans to grow this app bigger, or to grow it with a whole bunch of other applications, maybe it might make sense to containerize. But again, that would depend on the context. And if I'm going to have very inconsistent use, then maybe serverless would work out too. But for this particular app with no context, I'm not switching it over. I'm staying on VMs. OK, we've come to the end. I've taken you through a pretty good tour of what we have here. We started here. We started with a single app, all running on one machine. But we ended up here, where we've basically taken all the state, pushed it elsewhere, and we can now grow and expand and have a lot of different options with the computing level. Now, there was so much I couldn't cover. I was pretty vicious with my editing pen, because I wasn't getting under 40 minutes. So I didn't talk about our ML APIs, which are awesome. So what you could do with our ML APIs, same sort of insert in the code the way we did cloud storage, you can grab, with Vision API, you can take this. I'm not going to switch, don't switch over. But you'll notice there that I have tags that I got from Cloud Vision API instead of making people do it. So this app, I could just completely replace data entry on this app with Cloud Vision if I wanted to. I think it's funny, a little detail is that it thinks that the Ewok, the kid in the Ewok costume, is carnivoran, which is kind of scary, but I don't know how he's raised. I don't know. So just, if you see a kid in an Ewok costume, be afraid. But Cloud Vision was able to do that for me. It also picked out skin and children and picked out a whole bunch of details from those images. I didn't talk about the API library. So if you're using any of the other Google APIs like Maps or YouTube or Ads, you can manage them through here and use them in your Google Cloud Platform project with default credentials that you don't have to set up a lot of certs and a lot of credentialing information. You can just run it with kind of very minimal authentication, but securely. Didn't talk about Stackdriver. If you need your logs or monitoring and all that stuff, Stackdriver can do this for you. All this stuff I didn't give a chance to talk about will all help you run in this scenario. So if we look at Google Cloud as a whole, I talked about the compute platform. I think we covered a lot of it. We covered storage and databases. We covered a little bit of networking. We covered the tiniest little bit of big data in that I mentioned PubSub. Mentioned the machine learning APIs, mentioned developer tools, and mentioned management tools. But if you look at this whole list, there's a lot of missing because there's just a lot more to the platform. So I'd ask, if you have any questions or if this has ignited anything in you, please make sure you stop by the Cloud booth. There's everybody from Google, not everybody, but a lot of people from Google Cloud are there and can answer your questions. And hopefully, I showed you how you can onboard and how you can get started with Google Cloud. Keep in mind that if you sign up, you get a $300 free credit for 12 months that you can use to kick the tires. And hopefully, you go from here to discovering more about what's on the platform. So thank you very much. I've been Terry Ryan. Please feel free to heckle me on Twitter, @TPRyan. If you have any questions, I'll be around. But I think I'm running short on time. So have a good rest of your I/O.
And it's a new day. I'm gonna make it on my own. The sun comes out. I'm in a new way. I gotta pack my things. I'm going home.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm here with Ilyan, who is a principal engineer on Android, and he leads Project Treble. Hi, Ilyan.
Hello, Timothy. How are you?
I'm super. How are you?
Excellent. Thank you.
So that keynote was amazing, and there was a lot of your work up there. In fact, Project Treble. I want to talk about that, but before, could you describe the problem? What are you solving with Project Treble?
What we're solving is what we call Android's version fragmentation problem, which is best explained. If you're an app developer, you have to deal with all of these Android versions that you have to implement against, and this is a massive pain to deal with. So this is the problem that we started addressing out with Project Treble.
And how you solve that with Project Treble is you make it easier for manufacturers to upgrade to the latest version, right?
Correct, yeah. I mean, for developers to have the latest, device manufacturers have to launch their devices on the latest or upgrade existing ones to the latest. But historically, it's been very difficult, which means expensive, to do that, which is why device manufacturers simply didn't do it. This is why we have Android version fragmentation today. The way that we solved it is effectively by lowering their costs. That's what Project Treble is.
All right, so Project Treble was introduced last year. What's new this year?
What's new this year is that we effectively completed the engineering portion of our work, and we embarked on an operational side of it, which the goal of it is to accelerate the deliverables, the intermediate deliverables of Android to the OEMs, to the device manufacturers, so that they can do their work to launch these devices and upgrade these devices much, much earlier than previously. So the end result is that we expect companies like Samsung, for example, to do their work this same year, in the same year when we launch Android.
That's awesome. Now, what OEMs are launching?
We have 7 companies in addition to Google's very own Pixel, of course, who are launching previews, betas this year. And these are Oppo, Vivo, Nokia, Sony, Essential, OnePlus, and Xiaomi.
Awesome.
That's a lot of companies.
And you and I actually have our pockets full of some of these phones.
Yes, we do. We do.
I think it'd be neat to show there's the same version of Android running on each of these different phones.
Yeah, that's what's beautiful about this, is that these are devices by completely different companies, which all run the same version of Android. That was never happening until now.
That's totally awesome.
And, there's one more thing, of course. In addition to these previews, we have a total of 18 devices by 11 manufacturers who will either launch or upgrade their existing devices to the latest of Android this year.
That's really cool.
It is.
So for developers, this again really matters because it simplifies their overall developer experience, which they can get started on by downloading the preview.
That's exactly right.
Ilyan, thank you so much for joining us to explain all of that.
Thank you for having me.
To learn more, head on over to android.com/beta. I'm Timothy Jordan, and this is I/O Live. Hello, and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Tim Sneath, a product manager on Flutter. Hi, Tim.
Hi, Timothy. How are you doing?
I'm doing very well, thank you. Let's talk about Flutter.
Yeah.
For those few developers out there that don't know what Flutter is yet, what is it?
Yeah, so Flutter is a toolkit for building native mobile apps for iOS or Android from the same code base. It's open, it's open source, and today at I/O we're announcing a new version of Flutter.
Oh, yeah, so that was my next question. What's new this week? There's a new version, what else?
Yeah, so this week we're announcing Beta 3. Obviously, it's the third beta of our product. We shipped the first beta at Mobile World Congress a couple of months ago, and now we're starting to get to the point where we really feel like it's ready for a lot of production use, and so we're encouraging people to start taking a look at Flutter.
Now, you've worked with developers using Flutter a lot. What would you say they're most excited about when they start using Flutter?
Yeah, so I think there are 3 things primarily that make Flutter a great platform for building apps. Number 1, we have native performance. We compile everything that you write to ARM code. We're powered by the Dart programming language, and that enables this really fast performance. Second thing is we have this unrivaled productivity. With Flutter, you can use this thing called hot reload, so you can write your code, you can continue to work with it, and see exactly the changes that you're making in real time on the device. And then thirdly, Flutter has this high velocity graphics engine that lets your dreams come true, lets designers choose what they want to build and developers put them into production.
Awesome, and there's a lot of people using Flutter today. What are some of your highlights of the apps that are out and live?
Yeah, so again, we've only just got into beta over the last couple of months, both internally at Google and externally. Internally, we power some things like our ads. If you ever create an ad campaign, you're using a Google app built with Flutter. Externally, probably the most famous one that was shipped the back end of last year was Hamilton. You know, the Broadway musical. They shipped a companion app for using Flutter that has had millions of downloads, a really great application. And then this week we're talking about some other new apps. Alibaba, the big Chinese online retailer, they've just shipped an app in Flutter that they're now rolling out to millions of customers. Groupon have an app that they're working on. We have just different kinds of apps from different industries: wine, retail, finance. Loads of different people are coming out with apps. And in fact, we've just seen several hundred apps just since we shipped beta go live on the Play Store.
If you want to get started with Flutter, what's your first step?
Well, there's one simple place you go, and that's flutter.io. And there you can find sessions, you can find code labs. We're obviously live streaming 6 different sessions here at Google this week. There's a whole bunch of documentation, and of course you can download the Flutter SDK.
And that's all at flutter.io.
Flutter.io.
Thank you, Tim.
Of course, it's a pleasure.
I'm Timothy Jordan, and this is I/O Live.
Hamilton is one of the most talked about and best loved musicals, with shows on Broadway, in London, and around the country. We wanted something to make the show more accessible for our fans, so we wanted to develop an app to meet the needs of fans as we started to expand the brand. We turned to Posse, a New York-based development firm, to help us develop the Hamilton app.
Hamilton's Flutter app launched in the App Store and the Play Store 3 months after we wrote our first line of code. And we accomplished a ton. Fans can enter a daily lottery for a shot at $10 tickets, buy merchandise through an e-commerce experience, take selfie photos with the HamCam, and get daily news and updates.
We knew that this app needed to be rock solid, both in terms of performance and visual fidelity, and really represent the amazing experience that the Hamilton show itself provides. And ultimately, that's why we decided to use Flutter.
Flutter is a mobile UI toolkit that allows developers and designers to craft beautiful native experiences on iOS and Android, and is entirely free and open source.
We have very high expectations of quality for the apps that we build. We expect pixel-perfect results, and we need them to be very high performance. Flutter gave us a lot of opportunities that previously weren't available to us. The fact that it's a single code base drastically improved our ability to deliver a consistent experience across platforms. Its hot reload gives us an ability to build more features in less time.
It allowed me to make changes really fast and iterate through the UI without having to stop and restart the app. Coming from an iOS and Android background, it's something that I've been waiting for a long time. The Flutter developer community is very active. Drop-in packages helped us maximize productivity. It helped us integrate elements like Firebase and Cloud.
At the end of the day, we're just really happy that we found Flutter so that we can build these beautiful native interfaces for both iOS and Android from a single code base.
We were given a really tight timeline, and we turned the app around faster than I ever could have imagined. We were able to make changes right up to the night before we went live, and really feel confident about them. In fact, we pushed an entirely new feature to the App Store the day before we launched.
And since launch, Flutter's efficiency and speed has helped us to build new features, such as the recent trivia game. We're really excited because as the show continues to grow, we're going to be able to keep pace with a ton of new features that's going to make the app even better.
We couldn't be more thrilled with Flutter. It has enabled us to use one code base to deliver a truly high-quality app that Hamilton fans have absolutely fallen in love with.
We're thrilled with what Posse was able to deliver. The entire brand of Hamilton is about delivering on an experience for fans. They're thrilled about the new features that we're rolling out, and we're really excited to see where the app goes next.
Hello, and welcome to everyone here and those of you following along on the live stream. My name is Richard Euler. I'm a software engineer on the Android runtime team. I've spent the last 3 years trying to better understand memory use on Android, and more recently I've been working with first-party app developers to tackle the challenges of evaluating and improving Android memory use. It's great to see so many of you here interested in Android memory use. To start off, why should you, as an app developer, care about memory use? For me, it's really about the Android ecosystem, the ecosystem of applications, of devices, and of the users of those devices. And where memory comes into play is not so much for the premium devices, where you have a lot of memory available, but much more for the entry-level devices. Because these devices need a decent selection of low-memory apps to work well. If application memory use and requirements grow, then the entry-level devices won't work as well. If they don't work as well, OEMs will not want to produce these devices. And if they don't produce these devices, well, we're kind of excluding a bunch of users from our Android ecosystem. And that's a bad thing. So app developers have a role to play when they're developing their applications to do whatever they can to be efficient in your memory use, to reduce your memory use, keep it from growing too much, so that we have a nice selection of low memory applications, so that entry-level devices behave well, they work well. And if that happens, OEMs will produce these devices, and we can put them in the hands of users to use our applications. So in this talk, I'm going to talk about 3 broad categories, 3 areas. First, I'll talk about the mechanisms that come into play on an Android device when it's running low on memory and how that impacts the user. I'll talk about how we evaluate an application's memory impact, and in particular, some very important factors to be aware of that come into play with that. And third, I will give you some tips for how to reduce your application's memory impact, especially given that a lot of the allocations going on in your application originate deep within the Android stack on which it's running. OK, let's start. What happens on a device when it's running low on memory? Well, memory on device, physical memory on device, is organized or grouped into pages. And each page is typically around 4 kilobytes. Different pages can be used for different things. So pages can be used pages. These are pages that are actively being used by processes. They can be cached pages. These are pages of memory that are being used by processes, but the data they contain also lives somewhere on the device storage, which means we can sometimes reclaim these pages. And then there might be free pages of memory sitting on the device that you're not using. So what I've done is I took a 2 gigabyte device, and I started it doing nothing. So at the very beginning of time, the runtime's not running. And then I started using it more and more. So lots of different applications, exercising them, which has the effect of using more and more memory on the device over time. So we can see at the beginning, the flat line there is before I started the runtime. Then I start the runtime up. There's plenty of free memory available on the device. And this is a happy device, because if an application needs more memory, the kernel can satisfy that request right away from the free memory. Over time, as you use more memory, the free memory gets exhausted. It goes down. And to avoid very bad things from happening, the Linux kernel has this mechanism that kicks in called kswapd. And kswapd's job is to find more free memory. This kicks in when the free memory goes below what I'm calling here the kswapd threshold. And the main mechanism that kswapd uses to find more free memory is to reclaim cached pages. Now, if an app goes to access a cached page or memory that was on a cached page that's been reclaimed, it's going to take a little extra time to reload that data from device storage. But probably the user's not going to be noticing this, so that's OK. Now, as I exercise more and more applications, they use more memory. The number of cached pages is going to fall as kswapd starts to reclaim them. If it gets too low, there's too few cached pages, then the device can start to thrash. And this is a very bad thing because it basically the device will completely lock up. So on Android, we have a mechanism which is called the low memory killer that kicks in when the amount of cached memory falls too low. And the way this works is low memory killer is going to pick a process on the device, and it's going to kill it, and it's going to get back all the memory that that process was using. Now, this is an unhappy state to be in, especially if the low memory killer kills a process that the user cares about. So let me go through and tell you a little bit more about how the low memory killer decides what to kill. Android keeps track of the processes that are running on the device, and it keeps them in a priority order. So the highest priority processes are native processes. These are ones that come with Linux, things like init, kswapd, which I told you about, daemons like netd, logd, and Android-specific daemons, adbd, installd, basically any native process that's running is categorized into this. The next highest priority process we have is the system server, which is maintaining this list, followed by what are known as persistent processes. These are kind of core functionality, so telephony, NFC, SMS, those kinds of things. Next, we have the foreground app. So this is going to be the application that the user is directly interacting with. In this case, perhaps the user is viewing a web page, so they're interacting with the Chrome app. Next in priority are what are called perceptible or visible processes. These are not processes the user is directly interacting with, but perceptible in some way. So for instance, if you have a search process, maybe it has a little bit of UI on the screen. Or if the user is listening to music in the background, then they can hear that music through their headphones. They can perceive it. After the perceptible apps, we have services. These are services started by applications for things like syncing or uploading, downloading from cloud. And then we have the home app. This is what you get when you hit the home button. It often hosts your wallpaper if you have something there. So in addition to these running processes, we also keep track of what the previous application the user used was. So maybe they're using this red app, your red app, and it brings them to Chrome with a link. Then when they've switched to Chrome, that app is going to be the previous app. And we also keep in memory a bunch of other processes, which are cached applications the user used before. Some of them maybe recently, some of them not for a little bit of a while. I want to point out here that these cached processes, when I use the term cached, this is a different use of the term cached than the cached memory pages I was talking about previously. OK, so the reason we keep around previous and cached processes is because if a user wants to switch to one of these applications and say they want to switch to the previous application, it's very quick to switch to that. Oh, I should say this is for a device in a normal memory state. So if you want to switch to a previous application, that's very quick. But also, if you want to switch to an application that happens to be in a cache process, that's very quick to do because it's already in memory. If we step back, though, and say, well, what happens when the device is low on memory? In that case, we could imagine the memory used by the running applications is growing. The number of cached pages drops below the low memory killer threshold. The low memory killer now has to come in and kill something to free up some memory. Well, it's going to start killing from the bottom of this list. So maybe it kills this blue application. That's gone. We get some more memory back for the applications that are still running. But if the user now wants to switch and start using that blue application, it's not cached any longer. It means it's going to take a noticeably long time to launch that application. It could be 2 or 3 seconds, and maybe it's lost some state. So this is where the user first starts to really feel, oh, something's going on here that's making things slower. If the processes that are running continue to use more memory, so we get under more memory pressure, low memory killer is going to start to kill more cached processes. If they continue to grow more and more, until eventually there's only a few cached processes left, at this point we say the device memory status is critical. This is a very bad place to be. If the running processes continue to use more memory, though, The low memory killer is going to have to kill more processes. Eventually, it's going to end up killing the home app. At this point, the user is going to ask, well, hey, what just happened to my wallpaper? Because when they go home, it's going to be a black screen for a few seconds before the wallpaper starts up again. If it's even worse, maybe a perceptible process is killed. The user is going to say, hey, what just happened to my music? I was listening and it just stopped. Really bad case, the foreground app is killed. To the user, this looks like the app crashed. And the most extreme case you can get into for a low memory killer, basically, it needs to kill the system server. This looks like your phone is rebooted. So these are all very visible impacts of what happens when a device is running low on memory. And it's not a good user experience when this is happening on your device. Okay, I want to go back to this graph that I was showing before about what happens to the memory pages on the device as you use more memory. This was a 2 GB device. What do you think it looks like, this graph, for a 512 MB device? I'm going to give you a few seconds to think about that. You have an idea what it looks like? So I tried it for a 512 MB device. Same thing, start the runtime, use more memory, and it looks something like this. So because there's so little memory available at the beginning, there's very few free pages that we can use up before the kswapd has to kick in. And then there's very few cache pages we can reclaim before the low memory killer is needed to start killing things. And so you can imagine if you have this device and the low memory killer is always active, it's always killing processes, and it leads to this bad user experience, then maybe OEMs are not going to be too interested in shipping this device because, well, it just doesn't work well. And that gets back to the ecosystem challenges I mentioned in the beginning. So this is why we care about memory. Now, how do we figure out how much memory an application is used? How do we know your application's memory impact? I told you that memory on device is broken down into pages. The Linux kernel is going to keep track for each process running on the device which pages it's using. So maybe we have a system process, Google Play Services process, a couple apps running on a device. We want to know each of their memory impacts. Well, just count up the number of pages that it's using. It's a little bit more complicated than this because of sharing, because multiple processes on the device can be sharing memory. So for instance, if you have an app that's calling into Google Play Services, it's going to be sharing some memory, perhaps code memory or other kinds of memory, with the Google Play Services process. And then we can ask, how should we account for this shared memory? Is that part of the responsibility of the application? Is that memory impact something that we should care about? And there's a few different ways that you can approach this. One is to use what we call resident set size, or RSS. And what this means is when we're counting in apps RSS, we're saying the application is fully responsible for all the pages of memory that it's sharing with other applications. Another approach is called proportional set size, PSS. And in this case, we're going to say the app is responsible for those shared pages proportional to the number of processes that are sharing them. So in this case, 2 applications or processes sharing these pages, the application will say is responsible for half of them. If there were 3 processes sharing the same memory, we would say the application is responsible for 1/3 of them, and so on. And then a third approach you can take is called unique set size, where we say the application is not responsible for any of its shared pages. Now, in general, which approach to take really depends on the context. So for instance, if those shared pages were not being used in the Google Play Services app until your app called into Google Play Services, then maybe it makes sense to say the app is responsible for all of those pages. We want to use RSS. On the other hand, if those pages were sitting in memory in the Google Play Services process before the app called into Google Play Services, they were always there, the app is not bringing them into memory, then we wouldn't want to count them. USS would be more appropriate. In general, we don't have access to this high-level context to know, at least at the system level, so the approach we take is the most straightforward one, which is proportional set size with equal sharing. And one benefit of using PSS for evaluating an application's memory impact, especially when looking at multiple processes at the same time, is it will avoid overcounting or undercounting of shared pages. Okay, so use PSS for your application's memory impact, and you can run this command, adb shell dump sysmeminfo-s, give it your process name, com.example.richard, or whatever it is, or you can give the process ID if you happen to know that, and it's going to output something like this, an app summary view of the application's memory, and at the very bottom, there's a total, and that number is the application's PSS. This is adb shell dump sysmeminfo-s. Okay. Now, let's say you do this, you figure out what the PSS of your application is. There's a very interesting question to ask. How much memory should your application be using? Because, you know, I say earlier, if we use a lot of memory, that's bad because low memory killer kicks in, but we're actually using memory for a reason. We're using it to provide features, to provide user value, to provide, you know, delightfulness. Everything that makes our app great is going to be taking up memory. So we have this trade-off between user value and memory. That's what I'm showing here in this graph, the trade-off space. In an ideal world, we're kind of up and to the left on the graph, where we're providing a lot of user value without very much memory impact at all. But in practice, this is going to probably be technically infeasible because you need memory to provide value, and there's only so much value you can provide with a limited amount of memory. On the other hand, the other extreme would be if you're using a lot of memory to provide not much value. And I think it's safe to say this is not a great app because it's providing too much memory, using too much memory. Unfortunately, my slides are not showing up right, but imagine a curve on which there's too much memory for this app. It's not worth it to the user to use. Ah, there they go. Wonderful. Next, we can look at this corner of the graph where we're not providing too much user value, we're not using too much memory. We can say this is like a small application, maybe your desk clock app. And at the other end, we can have apps that use a lot of memory to provide a lot of value. These are large applications, maybe a photo editor, something like that. And we can say, well, what's better, a small app or a large app? In this case, they can both be useful, except that when I've said that an application is using too much memory, that really depends on what kind of device you're running on. If you're running on a premium device, it can support much larger applications, but on a smaller device, an entry-level device, maybe this large app uses too much memory to make sense on that. So really, I should be drawing a line and say too much memory depends on the device. Premium, mid-tier, and entry-level might not support that large app. For better or for worse, what I see happening often is over time, as you develop your application, you tend to add more features. It tends to take more memory. So you tend to go up and to the right in this graph. Now, this is actually good for mid-tier and premium users because they're getting more value, more bang for their buck memory-wise. But in this case, it's a little bit unfortunate for the entry-level device user because while he could use the older version of your app, you've now added so many features and it's using so much memory that it just doesn't work as well on their device. So the points that I want to say here, the takeaways, anything you can do to improve your application's memory efficiency is good. So if you can move to the left on this graph, so less memory use without sacrificing user value, that's great. And just be aware that when you're adding new features, while it can be good for mid-tier and premium device users, there might be a negative consequence for these entry-level devices. Okay, there's something wrong with this graph. Does anyone know what it is? Well, let me see. The problem that this graph is, it's suggesting that an application's memory use is one number. So you give me this application, and I can tell you it's PSS. But in practice, that's far from the case, because an application's memory impact depends on a whole bunch of different things, such as the application use case, the platform configuration, and device memory pressure. And so this is important to be aware of when you're testing your application's memory, perhaps testing for regressions or to see if an optimization is working, to make sure that you're testing the application use case you care about, and you're controlling all of the other parameters so that you're doing a proper apples-to-apples comparison. Let me go into a little bit more detail. So how does an application use case impact memory? What I've done here is I started using Gmail, and I've switched to different use cases in the application over time. So every 20 seconds I switch. I started by viewing the inbox. It's using just a little over 100 megabytes PSS. Then I switched to looking at an email that had some text, uses a little bit more memory. I switched to looking at a different email, this one time with pictures. It uses more memory. Then I started to compose an email, used a little bit less. I stopped using the app, and then it used less memory. So you can see here that depending on the application use case, memory impact varies quite significantly. And it doesn't necessarily make any sense to compare your application's memory from point A and point B, because these are different use cases. Okay. Application use case is a pretty straightforward factor. Something that's less obvious is that your memory will change a lot depending on what your platform configuration is. So what I'm showing in this graph is I've picked one of those application use cases from the previous slide, Gmail, looking at an email with pictures, and I've run it on a bunch of different devices. So a Nexus 4, Nexus 5X, Nexus 6P, Pixel XL, and also on a number of different platform versions, even within the same device. So for instance, for the Nexus 5, I ran it on Android M, N, and O. And you can see that there's quite a variation in how much memory this application use case is taking up. This comes about because, well, for different devices, we have different screen resolutions, different screen sizes, which means bitmaps take up different amounts of memory. You might have different platform optimizations on the different devices. You might have a different Zygote configuration, different runtime configuration. It's running your code differently. And so there's a lot of different factors going on here, which mean when you switch to a different platform configuration, you're going to get different memory use. So I would say when you're testing your application's memory use, try as hard as you can to use a consistent platform setup, the same kind of device, the same platform version, and the same scenario of what's running on device. And now there's a third case I want to talk about, which is pretty interesting because it's a little bit counterintuitive, which is an application's memory impact depends on the memory pressure on device. So here what I've done is I've taken Chrome application, and I started running it on a device that had plenty of free memory. And then I set up some native process in the background that's going to slowly use up more and more memory on the device so that I can see what happens to Chrome when the device gets under medium memory pressure or high memory pressure. And we can see when there's plenty of free memory on the device, so low memory pressure, Chrome's PSS is pretty flat, except for that little spike, which is probably some variation in app use case or the platform. When the device gets under enough memory pressure, that K-swap-D kicks in and starts to reclaim cache pages. Well, some of those pages that it reclaims are going to be from the Chrome process, and that's going to cause Chrome's memory impact to go down. Its PSS is going to go down until eventually, if the device has so much memory pressure, the low memory killer is active, and it decides it wants to kill Chrome, then PSS for Chrome is going to very quickly drop to 0. So what you can see here is that even for the same application use case, the same platform configuration, we have a wide range of PSS values we might get. And so you have to be a little bit careful. Imagine I've come up with this optimized version of the Chrome APK, and it has this kind of lighter blue line for the memory profile. I'm confident that this is an optimized version of the APK from a memory standpoint, because for every level of device memory pressure, it uses less memory. But if I'm doing a test, and I sample the PSS of the original Chrome version at point A, but I sample the PSS of the supposedly optimized Chrome version at point B, and I compare, and I say, oh, well, A is less than B, so A has less memory. I might falsely conclude that the original version of Chrome is better than my optimized version. So you really have to be careful when comparing PSS values to make sure that the device memory pressure is the same, otherwise you can get these funny results. My advice, because it's pretty hard to control for device memory pressure, is to run your tests on a device that has plenty of free RAM so that there's a low device memory pressure, and you can see the PSS numbers will be much more stable in that area. Okay, so we talked about why you want your applications not to take up too much memory, how you can evaluate your application's memory impact. Let me now give you some tips for how to reduce your application's memory impact. And the first tip is check out Android Studio's Memory Profiler. Profile your application's Java heap. This is going to give you a ton of information, useful information about the Java objects on your heap. So where they're allocated, what's holding on to them, how big they are, pretty much anything you want to know about the Java heap you can see from this. My tip for you is to focus on the app heap. So if you open this up in Android Studio, you'll see 3 heaps. One is a Zygote heap, one the image heap, one the app heap. The image heap and the Zygote heap are inherited from the system when your application first launches, so there's not much you can do about that. But definitely, you can do a lot on the app heap. I'm not going to go into a ton of detail on how you would use this tool, or actually not very much at all, because Esteban is going to be giving a talk tomorrow at 12:30 on exactly how to use this tool. His team built the tool. He's going to be talking about how to do live allocation tracking and heap analysis. So I highly recommend you go check out that talk tomorrow at 12:30. Okay, so you say, Richard, you've told us that we should care about PSS, that's our application's memory impact. You just told us we should use the Android Studio's memory profile to profile the Java heap. But if we look here, we see, well, the Java heap's not actually all that much of the overall memory impact of the application. What about all the rest of this memory? What should we do here? This is tricky because most of these applications, or allocations, sorry, are originating deep within the platform stack, the Android stack. So if you want to know about them and really understand them, it helps to know a lot more about, say, how Frameworks is implementing the view system of resources, or how the native libraries, fonts, and SQLite and WebView is working, from the Android runtime, how it's running your code, from the hardware abstraction layer, how graphics is working, all the way down to virtual memory management in the Linux kernel. By the way, I live in the orange block in the middle, the Android runtime. That's where I am in this stack. So you might ask, okay, so this memory is coming from the platform or within the platform. Should we be using platform tools to diagnose this memory? For instance, if dump_sysmeminfo-s, that summary view isn't enough, you could try running dump_sysmeminfo with -a to show basically everything you can see from a platform perspective about your application's memory use. This will give you a much more detailed breakdown. For instance, instead of seeing your code memory regressed, you can see, is it because my .so memory mappings have regressed, or my .apk or .dex memory mappings have regressed? It'll also show you a breakdown of the different categories of memory, so private, clean, shared, dirty, and so on. Private dirty memory is like the used memory I was talking about at the beginning. Private clean memory, the clean suggests it's like the cache memory that also lives on disk. So you could use dump_sysmeminfo. If that's not enough detail, maybe you see, oh, okay, .apk mmap regressed. There's this tool called showmap you can run on your application, and it's going to give you an even more fine-grained breakdown of your memory mappings. And it'll actually give you specific files that are being memory mapped in your application. And this can help pinpoint what files might have led to regressions. In the platform, we have a heap dump viewer that I've developed, experimental heap dump viewer called AHAT that tries to surface more platform-specific things. You could try using that to learn more about your Java heap, though Android Studio's memory profile will have all the same information. And then we also have on the platform something called debug_malloc. This is where you can instrument your application so that every native allocation it makes, it's going to save a backtrace, a stack trace to that allocation. You take what we call a native heap snapshot of your app when it's running instrumented. And if you have the symbols, you can desymbolize the stack traces, and you can get native stack traces for all of your native allocations. This has quite a bit of overhead at runtime, and so it can be a little bit tricky to work, but it provides a lot of insight into the native heap. So we have these platform tools. Should we use them? Can we use them? Well, certainly you could. They're all available, but some caveats with these tools. They tend not to be well supported. They have very clumsy user interfaces, as you just witnessed from my snapshots. This approach requires quite a bit of deep platform expertise to understand, for instance, oh, what's the difference between DEX mmap, VDEX mmap, OAT mmap, where are these things coming from, for instance. You might need to have a rooted device, such as in the case for showmap and debug_malloc. You might have to build the platform yourself if you want to get your hands on AHAT or the symbols that debug_malloc needs to desymbolize. The numbers tend to be pretty noisy because you're looking at memory at a page level. And a lot of the memory use you'll see from these tools is kind of outside of your control anyway. So you might see Zygote allocations, runtime allocations that aren't related to your code. So I don't think that this is the best use of your time to try and use these tools, though by all means, go ahead and try them out. I'm going to give a bit of a different suggestion, which is if you want to improve your overall memory use, do two things. One, profile your Java heap using Android Studio's memory profiler like I showed before. And two, reduce your APK size. And let me tell you why I think this is a reasonable approach for you to take to reduce your overall memory impact. First is that allocations that are outside of the Java heap, many of those are tied to Java allocations. So your application is calling into the Android frameworks, which is calling into native libraries under the cover, which is doing native allocations or even graphics allocations, whose lifetime is tied to Java objects. For instance, just to give you a sampling, in Java, on your Java heap, if you see these kinds of objects, so a SQLite database, web views, patterns, those all have native allocations associated with them. If you see a DEX file object, that's going to have .dex mmap, .vdex, .oat mmap associated with it. If you have thread instances on your Java heap, that's going to be associated with stack memory. And if you're using bitmaps or sometimes surface views or texture views, that can lead to graphics memory use. And there are many others. So if you want, if you're focusing on your Java heap, you're worried it's not going to help anywhere else. That's not true. Optimizations on your Java heap are going to help with other memory categories as well. I am trying, as part of my job, to surface better this information about these kind of non-Java heap allocations. And you start to see that if you look at Android Studio's memory profilers, there's, it'll report a number called native. And I just want to let you know this is kind of an approximation or a suggestion of some of the non-Java memory that might be associated with a Java object. Take it with a little bit of a grain of salt, but it works really well for surfacing the memory impacts of, say, bitmaps. Okay, my second suggestion was reduce your APK size. And why do you do this? Because a lot of things that take up space in your APK take up space in memory at runtime as well. For instance, your classes.dex file is going to take up space on the Java heap in terms of class objects. It's going to take up code memory for the memory map dex file. It's also going to take up what shows up in private other in the app summary view, runtime metadata, representations for your fields, methods, and strings, and so on. If you have bitmaps in your APK, when those are loaded at runtime, the pixel data is going to take up space depending on the platform version or how you've loaded them, either in the Java heap, the native heap, or as graphics. Resources in your APK take up space on the Java heap. Say you have an asset manager object. Also on the native heap, you have a parsed zip file structure that shows up there, and you're going to have code memory for your APK map. And .so files, if you have, if you're shipping libraries, JNI native libraries with your application, when you're accessing those libraries at runtime, it's going to take up space. So all of these things, if you can shrink them, you reduce your APK size, you reduce your memory size. And I will tell you that measuring APK size reliably is much easier than memory, because for an APK, you actually do have one number for the size. If you measure the APK size for a single APK repeatedly, you will get the same result, very much unlike memory. There was a talk at Google I/O last year called Best Practices to Slim Down Your App Size. I recommend you check that out. That'll give you more advice, more concrete action items you can take to shrink these things. OK, let me do a quick recap of why we care about memory, what I suggest you do to improve your application's memory use. So first, I talked about how as we use more memory on device, the low memory killer is going to eventually kick in. It's going to kill processes. If the user cares about these processes, that's bad. If the device is getting low memory killers running too much, then OEMs won't want to produce the entry-level device. Then we lose those devices, we lose those users. To evaluate your application's memory impact, use PSS. Anything you can do to improve your memory efficiency is good. When you're testing for memory regressions or optimizations, make sure you're targeting the application use case you care about and controlling for the platform configuration. Test on a device that has plenty of free RAM to help control for device memory pressure. And to reduce your application's memory use, do try out Android Studio's memory profiler. Focus on the app heap. Go to the session that Esteban's giving tomorrow at 12:30 to learn more about how to do that. Do what you can to reduce your APK size, and check out the talk from last year on how you can do that. So thank you all for coming. I would love to chat with you more and hear more about the memory challenges you're facing. So you'll find me. I'll hang out for a little while outside after the stage. And you can also find me at the Android Runtime office hours, which are 5:30. So that's just a couple hours in Tent F after this talk. Thank you very much.
Hey there, I/O Live. I am Todd Kerpelman, and I am here inside the very crowded and popular Flutter Firebase Dome, talking to Michael Thompson, product manager of Flutter. Hi, Michael.
Hi, how are you?
I'm doing well, thanks. So there's a lot going on here inside the dome, as well as some stuff going on outside. Tell me, what are we looking at here? What's going on behind us?
So this is our showcase wall that illustrates the wide selection of different types of apps you can build with Flutter. So Flutter, of course, is Google's multi-platform SDK for building mobile apps for both iOS and Android. So what we're seeing here are some apps that look very traditional iOS look and feel. We're seeing an app from Google over here from our Atlas team that has a much more traditional material look and feel. And we're seeing a number of apps that have a much more custom look and feel, where they've tried to create this more brand-specific extension, and where the layout of the app really is an extension of that brand.
And so what else can an attendee find if they're exploring the Flutter Dome?
Yeah, so what we're seeing here is the end result. And the thing that's really interesting is that's just one of our key components of our offering. The other thing is we have a great developer experience. So when you try and create UI, whether it's more traditional or more custom, we found that there's a lot of iteration going on. You may have one notion of what your screen should look like, but it's really helpful to take that and tweak it and step by step to build up your UI. So for that, we built something called Hot Reloads, which is the ability to update the current screen you're looking at, and in just a few hundred milliseconds, push a small change to that running application, preserving the whole state without having to re-navigate back in. And that's actually an example of all the great engineering we do in this project. So when you use Hot Reload, you're running against a virtual machine, which is how we can do those quick reloads. But when you're running these apps in production, very importantly, we compile these to native ARM machine code. So you get the combination of fast iteration speed at development time with fast execution speed in production builds.
The thing about Hot Reload that I think maybe not everyone gets at first is this is actually running on a real device. Like the game, you're editing real code.
Yeah, so this is, we do a lot of really cool engineering in this project, I think. So when you run during development time with your Flutter app,
Adam, thank you.
Good afternoon, everyone, and welcome to our session on how to incorporate what's new in material design into your existing code base. My name is Lynn Jepson. I'm the engineering lead of Materials Web team.
And my name is Adrian Secord. I'm the eng lead for our shared code libraries.
So we're going to show you how to incorporate all the new goodness of material design into your existing developer workflow. You're probably in this talk because you've already built an application, and you're wondering, all these new material tools and components, they sound awesome, but realistically speaking, can I incorporate them into my existing code base? The answer is yes. Okay? We're going to show you how to update pieces of your app to use Material Design without feeling like you have to rewrite your entire application. But first, let's talk about some of the new things in the Material Design ecosystem and how that supports our existing MDC libraries. Then we're going to do a walkthrough of the code and show you some example code actually using MDC. And then we're going to talk about some of the benefits of using MDC in your existing code base. So what's new in Material? There are a lot of new things in Material Design this year. We've done a lot of announcements. We've done improvements to our guidance. We've had improvements to our components. And we've launched a brand new Material Tools suite. We're going to show you how each of these tools supports developers. The first tool you should absolutely know about is Material Design Guidance. We've really expanded and enhanced these articles this year. So it starts with an overview of the material metaphor, and then it dives into some of the foundational UI practices around color, typography, elevation. Now, this is all really good, interesting reading, but perhaps a bit theoretical when you're trying to incorporate material design into your existing code base. So Material Design Guidelines also provides tactical guidance on how to use our components, like button, app bar, text field, etc. These articles, they're applicable to developers, not just designers. So let me give you an example. Say your designer makes a mock with a material design button. When you go, the button, it shows text. But when you go to put the text inside the button, inside your application, the text wraps to 2 lines. You're not sure if you should increase the width of the button or just let the text wrap. If you read the article for the material design button, your question is answered quite quickly. There is clear guidance that you should not let the text wrap for a button. These articles, they help developers guess correctly when you're in the middle of feature development. Now, to make sure that these articles are applicable to developers, we have our own engineers, like myself and Adrian, actually collaborate with designers as they're drafting these articles. Our own collective engineering experience, it provides a lot of perspective on what sorts of problems developers frequently encounter.
So that first part with all the guidelines really feeds into the second part we want to talk about, which is MDC. So MDC stands for Material Components, and it's our set of shared libraries that you can use to build material apps and websites. It's actually 4 separate libraries, and they're built to match the guidelines that we see on the design website. We want to support developers where they're at right now, so where the libraries, the platforms we choose, are chosen based on where you're developing. So the first one isn't going to be too surprising. We have a library called MDC Android. MDC Android is the open source evolution of Android's previous design support library. So essentially, we've taken a piece of what used to be inside of Android and pulled it out into the open source, into GitHub, so that you can use it directly, interact with us, and work with us on the GitHub repo. The second one is MDC iOS. This is the open source version, much similar to the Android one, of Google's internal UI library. So you might be a little bit surprised that Google does iOS development. I'm not sure if you are or aren't. Depends on where you're coming from. But actually, Google is dedicated to serving its customers on whatever platform we find them. Fun fact, actually, MDC iOS was the first open source library that Material put out way back in 2015. And it's been hanging out on the GitHub repo since then, and we've been iterating and developing and interacting with everyone there. Another fun fact, actually, at I/O 2018, there are as many developers who say they're developing for iOS as for Android. The third platform you might be not quite as familiar with, depending on sort of what talks and things you've been going to at I/O this year, but it's Flutter. So Flutter is a UI framework. It's written in the Dart language, and you write your app once, and then it compiles down to native Android and iOS apps. Flutter is currently in its first public beta. It's developing a lot of buzz with developers. And you might have actually seen the talk earlier today by one of our colleagues, Will Larsch, called Code Beautiful UI with Flutter and Material Design. If you didn't see the talk and you're interested in seeing it, you can actually catch it on YouTube in a couple of hours.
For web, we focus on providing two core web technologies, CSS and JavaScript. So as many of you probably know, the web is a very diverse platform. There are a lot of ways to do web development. We found that providing CSS and JavaScript makes MDC Web usable by multiple web frameworks. We've also developed a way of wrapping our JavaScript so that we can use it in other web frameworks. Now, we've heard that a lot of existing code bases are written in one web framework in particular, React, which is why today we'd like to introduce a new MDC library for React. It depends on the CSS and JavaScript of MDC Web. Now, this library is still in alpha, but we encourage you to go and check it out and give us feedback on what's working.
So we want to emphasize that all the MDC libraries are open source. They're there, out there, on GitHub for you to see, to play with, to interact with, hopefully to contribute to, even at the very worst if it's just sending us some issues when you find a bug. And we want to make sure that these libraries use modern development practices and that they're aligned with the kinds of development workflows that you yourselves are using. A second piece I'd like to introduce here, which we've seen before in previous talks, is called the Material Theme Editor. This is a plugin for Sketch. If you're not familiar with Sketch, it's a very popular design tool. People use it for mockups, for prototyping, that sort of thing. And if you use the Material Theme Editor inside of Sketch, the cool thing is it knows all about the MDC components. So you have a lot of confidence that whatever gets designed by either yourself or your designer will translate really well to code. A second piece that complements the Material Theme Editor is Gallery. So Gallery is really cool in that Gallery you can use to sort of share different mocks, collaborate, comment on them with all your different team members. But the neat thing is if you're using the theme editor, Gallery basically sucks in a whole bunch of metadata that came from using the theme editor and can display interactive things like measurements, fonts, what the colors are that are set. And even probably more importantly for developers is that you can tap or click on any of the elements that you see in a mock and get the link to the appropriate code documentation. So here, though you can't see this because it's probably really far away, the user has highlighted that first text field on the top, and it's showing some measurements in red, that kind of thing. But even more importantly is the part over on the right, where it's actually giving you a link directly into the Android docs for the MDC text field. This is really great because you know that you're jumping right into the right thing, and you're not trying to figure out, oh, where did that doc go? How do I get there? So this is a really fantastic way to collaborate with design. So using MDC in your code base, we've been talking about this. Let's get right down into some code. We developed MDC to be incorporated directly into your code base. We really, really wanted to avoid forcing you into getting into some huge framework where you had to do a whole bunch of setup or had something where it sent its tentacles into all the different aspects of your app. Instead, we wanted you to be able to take, say, MDC button and plunk it down in your app and get it working right away, and not have to necessarily buy into a giant framework. So you're going to see next some examples from Android, iOS, and the web. So first, let's pretend that you are about to go and get yourself a new puppy. So you're very excited about this, and you're up on the dog adoption websites, as one does. And of course, everyone knows the most important part about bringing a new family member into your family is, or maybe the most fun part, is choosing the name. So you're a developer. You've got to choose a name. You're coming up with all sorts of different suggestions from yourself and your family and your friends. What are you going to do? You're going to write an app to track all these names. So we're going to build our own app here. This is our view controller. This is going to start in Xcode. So it's written in Swift. It also, MDC works just fine with Objective-C. And this is really just starting with the standard template that comes out of Xcode. Xcode, by the way, is Apple's IDE for generating code. And this just comes straight out of the default template and loads up some example data, and then just gets a view on the screen. So if you start with this, you get this very, very basic dog name tracking app. All right, so we have our dog names here. It's wonderful. We've collected a whole bunch of them. But of course, as you go about your day and talking to people, you're going to find even more dog names that you want to track and rank in your dog name tracking app. Of course, so this is a great example of using a material floating action button. So instead of you having to go into the code and add something to an array somewhere, you can just tap the button and add a name that way. So first off, you got to get the code, right? So our code, of course, exists in GitHub. You can download that immediately using Git, all the normal things. But at least on iOS, the standard way to get code is to use a package manager. So CocoaPods is a standard package manager on iOS. And here is a pod file. If you're not familiar with this, it's not very exciting. But what you have to do is just reference this material components pod, and then run pod install to download material components and all of its dependencies onto your local disk so you can use them. The next step is just to wire up this material button the exact same way you would normally. So back in this Swift code, you can see at the top, we're just importing material components. And then next, we're creating a floating button. So the class name in this case is MDC floating button. So we're creating that new button. And then we're setting its icon and its background color and putting in the view hierarchy just as you would a normal button. So if we do all this, you get this nice lifts view, and in the bottom corner there, we have a nice little purple fab that you can, sorry, floating action button, that you can tap, and you get all the normal little ink ripples and the different effects you would expect for pretty much for free.
Let's talk about a completely different example for the web. Say you have an existing HTML form. I'm going to show you how to replace just this input element with a new MDC text field. MDC Web is installable through Node Package Manager. You just have to run this one-line command. It's both easy and fast to install our code into your code base. You'll need to actually update your source code to use MDC Web. So let's start with a text field. You just need to copy our text field HTML into your form. Now, our text field HTML is documented on GitHub. Here we have the documentation for the text field component. The HTML structure is called out quite early in the documentation so that you can quickly copy-paste. And each of our components for web follow this documentation format. The next step is to actually import our Sass files into your Sass files. Sass is a technology which compiles into CSS, and it works with existing open source bundle systems like Webpack. Finally, you need to initialize the JavaScript on the HTML element. And this is all you need. You get a nice, lovely text field working on your website. Users can interact with this text field like they would any text field on any website. And check out the animation of the line ripple and the floating label. This is Material Design approved animation. It provides valuable feedback to the users who are interacting with your website.
All right, so back to our little dog name tracking app, which, the first thing you should probably do is come up with a better name than that. But let's pretend you're really into this app. You're very excited about it, and you think it's the best one of these out there, and you decide to push it a little further. You work up with maybe a friend, a branding story for your app. So you're not just it's not just a simple app anymore. You want to make sure that you've expressed all the right typography and color system and maybe different elements of the app. So it all comes together and works as a single branding story. And let's pretend in your graphic design aspect of your brand, you're really more into sort of like sharp corners and edges than you are these round, circly type things. This is an excellent example of something that we can use material theming for. You might have heard material theming. I hope you've heard about material theming in the other talks in I/O. But this is a great time where we can take a little bit of branding, sharp corners, and apply it to a really visual, very forward element in your design, which is the fab. So what we're going to do is transform our fab from the circular one we get by default into this nice diamond shape. So back in the code here, anything in MDC iOS that you can affect its shape takes a thing called a shape generator. And in the highlighted code here, we're creating this shape generator. And we actually have given you in the library a few standard shape generators that you can use. They do simple things like take rectangles and cut off corners at various angles, or maybe they round off corners at various radii, that sort of thing. And in this case, what we're doing is we're going to take a square, which is or the bounding box of the original button, and we're going to cut off its 4 corners at 45-degree angles so we get this nice diamond shape. So that's all that's happening in the highlighted code. We create this shape generator, and we assign it to the fab. And if we do that and rerun our code, we get this. So you have this nice diamond-shaped fab popping up in the bottom, and you get all the normal effects that you would expect, like the ripple and the different animations for free. And every time your users go and interact with your lovely fab down there, they are getting a little burst of your brand in that button.
all of our all of our components allow for customization. So let's talk about the text field example on the web platform. Say your designer wants to customize all the colors of a text field. He wants the line to start at gray on page load, but then when a user hovers over the text field, he wants it to change to orange. Your designer also wants the line to change to a slightly different shade of orange when the user clicks on the text field and starts entering text. And your designer wants to make sure that the label matches the color of the line. How do you build all of this? You build it using, back, forward. You build it using MDC Web Sass mixins. So these Sass mixins are APIs that developers can use to customize components. Here we have the code to customize the text field. At the top, we have code to customize the gray colors for the idle state of the text field. In the middle, there's code to customize the hover state. And at the bottom, there's code to customize the focus state. Focus state is when the user actually clicks on the text field and starts entering text. Now, you can implement a lot of customization using these Sass mixins, and you don't have to worry about all the choreography of all these color changes. Now, for those of you that have Android applications that are already built using Material Design, the MDC Android team has made it really easy for you to upgrade your existing MDC text fields to a new outlined variant of this text field. Here we have some code for a form in an XML or an Android XML file. All you have to do to upgrade to an outlined variant is to add this one line of code to the style attribute. With that, you get a new form of text field. It looks like this. It's our outlined version. You can think of this outlined version as another form of customization. If this outlined version looks better with your app's existing graphic design, then use it. And because this is an Android component, we've also made sure that it works with existing Android theming. So if you've already set your Android theme colors to the right shades of orange, then this text field will inherit those colors. Now, we've shown you a lot of code here at I/O, but perhaps looking at code from the back of an I/O stage is not the best way to learn. The best way to learn is to actually write code, which is why we've created 30 code labs for you to go and enjoy that work with MDC. We have code labs for all of our platforms: Android, iOS, Flutter, web. For Android, we have code labs in Java and Kotlin. And for iOS, we have code labs in Objective-C and Swift. We don't have any code labs in React yet, but if you want code labs in React or some other technology that you're using, let us know. We really want to make sure that we're targeting the technologies that developers are already using.
So now that we've seen some code, we've seen some examples of getting some MDC things into code, we want to go back a step and say, like, why use MDC? We really believe that using the MDC libraries helps you create beautiful products. We believe that they should be pretty easy for developers to use, and we definitely believe that they provide an excellent user experience to your users. So not only do you get this sort of like experience of using the code, and hopefully it's a little smoother and easier to use, but this actually brings a lot of value to your users. Let's go into a little bit more detail. So each one of our components is built to be pixel perfect. We collaborate with the designers infinitely to add polish, to get all the details right. We worry about the fills and the strokes and the radii and all the anti-aliasing and all that sorts of thing. And we also do a lot of research and user testing. Material as an organization actually has researchers on staff that go out and take our components, put them in front of people, and test them and see what works better and what doesn't. We actually have a very good example of this with the text field that we were seeing before. You might have seen it had like very heavy outlines and very broad or very prominent fills. Our original text field that we released in 2014, when we went out and did some user experience, some user research, we found out that people didn't actually, in the middle of a busy screen with a whole bunch of different things in it, people didn't actually know necessarily that they were supposed to tap into it and fill out the text. So they were missing, say, filling out an important part of a form. We went back and redesigned based on that experience and actually republished maybe a year ago the text field spec, updated all the code so that it became a better text field for everyone to use. The other thing that we do is designers, of course, are not a sort of one-size-fits-all. There's many different kinds of designers. So on Material, we have visual designers, we have interaction designers, we have people who do motion design, and we work with all of them to make sure that every aspect of these components is as good as possible. The other piece is that MDC is production ready. We work very hard to make it optimized for various performance metrics, for memory, for CPU, that kind of thing. We test on a wide range, an exhaustive range of devices and browsers and situations. We also stress test things with the open source community. So you could imagine that maybe Google only uses these components in a sort of certain way, and no one else ever uses them a certain way. But that's OK, because we have open source contributors who are using them in all sorts of different ways, and we get all that and fold it back in so that everyone gets the benefit of that experience. The other thing that's really important is this is how Google ships its apps worldwide for quite a number of years now. All our Android and iOS web apps are out there using exactly this code to ship. So we're used to doing sort of the Google scale performance and optimization that you get the benefit of too.
The third reason why you should use MDC is because it helps you build features faster. So using our components can really speed up your development time. We've already spent months of developer and designer time building these components from scratch. So we want everyone here today to feel like they don't have to build components from scratch. They can just quickly install and use our components in your code base. In fact, we also don't want you to be tied to Material Design's visual expression. So if your designer wants to make changes, like customizing the color of a text field or the shape of a floating action button, then there are APIs developers can use to build that customization. We want you to express brand through our APIs. We have APIs for color, typography, shape. We want our components to feel like they belong within your existing application. The fourth reason why you should use MDC is because using MDC is leveraging MDC engineering. We're going to be releasing new components and new features through 2018 and beyond. MDC is the only component library which evolves with Material Design. So our MDC engineers, they collaborate directly with the designers who are writing Material Design guidelines. That's why you can depend on us to make sure that we release new components that evolve with the Material Design spec. I hope you all have learned a lot today about how to incorporate Material Design into your existing code base. You've seen some new material tools and how they work with MDC. You've seen some example code actually using MDC. And you've heard about some of the benefits of MDC in your existing code base. That's all we have. Thank you so much. We're going to take questions here in a second, but I just want to let you know that we have a Dome F, which is the design/accessibility dome. We're going to be hanging out there all day tomorrow, so you can come and ask us questions there as well. But thank you so much.
Thank you.
Any questions?
Please use the microphones.
Yeah. Anybody? Anybody? No, they just all want to go do code labs, Adrian. Thank you. Oh, Sarah, go ahead.
Do you have any ways to make it easier to export settings that I might have made in Android that I want to be able to share with my iOS app, that I want to be able to share with my web app?
The question is from Android to web, like sharing code?
Sharing all the work that I did to customize my material theme.
We're working on it. Right now, they're visually very similar API-wise. So the question is, how do you make sure that all the work you've done to customize your theme for Android, you can reuse in other platforms like web or iOS? Right now, those APIs are super, super similar because our engineers for Android and iOS and web, they all sit next to each other and collaborate on it. We haven't made it a simple, like, run a script and it works, but we're working on it.
And also, of course, there's different platform adaptations. Android code is not iOS code, and Android designs are not iOS designs. But we hope to make it easier, at least in the sort of 80% case where really the designs are the same.
Thank you.
Thank you.
We're going to get more questions. Oh, yeah.
Yeah, like, is it possible to go too far? Like, say you shape the fab like a bone or something. I don't know. Is it still material or something? Like, the original material design was like paper and ink. Like,
Yeah.
you're saying customized, but what makes it material design? Like,
So the question is it possible to customize a little too far? Yes, but we also have a lot of guidance to help guide you in the right direction that'll sort of help you. Yeah.
So in the design guidelines, there's a great customization section. Not only sort of overall, there's sort of a top-level customization section for theming, but also in every component, there's different things of like, here's how you customize the typography and so for this component. So you're totally right. If you start fiddling with all the knobs, of course, you can generate something that's maybe not so great. But we're hoping with the combination of the guidance and also the tooling. So one of the things that not maybe built into the MDC libraries themselves, but we have tools like the material color tool that'll help you like choose color palettes that look great and will work well in your app. And that sort of tooling, we're hoping to build more like recommendation type things, or sometimes we call them guide rails, to kind of make sure that you don't get too far off the road and we end up with something that should be usable.
are you planning to support Windows with your tooling eventually? Like,
support what?
Windows, because so far it's been Sketch, and that's...
In a web browser, yes.
All right.
Thank you.
Yeah, hi.
Hi there. I wanted to know if our designers stylize an entire material theme, are there tools within the Sketch plugin or gallery to output that as a style sheet or an Android?
Hey there, IO Live. Todd Kerpelman here, and I'm here with Jen Tong, who is apparently using the power of the cloud to like find new planets. No big deal, you know.
Yeah, why not?
Sure. So Jen, what is going on here at this booth?
So behind us, we see Project Panoptes, which is an open source project that includes open source hardware that is composed entirely of commercial, off-the-shelf components. And it is intended to be low cost enough for educational institutions and hobby astronomers to build these robotic telescopes and contribute to the project.
And so what happens once they build these robotic telescopes? How are they discovering stars, or planets, I should say?
So the way they discover planets around other stars is by combining their efforts using the cloud. So what happens is each night the telescopes will all wake up and look at the sky, and they'll get a bunch of great images of the sky. And then when the day comes, they'll go to sleep, but not really. They're going to start uploading all of their data to the cloud platform. And from there, we can combine all the data together, aggregate it, and then from that, we can infer the existence of planets around other stars.
And how do you infer the existence of planets?
So planets are very hard to see directly because their stars are very bright and there's lots of glare and they're very far away. In fact, a star only looks like 1 pixel on the camera. So we have to use some trickery to do that. So instead of looking for the planet directly, we look for a dimming of the star when the planet moves between us and the star, kind of like an eclipse, or we call it a transit in a more general case.
And so the general idea is you've got hundreds of telescopes all around the world taking pictures of the night sky. They combine all those images up to Google Cloud, which analyzes them all and looks for a star that dims on a regular enough basis that you think it must be because there's a planet passing in front of it.
That is exactly correct. So we're able to infer that just by having a whole bunch of samples from having a very large fleet of telescopes.
Wow, that's very interesting. Now, if I remember from being 3 years old, stars do twinkle. How can you tell that a star is dimming because of a planet passing in front of it versus like, you know, normal star twinkling, which is totally a technical term?
Totally technical. And that's a great question because that's part of the stuff that makes Panoptes special. Because we're using commercial off-the-shelf cameras instead of specialized astronomy sensors, we have to compensate for the fact that those cameras are designed to take color photos. Because when a camera takes color photos, it filters some of the light out using this thing called a Bayer filter. And when the star twinkles, it moves around that Bayer filter, and it makes it much harder to count the number of photons, because we don't know how much are getting filtered out by the Bayer filter. So the way we compensate for that is we look for another star in the same picture that has the exact same amount of twinkle. And from that, we can do a relative brightness measurement, because we know how bright those stars should be, because we can identify the star. And that's how we kind of cancel out the twinkle.
And I'm contractually obligated to ask, what awesome Google Cloud Platform features are you using to power Project Panoptes?
Yeah, Panoptes definitely kind of illustrates that boring uses of the cloud can enable really cool stuff. So we are using some simple stuff. We're using some of the simple security controls. We're putting a service account on each one of the devices so we can control access to a specific telescope, can access a specific part of our storage buckets. And then we're using Google Cloud Storage to store all of that data, and then we're aggregating it on Google Compute Engine.
And so the general idea is anybody can get involved, they can build their own telescope, and they can be part of this project, and then if they find a star, they can name it after themselves. Is that basically it?
Well, naming stars is a more complicated issue. And individual Panoptes telescopes don't actually discover a star themselves. It's kind of like a team that collaboratively accomplishes a goal. But yeah, anybody can get involved. We especially like to work with hobbyist astronomers and educational institutions because we want to kind of inspire a love of astronomy in the youth around the world.
That's good. And how would I get started if I wanted to?
So I encourage you to go check out projectpanoptes.org.
All right, so you heard it here. Go to projectpanoptes.org, and you too can name a star after you. Jen totally promised that you can do that. Hello, IO Live, and I am coming to you from the cloud, or I guess more specifically, the cloud section of the IO space, and we're just going to do some demos.
Good. Welcome, everyone.
Welcome.
I'm Romain Guy from the Android Framework team, and now can finally reveal some of the stuff I've been working on.
And I'm Lucy Abramian. I'm an engineer on the AR and VR team. I'm actually going to start off by telling you something very personal to me and that I'm very passionate about. But it's not just one thing. It's actually a combination of things that I love. Ever since I was a child, I've been marveled by space. Isn't it amazing? Just think about it for a second. The diversity of the planets, everything that's going on around the solar system right now. Wouldn't it be amazing if we could just see it up close? There's just one problem, though. Humans can't go to another planet, not even Mars, just yet. Or can we? And this starts the second part of my passion. Augmented reality is delightful. It helps you interact with a world that is within a whole new experience that is catered to your environment. ARCore is Google's platform for augmented reality applications. But even if we use ARCore to help us understand the environment, what do we do about 3D rendering? OK, so while it's not exactly rocket science, today 3D rendering has a steep learning curve. But if you're like me, you're still really passionate about space and AR and 3D and rendering and graphics and matrix math, so you just start coding. And coding and coding and coding, and then you quickly realize there's a lot of code.
Yeah, actually, how many of you have written OpenGL in their developer life? So first of all, I'm so sorry. And second of all, you probably know how difficult it is. I've been doing this kind of stuff for basically 10 years at Google, and it's a pain.
This proves my point right here. It's difficult. And we've noticed that there's so much in common throughout all AR apps, things like streaming the camera image to the background, or even just making an object appear on the screen. So we wanted to take care of that, so you don't have to go through all the pain.
No, I go through the pain.
That's why we built the Sceneform SDK, to make AR development quick, simple, and familiar to any Android developer. Sceneform is a 3D framework that makes it easy for you to build ARCore apps. It includes an Android Studio plugin that allows you to import, view, and even edit 3D models. The API offers a high-level way of working with 3D, and it's tightly integrated with ARCore, so that makes it especially easy to build AR apps. Because it integrates with the Android View framework, you can easily add AR into an existing app or create one from scratch. The New York Times used Sceneform in their new AR articles. You can download the New York Times app today and search for augmented reality, and not only read about David Bowie, but also walk around a mannequin wearing his costumes. Otto, the online furnishing retailer, used Sceneform to allow customers to see what a piece of furniture looks like in their living room before they buy it. If you're from a European country, you'll be able to download the app and try it out.
And actually, a couple of the engineers from Otto are in the audience somewhere. And I just want to thank them because they were very patient with us when we were working on Sceneform. They went through all the early versions of the API. And it wasn't always working right. So thank you.
Thanks for your patience.
And
Well, thanks for helping us build it.
Yes.
Yes. I'm going to play this video again because I love it. Remember that solar system I was talking about that I wanted to bring to you? Here it is, right inside your living room. And trust me, without the thousands of lines of rendering code. You can see this code online right now by going to our GitHub repo linked at the end of the presentation. So let's walk through how we built this app. So first, we'll start off with some common concepts of AR apps, and then show you code snippets using Sceneform. After we've covered the basics, Ramon will go into detail about physically based materials and give you all sorts of rendering knowledge to help you optimize and make beautiful 3D objects in your app. The SceneForm API consists of two concepts, the scene and the view. The scene represents the objects you are adding to the world, like the 3D models that you want to place in your AR app. The view is where your scene will be drawn. In this case, it's your device screen and where the device is in the world. The renderer will draw the scene from this perspective. The view ties into the Android View framework or system, and that's your hook into the app. As a developer, you will build your scene by defining the spatial relationships of objects. To do this, SceneForm provides a high-level scene graph API for defining the hierarchy of objects and their spatial relationships. One analogy that I like to think about is the Android View hierarchy, but instead of, obviously in 3D, and instead of views, we use graph nodes. Each node contains all the information that SceneForm needs to render it and to interact with it. And finally, nodes can be added to other nodes, forming a parent-child relationship. In our solar system example, planets orbit around the sun, and moons of these planets orbit around the planets. A natural way to define the solar system in a scene graph is to make the sun the root node and add planets as the sun's children and add the moons as their children. That way, if you want to animate the Earth orbiting the sun, the moon will just follow the Earth. You don't have to do the complicated math to figure out the moon's relationship to the sun while the Earth is orbiting it. In this video, it's the same solar system example that we saw a little bit ago, but we've also added touch interaction. Nodes can become interactive by adding touch listeners to them, obviously, and we propagate touch events through the scene graph the same way Android touch events are propagated through the view hierarchy. Nodes can contain 3D models like the planets or the sun, or 2D Android views. You can create an Android view just as you would in your layout editor and put it in the world and interact with it like you would with any other app. It's a first-class citizen of our scene. So how does an Android developer usually get started? With Android Studio, of course. I won't go too deep into this because there is another talk tomorrow morning called Build, Iterate, and Launch that will show you all of these steps. But I want to note that we have built a plugin for Android Studio that allows you to drop in 3D models that are built with standard modeling tools like Maya, or you can download them from Poly. You go through the import flow, and that converts the models into an SFA and SFB format. These formats are particular to SceneForm, and the SFA is what's bundled into your app. So drop the SFA file into the res.raw folder, or the source assets folder, and you can ship it with your app. One thing we wanted to note, yes, you can view and edit your models right there in Android Studio.
Yes. And what's important to note is that we use the same renderer on the device and inside Android Studio, so what you see in Studio will be what you see on the device. One other thing to note, again, there are going to be more details tomorrow. The importer acts as a Gradle plugin, so for every asset that you import inside your project, you're going to get a new Gradle task, which means that if your designers give you a new version of the asset, all you have to do is replace the file in your project, and the next time you build, we will reconvert the asset automatically, and you'll be up to date. So you don't have to worry about going through a manual wizard every time you get a new version of the asset.
Let's start coding? Yeah. Let's start off with our onCreate method in your activity, just as you would. find the AR fragment, find SceneForm's AR fragment. This takes care of setting up the AR core session for you and also manages the lifecycle of SceneForm. And naturally, it will contain the AR view, and the view holds a reference to the scene. I want to note here that you don't have to use our fragment. You can use the view and therefore the scene directly.
And this is one of the powerful things about SceneForm, because it's just using a regular Android view that happens to be a surface view. You can drop it wherever you want in your application. It doesn't have to be full screen. And more importantly, we don't take over your application. If you try to use something like Unity, for instance, Unity becomes your application. It's a very easy way to embed AR inside an Android application that already exists. And New York Times, for instance, is a great example of how far you can push this, because they show AR through a web view. So they just put an AR view behind a transparent web view. And as you scroll the web view, they load content into the AR view. So you can do pretty complex things. It doesn't have to be just a simple full screen example like you're seeing here.
So let's start loading all of our models. And in this case, I have a to-do for you to load the rest of them. But I'll show you how to build a 3D model. In SceneForm, we have two types of models. We call, or not models, sorry, renderables. Renderables are the things that are going to be rendered on the screen. I know we're very creative with the naming. In this case, we want to load the sun model, which was dropped into our res.raw folder. And so you set the source and build. I also want to point out that these are completable futures. So it will do the loading in the background, and you can accept and handle as you would with a completable future. I should also mention Kotlin here. We could do all of this in Kotlin, but all of the code snippets will be in Java.
One thing we haven't done yet is build Kotlin extensions for SceneForm, but if you are inclined to do so, I would love to see your code.
So remember earlier we showed you this graph representing the sun and the planets. Keep the structure in mind, because we're going to be loading and creating the scene graph. We've loaded all the models, so now let's build a solar system. We start off with the sun node. Create a new node and set its renderable to be the sun model that you had loaded. Next, we create the earth node. We set its parent to the sun, therefore building the scene graph, starting to build the scene graph. Notice here that I have set the sun to earth meters constant. In this case, I've used 0.5 meters because I wanted to fit the solar system inside the living room. But we've set the Earth's local position relative to its parent, the sun. Set the renderable that we loaded, and continue. Now the moon. Create the node, set the parent to Earth, and notice here now that the local position of the moon is Earth to moon in meters. I think I've set it to be 0.1. It has nothing to do with the sun. Set the renderable as a moon renderable, and you're set. Now, to animate their orbit, you can just use Android's property animation system. We've created some evaluators for you to use. Once we return the root node, we now have the entire graph, our solar system. So let's bring the solar system into the scene. All we have to do is parent it to the scene. And that's it. Or parent the sun to the scene. And the solar system is now in your room. Or we could do something else. Anchors. I don't know if you know about ARCore anchors, but they are how you attach your content to the world. And ARCore makes sure that they are anchored to the world. You can get anchors from ARCore's hit test based on the user's touch events. Or with our new cloud anchors, you can use an anchor that another friend has created on another device. For using anchors, we've created an extension to Node called the anchor node that just takes an anchor and now brings that anchor into our scene graph. Set the anchor node's parent easily, just to the scene, and then set the sun's parent to the anchor node. Notice how we've rearranged it a little bit. First, we had the scene with the sun as a root node, but now we've created the scene the anchor node, and then the sun and the rest of the solar system. I was mentioning model renderables before, so now we'll talk about the 2D view renderables. To add 2D into your app, in this case, I've used a little info card that pops up about 1/4 of a meter above a planet, say, and you want it to display some information on it. So I've created this node that would hold the view renderable. I've set it to a planet, and it will now float 1/4 of a meter above the planet, wherever that planet is. You start off by building a view renderable. But notice here that instead of the res raw source for the model renderable, I've set it to the view ID. And that's all there is to it. Now you have the 2D view, just as you would have in any other application, and you could do things with that view, like set the text. And finally, if you want to drag, scale, and rotate objects, we made that really easy for you by creating a transformable node. The transformable node is an extension to Node, but it also understands touch events and gestures, like dragging and scaling and rotating objects. So in this case, if instead of creating a sun node, I created a transformable sun node, I would just do everything else that I did before, but now we can actually drag and move the solar system. I should mention that there was a talk earlier today about UX interactions in AR. So if you want to know more about the best practices for UX, please go back and look at that talk. I'll hand it over to Romain.
Let's talk about materials. So this is a deceivingly simple part of SceneForm. But before you can understand how to create your own material, we have to understand the concept behind physically based rendering. So after you import an asset through the Android Studio plugin, like Lucy said, you end up with two files. There's a .sfa and a .sfb. So the .sfb is the binary that goes into your application and that we load at runtime. The .sfa is effectively a JSON description of the asset. And it looks a little bit something like this. So this is the SFA from the moon, the moon of the Earth from our example. And you can see those attributes called base color, normal, and metallic roughness. So those point to textures that are defined somewhere else in the SFA file. I'm not going to go into details about the syntax and the structure of the SFA file, mostly because there's excellent documentation that's available online. There's also the talk tomorrow morning, so you should check that out. But what I want to talk about is what kind of textures do you need to create to be meaningful for the color, the normal, and those two weird ones, the metallic and the roughness textures? But again, before we do this, we have to talk about physically based rendering. So physically based rendering has started becoming quite popular over the past, I would say, 3 or 4 years. It started in the VFX industry. It's now used in a lot of AAA games. It's still fairly uncommon on mobile. And the basic idea behind it is that we're relying on physical principles to define all the behaviors and all the equations that we use in the rendering system. So that includes things like separating the lighting code from the code that defines the surface, and that doesn't impact on the materials themselves. It means that we have to take into account laws of physics like the energy conservation. We use physical light units. So for instance, when we declare a sun as a dynamic light in a scene, we use the unit called lux. Or if you were to add a light in your scene, in your AR scene, that's just a light bulb, you can use watts or lumens as the unit. So it's a number of things like this that are grounded in reality that both help us validate our rendering. It also makes our life easier because those are things we deal with every day and that feel natural to us. And I'm going to show you an example. So this is an example, it's not in AR, but this has been rendered using our rendering engine, just a very simple sphere. And you can see that there are reflections on the sphere. You can see, what you are seeing here in action is a physical effect called the Fresnel effect after a 19th century physicist. And the closer you are to the edge of the sphere, the more you can see the reflections. And this is a natural phenomenon that you can see everywhere. So this is a photo I took in Lake Tahoe. And you can see that close to the edge where I was standing, you can see through the water. And the further away you get, the more you can see the reflections of the water. So, and again, you can see this on every object. Every object around you follows this principle. It might not be obvious at first, but this is what happens. And we recreate this kind of physical behaviors in our rendering engine to make things look as realistic as possible. So we follow a workflow for our materials called the metallic roughness workflow. If you look that up, you're going to see there's a lot of information out there. The metallic roughness workflow is available in a lot of popular tools. If you've used Unity 5, you have access to it. Unreal Engine 4 uses it. Blender, recent versions, has access to the metallic workflow as well. So the way it works is when you want to define a new material, you're actually trying to describe and define a surface. And to define a surface, you're going to need three things. And we're going to take them in this order for very specific reasons we're going to explain in a little bit. The first one is you need to define the metallic property of the surface. Often we talk about metallicness, but it's not even a word. So metallic, at a high level, is whether or not the object is a metal. And we're going to see why this is very important to us. Then you're going to define the color of the object. And we call it the base color as opposed to the diffuse color or the specular color. Those are terms that you might have seen if you've used older engines. And again, there's a reason for that. Finally, you need to define something called a roughness. Roughly, it means how shiny the object is. And if you want to go further, there are two other things you can define to give your surface more details, a more natural appearance. So the first one is the normal, or the normal map. It just helps break the evenness of the surface. And the second one is called the ambient occlusion or occlusion. So first, what is a non-metal? I'll spare you the equation. This is actually fairly simple. So here at the bottom, we have an object, an orange object. It's drawn in gray to make the diagram easier to read. But we have light coming from a light source and hitting the surface of the object. And the light that hits the object gets split into two components. The first one in white is the reflected part. So those are all the reflections. So in that orange ball that we saw before, at the edges you could see those reflections. That's this part of the light. And then the other part of the light is refracted into the object. And most objects around us, they absorb some of the light. The light enters the object, it gets scattered, it bounces around inside the object, and eventually some of the light will come out, but not all of it. And this is what gives object colors. In that particular case, because the object appears orange, it just means that green and blue components of the light have been absorbed inside the object. And that orange light that comes out is called the diffuse light. The white light is called the specular light. So specular is for the reflections, and diffuse is for everything else. So this is an example of a non-metallic orange ball, and you can see those reflections. If you look at the reflections here, this is simulating an environment inside the classroom where we have overhead white lights. And you can see that even though the object itself is orange, the lights appear white. That's because they just bounce off, they don't enter the object, they don't take the color of the object into account. And then the rest of the object, the non-reflective parts, are orange as expected. Now, when you have a metallic object, metals are conductors, and they're called conductors because when energy hits them, in this case light, the part of the energy that's refracted into the surface gets absorbed. It just gets transmitted into the object and does not get scattered outside. So there's no diffuse light. You only get reflections. However, what happens with those reflections is that they take the color of the object. So you don't get those white reflections anymore. You get the orange reflections instead. So if we take the same ball that we just saw and we turn it into metal, if you look again at the lights, at the overhead lights of that classroom, you can see that they now appear orange. And this is because the rest of the light, the rest of the specular light, was absorbed inside the object. You can also see another side effect of this, of the Fresnel law that we just talked about. If you look at the edges of the sphere, you can see that the reflections are not orange anymore. They take on the color of the environment. And this is, again, a very natural effect. It feels weird when you see it for the first time in a rendering engine, but rendering engineers like me, who are obsessed about their work, comes Christmas time, they look at their Christmas tree and they take a picture of one of the ornaments. I was holding one of my phones on the side. I was lighting this green metallic ball with an orange light from the wallpaper on my phone. And you can see that on the edge of the ball, suddenly the reflections are not green anymore. They take on the orange light coming from the light source. So what we just saw here can appear weird when you see it on the computer for the first time, but this is an effect that's perfectly natural that happens everywhere around you. So the metallic property, I mentioned that this is the first thing you should decide, and you've now seen why, because when you define the color of your object, when you define the base color, it's whether or not, depending on whether or not your object is metallic or not, it's going to dramatically change the aspect of the surface. So you should always decide first whether you're dealing with a metal or a non-metal. So when it comes time to create the actual texture, the metallicness of the object can be defined as a grayscale texture, so values between 0 and 255. At 0, the object is not a metal, and at 255, when it's white, the object is a metal. Most of the time, the value should be either 0 or either 1. All the values in between are mostly used for anti-aliasing purposes, because your texture could contain, maybe it's a metal that's painted, and the paint itself is not a metal. So at the edges of the paint, you want nice fall-offs, nice transitions from metal to non-metal. Certain alloys in real life happens to be a mixture, and you can use intermediate values as well, but most of the time you won't have to deal with it. You won't have to worry about it. Very quickly, when a metal gets rusty, it actually becomes non-metallic. So if you're trying to create a surface that's rusty, the rust stains will be non-metal. And very often, so that's something that, again, you'll see tomorrow, you don't have to use textures for everything. You can also use constants. And very often, you can get away with not having a texture for the metallicness of your object. You can just say either it's a metal or it's not. OK, next step, you have to define the base color, so the color of your object. It defines either the diffuse color of the object for non-metals, or the specular color, or the color of the reflections for metallic objects. And what's quite difficult to do when you create a base color texture is that it must be completely devoid of any lighting information or any shadowing. And we're going to look at an example. And that can be hard because as human beings, we never see the actual color of an object. We only see objects through lighting. So it's difficult to imagine what it looks like, but you can quickly get used to it. And whenever you use a tool like Photoshop or Affinity Photo to build your textures, make sure that you're working in the sRGB color space, which is what those tools should be doing by default. But just in case, make sure you and your artist work in that color space. So this is a quick guide of how to build colors for objects. Based on real-world data, most of non-metallic objects use most of the range of the brightness. So whenever you pick a color in the color picker, for a non-metallic object, the values of your RGB color should be between 10 and 240. And there's nothing as dark as 0. There's nothing as bright as 255 when we deal with non-metals. And metals, on the other hand, they're always fairly bright. So they are not, dark metals basically don't exist. So you should stay in the range that's shown up here. And I was mentioning that you should not have any lighting information inside the base color of your object. And you can see here a set of swatches taken from real-world observation. And you can see that gold, for instance, that in real life appears quite yellow and saturated, the base color is actually not that saturated. All the colors in the base color map tend to be very pale compared to what you actually perceive. So here's another example. On the right, you can see a material to represent bricks. And on the left, you can see the base color texture. And you can see the difference. Once we light the object, all the contrast and saturation appears, but all of that information is not in the original texture that we're using to create this material. So again, if you work with your artist, make sure they're familiar with the metallic roughness workflow, or make sure they at least understand that the base color map should not contain any lighting or shadowing. Now, I mentioned the third parameter is called the roughness and defines how shiny an object is. So a very simple way to define a surface is like this. It's infinitely smooth. There's no object in the world that's smooth. And what happens when you have a smooth object, rays of light that are coming parallel to each other bounce off parallel to each other as well, so you get very sharp reflections. Rough objects, on the other hand, have what we call macrofacets at the surface. You can think of those as very, very tiny mirrors that might not be oriented in the same directions. So when light comes in, you have these parallel rays of light. They can bounce off in random directions, and that creates blurry reflections. And those are examples. At the top, you can see a ball, a yellow metal, and we increase the roughness from 0 all the way to 1. And at the bottom, we have a non-metallic ball, and we increase the roughness from 0 to 1. And you can see the effect here. We start with very sharp reflection, and as we get closer and closer to 1, the reflections become so blurry that we can't even perceive that they are reflections. They're there, but they're spread over basically the entire surface, the entire visible surface. So this is a very powerful feature because it lets you, again, create things like polished metals or a plastic that has been used for quite a while and it's become, well, basically rough. So roughness is very similar to the metallic property. It's a grayscale texture. You use values between 0 and 255. At 0, your surface is going to be glossy or very shiny. At 255, it's going to be extremely rough. You're not going to be able to see the reflections anymore. And just be aware that there might be differences between different tools. So if you specify roughness of 100, let's say in Blender, that same roughness might look a little bit different in a different engine because there are different ways of doing those computations. You shouldn't worry too much about this. Just tweak the asset until it looks right instead of scene form. Sometimes the roughness will be called glossiness instead. And glossiness is just the opposite value, so you can just invert the texture in Photoshop, for instance, to get the roughness map. Next, we want to add some details. So to save on performance and memory, we try to use smooth surfaces. So when you build your mesh made of triangles, you use smooth surfaces. So here we have an example of bricks that are completely smooth. To add some details, we can use a normal map. A normal map looks like this. When you apply it to the object, suddenly you get a little bit of shadowing and more information, more details on the surface. I'm not going to go into too much details about normal maps because there's a ton of information available online, so we're going to skip that before we run out of time. The only thing to know is that the colors inside of a normal map encode a vector. It's a direction. It's not a color. Next one is ambient occlusion. So here we have our bricks, and they've been textured properly. They have a roughness, they have a metallic, they have a normal map. But we're lacking what we call macro-scale shadowing information. Because a brick has a depth, so it will create shadows on itself. Like the surface should be casting shadows on itself. But because we don't have access to the triangles, instead what we create is just a black and white texture that tells us where the shadows should be. So again, that's called ambient occlusion or occlusion. It's very simple to, let's see the before and after. That's after, before, after. So again, adds a lot of detail and depth to your object. An ambient occlusion map is just a grayscale texture. When the values are 0, the pixel is completely in the dark. You should never have values set exactly to 0. At 255, there's going to be no shadowing. And it doesn't affect all the lighting. I'm not going to go into too much details here. So anytime you create an object that has cracks or crevices, that kind of stuff, you should be using an ambient occlusion map. So in the end, we have our 5 textures. We have the metallicness, the base color, the roughness, the normal, and the ambient occlusion. And if we get them all together in this particular example, you can create an object where everything varies from pixel to pixel. So here we have a metal ball, but for some reason, some of the tiles are missing, and those are not metals anymore. The reflections are just gone. So you can see with just the 3 textures, you can create very impressive variations from pixel to pixel and create most real-world materials in a photorealistic manner. One thing you can do to optimize your materials, especially if you use the 3D format called GLTF, that I'm sure they're going to talk about more in details tomorrow, you can pack the channels into a single texture. So ambient occlusion, roughness, and metallicness are grayscale images. So they can each fit in one of the channels of an RGB image. You can do this easily in any good photo editor like GIMP or Affinity Photo here, or Photoshop. And you can have only 1 texture instead of 3. It's going to speed up your load time. It's going to speed up the rendering as well. All right, so now I want to talk about performance a little bit. So one of the features that we have inside of our rendering engine is something called dynamic resolution. What we do is we always watch the time spent on the GPU to render every frame. And instead of dropping frames when there's too much to render, we adapt the resolution of the rendering. So we smoothly adapt the resolution both on the vertical and the horizontal axis. Sometimes we adapt first one axis, then the other, sometimes both at the same time. So what this means for you is that if you're building an AR scene, if you make it too complicated, if you have too many objects, if you have materials that are too complex, we're not going to drop frames. We're always going to favor performance over anything else. But we are going to lower the resolution of your scene. It works really well on our phones because we have really high density displays, so it's really hard to tell when this is going on. And I'm sure that most of you won't even notice as you're using the app. But basically, it boils down to, do you want to see a complex scene at lower resolution, or do you want to see a simple scene at higher resolution? The maximum resolution we currently use is 1080p. Even on devices like the Pixel 2 XL, we're not going to use the full resolution of the display because it's just way too many pixels to be able to drive physically based rendering.
Roman, I want to call out that the renderer does this automatically.
Yes, it's done automatically. You don't have to worry about it. We take care of performance in this case. Meshes, when you create your objects, it can be really tempting, especially for your artists, to add a lot of triangles to create really smooth surfaces. But we're running all of this on mobile phones, so you should be careful with the complexity of the objects. To give you a rough idea, what we call a hero object, so an object you can get really close to, should have maybe at most 10,000 triangles. But even that, if you can avoid using that many triangles, it would be great. And if you use 10,000 triangles in one object, make sure there's only one of them and not 100 of them, otherwise performance is going to suffer. And this is already with some of our early access partners, this is one of the common issues that we've seen. Really tell your artists to simplify the models as much as possible. And it's particularly important because every time we have a triangle that's smaller than a pixel, the GPU is going to do way too much work. I'm not going to go into the details here because you probably don't care, but basically we might end up doing the work 4 times, and we really don't want to do that. The complexity of the scene, thankfully in AR, you're probably not going to add a lot of objects, but if you ever create an AR scene, for instance, where you have a model of a city, you might be tempted to put a lot of objects in that city, every building or every car, every even pedestrian. What we recommend is that at most you should have maybe 100 objects visible at a time on screen. And the reason here is because we're going to run into, the CPU is going to become a bottleneck. So this is not something that dynamic resolution can help with. We avoid rendering anything that's not on the screen. We have a lot of optimizations around that. But if we have too many objects on screen, we're going to be bound by the CPU, and there's not much we can do about it, and you're going to start dropping frames. And dropping frames is particularly bad in AR. I mentioned the format called GLTF. We support OBJ and FBX. GLTF is a standard driven by Khronos. Khronos is the committee behind OpenGL and Vulkan. A lot of tools support GLTF. Websites like Sketchfab have a lot of assets in the GLTF format. And one of the reasons why I like GLTF is because in the standard, they pack the occlusion, the roughness, and the metallic inside a single RGB texture, which is something you should be doing for performance reasons. So if you can ask your artists to give you GLTF models, it's going to make, by default, your models a little more efficient to render. One thing we didn't show you how to do with our APIs, you can add lights in your scene, and you can add many, 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 many lights. This is an example of an early demo of our rendering engine running on my Pixel 2. So here I think we had something like 128 lights in the scene. So you can see that you can have many, many of them, and we can still run at 60 frames per second. What's very important is that if you add many lights in your scene, make sure they don't overlap or that they don't overlap too much. Because if we have 2 lights on the same pixel, we have to do the work twice. So if you have 100 lights on one pixel, we're basically rendering 100 frames. So use a lot of lights if you want. Make sure they don't overlap. And to do this in our APIs, you can give us a maximum sphere of influence for each light. Finally, if you use the view renderables, it's extremely convenient. You can create views the way you do it in the rest of your application. You can put them in the scene, super useful. But every view is rendered in software, and for every view, we have to allocate what's called a surface texture, and this is going to cost memory, it's going to cost CPU time, and it's going to cost GPU time. So try to reuse the views as much as possible. Don't try to put too many of them on the screen, and don't try to allocate too many of them at the same time. And finally, all the usual advice that we give you for performance inside Android application applies to AR, obviously, so don't allocate in the render loop. Don't do too much work. Be mindful of the size of your APK and all that good stuff. With that, we're out of time. There's a talk tomorrow morning, Build, Iterate, and Launch AR Apps. There's another one called Designing AR Applications that was earlier.
Today.
Yeah, earlier this afternoon. So come back 2 hours ago. We also have office hours. There's a code lab available online to create a similar scene to what you saw. And that's it. And if you have questions, you can find us after this talk or tomorrow. We'll be around to answer all your questions.
Triggers the cloud function. So on upload, something happens and it happens right away. And then coming back, once the response from ML Engine is received, you're using Firestore to basically give that real-time update to hit your phone right away as well. So you kind of keep that loop tight, even though you've managed to do this while all the while maintaining this kind of thin client. That's really nice, that the way you've kind of leveraged the existing technology. You didn't have to write anything to make sure everything happened nice and quick, but async.
Yeah, one thing that's great about Firebase is I get those real-time updates whenever new data comes in with that path.
Fantastic. So I guess zooming out a little bit, you've built the mobile app that builds a custom machine learning model. You've collected your data, you've annotated it, you're training, and you're serving at scale to your mobile client. What did you find to be kind of the most interesting part of all of this?
I would say definitely learning to tie together all these different tools. So there's a lot of different things I use to build the app from end to end, from TensorFlow object detection to Cloud Machine Learning Engine, which had a couple of different components. It had training, serving, and online prediction. And then the client piece using some Swift SDKs and the Firebase SDK for cloud functions.
Yeah, I mean, just along the way, you're hitting Python, Node, Swift, JavaScript. Oh, JavaScript is there.
Even a little bit of Bash with the G-Cloud commands.
Right. Right. Outstanding. And so, on the whole, what did you find to be most challenging kind of out of all of this?
The most challenging part was getting all of the data into Google Cloud Storage, because there was a lot of different pieces that needed to be there, from the pre-trained model checkpoints, the TF records, and then that config file, which tells object detection where to find these different pieces.
Right. And these are all coming kind of from different places, and just getting it all arranged. Yeah, I could see how that could be challenging. And I guess, was there some fun parts as well, hopefully, along the way?
It was pretty fun to build. One thing that was kind of funny was, as I labeled all the images myself. So there was a day
Hard
where
work.
I know it was a tough job. So there was a day where I had pictures of Taylor Swift on my computer. People walked by, were probably wondering what I was doing.
Yeah, just perusing photos all day. Right?
Exactly, generating those bounding boxes. And the most fun thing was definitely the final result of seeing on the iOS app the prediction with the bounding box come back in real time.
Definitely, yeah, that's a long journey.
It was.
Awesome. And as I understand, you've actually open sourced your code on GitHub.
Yeah, it's all available on my personal GitHub repo, and there's instructions in the README if you want to build the same model yourself.
Awesome. So that's so great that our audience can go out and build their own model. And I want to thank you so much. Really appreciate you coming in today and chatting in the studio.
Thanks for having me. Great to be here.
Yeah, it's been great. Thanks for watching this episode of Cloud AI Adventures. Today, we saw how to go from raw data to training to a mobile client. You can use Sarah's GitHub repo to not only recreate this, but extend it with your own data, a different model, or a different client app. For more details, we've included links to all the resources we discussed in the description, so check it out. And if you've enjoyed this episode, please like it and subscribe to get more episodes right when they come out.
to tell me now how you think I missed out. Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing, and this thing can't stop me now. We were so young, we couldn't help but love each other. But now I know nothing hurts deeper than a first love, a first love. And don't try to
Hi, everybody, and welcome to this session, the last one of the day. Everybody having a good I/O so far? Nice. Excited for the concert tonight? Yeah. So thanks for spending some time with us beforehand. I'm Lawrence Moroney.
I'm Kaz.
And we're here today to talk about machine learning plus IoT equals a smarter world. Now, that's a little bit of a riff on a famous computer science book. Anybody know what that is? Algorithms plus Data Structures equals Programs by Niklaus Wirth. It's one of the seminal works in comp sci. So we said, hey, we want to do a little bit of a riff on that. And it's also really about what's going on in the world today. That there's two major trends going on. Number one is the rapid rise of IoT, and number two is the rapid rise of AI and machine learning. And in many ways, these are kind of, they're intersecting with each other to create some really cool new scenarios. So we wanted to talk through a few of these scenarios and give some demonstrations. The first one we'll give is, let's take a look at really cheap IoT sensors that will do something in this case, we're going to take a look at those that measure air quality and how they can push data to the cloud and how we can use that for machine learning.
And we'll also look at how the cloud can be an empowering tool for IoT and AI with products that help you collecting data and analyzing it and learning some intelligence with the deep learning models.
And then the third one will be as some of our devices are practically mini computers like Raspberry Pis and our handheld devices, that what can we do about on-device inference with them as well? So we'll take a look at some of the examples of that and some pretty cool stuff that's happening there. But first of all, some numbers. According to IHS research, there are expected to be 31 billion connected IoT devices by the end of this year. That's a lot of devices. And those devices combined, we found the same research is showing a 27.6% compound annual growth rate of the data that they are pushing to the cloud. So 31 billion by the end of this year, and every year the amount of data that they're pushing is growing by 27.6%. And that's a lot of data. Now, what are we going to do with that data? Well, obviously, there's the usual things, filtering, sorting, querying, all that kind of stuff. But we can also use that to start training some models. And all of that data and all of those models, machine learning models, can then be used to generate intelligence and to help us to start making intelligent decisions based on the data that's being generated by our devices. So the first scenario I wanted to look at was thinking about simple sensors that give us smart solutions. I just wanted something with 4 S's on it. Easier to remember that way. And an example of this is there's these little devices, and if you've ever done any kind of hardware hacking, and there's a device, the one on the left here is called an ESP8266. And this little chip actually has GPIO pins on it, so those input-output pins, and it also has a Wi-Fi circuit on it. And when you combine that with something like the one on the right, that's an air quality sensor and a gas sensor. Now you can start putting together something very quickly and very cheaply that will push data to the cloud. And I'm going to go off script for a second, and an interesting story. Kaz and I had prepared this talk, and we were rehearsing it last week with the VP of our division. And one of the feedback he gave us was hey, you don't have any small, simple sensors on there. You're doing lots of cloud stuff, and you're doing lots of mobile stuff, but you don't have any IoT sensors. So you should really build one and put it in there. And this was last Wednesday. And the environment that we live in now is so cool that we were able to, thanks to Arduino and thanks to the Maker community, to be able to build the demo that I'm going to show shortly, in just a couple of days. And the longest part of that, can anybody guess what the longest time in building the demo was? No, it wasn't actually testing. It was waiting for the parts to be shipped from Amazon. I'm an Amazon Prime subscriber, and it took 2 days, but it only took 3 days to build the whole thing. So, you know, it's an amazing time to be alive, I think. You know, the amount of things that you can do, the amount of creativity, and the kind of things that you can build, it's just, I find it so cool, and I'm really happy to be alive right now. So let's take a look at, like, an example of how you'd use one of these. Like, consider a building like this one. And say in a building like this, we could put sensors like this for air quality around the building. And when they're around the building, then we can start tracking the air quality in that building. But, you know, that's just an instant status. We can tell the stuff here on the south side of the building, the air quality isn't great. You know, and then on the north side of the building, the air quality is very nice. But what would usually happen if you work in an office like this? People on the south side are going to go and adjust the thermometer, adjust the thermostat, the fans will kick in, and then people on the north side are going to be too cold. You know, it's like, wouldn't it be great if we could intelligently adapt the building? Or what if there was a disaster and there was like maybe a carbon monoxide leak, and our sensors are going to show that carbon monoxide leak, and I don't know how well you can see it here, but the leak is primarily centered around the exit. And if people are being driven towards the exit, they might be driven towards danger. But when we've got cheap sensors like this, we could say, hey, look, instantly we can have an alternative exit. But what if we can go even further? Sorry. What if we can go even further and then think about scenarios where machine learning comes involved and we can start predicting things? Like maybe we can predict the best times of the day to keep the fans on to maximize air quality and reduce our energy footprint. It's good for the environment. Or maybe we could, if there was a gas leak or something like that, we could predict the path of the gas leak based on testing and based on machine learned models. So emergency responders would know where it's safe to go and where it's dangerous to go. And you know, we all love our emergency responders and we want to make sure that they're safe. Or maybe we could look at what the impact by modeling what would be of like rearranging our office. What if we have more people sitting in the north and less in the south? Or what happens if we host a big event? And you know, this building is actually one of the offices in Google Seattle. And up on that top left-hand side there, that room called Center of the Universe is actually where we host a lot of events. And it'd be good for us to understand the air quality when we do so. So if you've got a lot of devices like this, there's a product called Cloud IoT Core. And the idea behind Cloud IoT Core is it's fully managed and allows you to easily secure, connect, manage, and ingest data from all of your devices. And then once you have that, then you can start doing interesting things like pulling the data out using BigQuery, using Cloud ML, using Cloud Data Lab, using Cloud Studio to be able to then build models and then run inference on these models and have analytics behind that. But let me give a little demo of environmental monitoring and what it would look like. So if we can switch to the Wolf Vision. So this is the device I was talking about. So this is a simple Arduino device. I'm not using the Wi-Fi. In this case, I'm just using a wired one. So I have a shield on top of the Arduino with a wired internet, just so we can make sure that the demo would work here. And then this little device is the air quality sensor. And so it's like, right now it's measuring the air quality in the room. And so that's measuring for particulates, it's measuring for gases, carbon dioxide, carbon monoxide, natural gas, all that kind of thing. So we kind of want to trigger it by kind of polluting the air a little bit. Any ideas how we could do that? I'll just breathe on it, because we all breathe out carbon dioxide, right? So I'm going to breathe on it. I've always wanted to do that in a session. And now if we switch to my laptop. So on my laptop, we can now see I have a Firebase running here, and I'm using Firebase Cloud Firestore. And on Cloud Firestore, I'm actually detecting and I'm getting the readings from this little device. So we can see the readings up here once they come up. Look here at the reading, like 57. That was a moment ago when I breathed on it. 54. I've actually gotten it up to 70. I must have eaten something bad. The usual background here is about 42. So what's going on here? How has this been done? Well, with Arduino, it's super simple to write code in C. And can we switch back to the slides? It'll be a little easier to see the code. So if I go back to the slides, we can see this is the kind of code that you would have written in C on an Arduino. And all I'm doing is I'm reading pin 0. This is plugged into data pin 0 on there. I'm reading that, and then every 2 seconds I'm reading it again. And then what I'm doing with that is I'm posting that to a URL, and then that URL is writing it to Firebase for me. And that's all you have to do. It's really that simple to build a sensor to start monitoring air quality. Very, very cheap, very, very simple. And then when you aggregate the data from all of these sensors together, if you've got thousands of them in the cloud, then you can start building some really intelligent solutions. But there's something to take into account when you're doing IoT, and that's think in terms of security. So data security is very, very important. Obviously, these things are just generating data and pushing it up to my database, but a smart hacker might be able to figure out how I'm doing that and then get access to my database. So you've got to think in terms of data security. And a pattern that I usually like to follow for this, and for good reason too, is instead of pushing from the devices directly up to your databases, have something within your firewall that they are pushing to, and let that act as a proxy, and then that proxy will proxy out to your databases for you. So then you'll have a secure connection between that proxy and the databases, and then hopefully that secure connection will be enough. And the reason for that is also to do it as an internal thing, was that the power limitations on these things mean that a lot of these will only support HTTP. They won't support HTTPS. So that's why in my code a moment ago, if you looked closely, you would have seen that I was just calling, I was just making a client.connect server, 80, in that case, because it's just an open HTTP connection. So that was to my internal proxy, and then the internal proxy was sending it out to the cloud. So things to consider, very cheap, very easy for you to build systems like this one. Coding with something like Arduino in C is super simple. There's tons of APIs and tons of examples there that would do that you can just adapt, and that's what I did in this case. I'd never touched an Arduino before last Friday, and it took a couple, and I'm not particularly smart, and it took just a couple of hours to figure out how to hack some of the code that they had provided to be able to build this and write my data up to Firebase. So that's on a small, simple sensor, but now let's take a look at what happens when you go cloud scale.
Okay, thank you.
Kaz.
So that was a very simple scenario. And let's take a look at another scenario where we would have a little bit smarter devices, such as camera. If you take a picture with a camera, you may want to detect some object, what kind of object you would have in the images. And TensorFlow provides an API to do that. That is Object Detection API. So by using the Object Detection API, you could have the labels of each object in an image, or you could have the boundary boxes, and you could have the scores. And it's really simple to use the API. For example, you can just download the model file for the Object Detection API, and you can have the dictionary for the tensors with the model file of the model. Then you can pass your images to the dictionary, and that's it. So you would get the output dictionary that would have the detection results, such as the number of the objects you would have, or classes of objects, or the boundary boxes, and the scores. It's so simple. So, for example, you could have the Raspberry Pi with the camera attached to a shopping cart so that you can take a picture of the inside of the shopping cart and apply the Object Detection API to detect what kind of items you are having, or how many of them you have in the cart. And we can use the Cloud IoT Core combined with the Cloud Machine Learning Engine to build a system that provides the production level scalability and availability. For example, if you want to build a smart camera system for the shopping cart, you can have a Raspberry Pi and a camera attached to the shopping cart, then use the Cloud IoT Core to collect all the data, store the data, or storing data on the Cloud PubSub, which could be the backend for your server. And we could use the Google Kubernetes Engine, or GKE, as an orchestrator for orchestrating everything happening at the cloud side. And finally, the GKE would be sending the data to the ML engine. That's where we are running the prediction with the Object Detection API. Let's take a look at the demonstration. So I'd like to use the webcam to show how
Switch to the laptop, please.
Yeah. So this is how it looks like. So it's a very small card, miniature card. And we have a Raspberry Pi and display and a camera. So if you put something like, this is a fake eggplant. I bought it in a Japanese store.
Also known as an aubergine for us Europeans.
Or a tomato.
Also known as a tomato.
How Object Detection API would look like. So please switch to the, I should ask him, yeah. So let's wait a while.
I need to refresh. Should I refresh?
Is it working? Maybe the network issue.
What network?
Oh, yeah.
There we go.
Here you go. So, thank you. So it's so easy to detect what kind of the object and how many of them you have in the shopping cart. So please go back to the slide. So that worked. So that was a very simple scenario where we just counted the items and classify them. But you may think that what's the point of using cloud for this kind of detection? And actually, that is true. You can run the object detection API just inside the TensorFlow, just inside the Raspberry Pi box. And you don't have to use the cloud. But if you can collect all the data at the cloud side with the thousands of the records, then you can extract certain some collective intelligence from thousands of the past records. For example, you can train a machine learning model with the order of the shopping items you are adding to the cart, thousands of them. So you can train a machine learning model that can predict what will be the next item you will be putting into the shopping cart. That will be reflecting the location proximity, starting from the vegetables and fruit and meat, like a chicken and spices and pasta, based on the already past history of the shoppers. And you can also have a small display with it, showing the recipe recommendation with the next item to add. That could be working as a navigator for the shoppers. So let's call it as a smart shopping navigator. And what kind of machine learning model we should design for implementing the navigator? At first, we have to represent what kind of items you have in the cart. So if you have the tomato in the cart, we may have the one hot vector that represents the tomato in your cart. In this case, you would have a 1.0 as a value in the vector. And if you put eggplant in the cart, you would have another 1.0 value in the vector. If you have the chicken, then you would have another 1.0 for chicken. So these multiple one-hot vectors represents the cart item history. And with TensorFlow, you can write code like this. So you would have a dictionary for shopping items, and you can call the one-hot function to encode the shopping items as a vector. And then you can have the multiple vectors that represents the cart item history. And now we have the history, and how do you detect the changes in the history? In this case, you can use the convolution, single-dimensional convolution, or 1D convolution. And convolution in machine learning is usually used to detect the certain patterns in a local group of the big data. For example, if you have a 2D images, you can apply a 2D convolution to find some shapes or patterns in the images. That is how CNN or convolutional neural network works for image recognition. But you can also apply the convolution to the single dimensional data, such as time series data. For example, you can apply the 1D convolution on the cart item history. They can detect that what kind of changes that happened inside the cart items. And then you can flatten the output to get the result. And with TensorFlow, you can write the code like this. You can call the conv1D function to apply the single dimensional convolution, and then call the flatten to get the result. So now we have the cart item change history, and we may also want to take in other factors such as seasonality, whether it's a winter or summer or time of day, because shoppers may want to choose different food items based on the seasonality, whether it's a summer, hot day, or whether it's a cold day. So we put everything into a single MLP, multi-layer perceptron, which is a classic old neural network with the 3 layers to predict the next items to add. With TensorFlow, you can write code to concatenate everything into a one tensor, and you would define the 3 layers of the MLP, and that's it. Let's take a look at how the Smart Shopping Navigator works. So,
switch to laptop, please.
Yeah, please switch to the laptop. If you put the eggplant, then it should detect the eggplant.
I see a shadow.
Yeah. So you are watching the same screen I'm watching here. So at the right side, you see the what kind of the recipes and items are recommended. So it looks like the system recommends the pasta, eggplant, baked. And I want to make a pasta, so I would put the tomato. Then the navigator would show the other things you have to add would be, I already have it, but eggplant, tomato, and I want to make the, maybe I have to use the, I want to make a pasta.
The mouse is also working.
Mouse is working. Or somehow it doesn't show pasta, but anyway.
Refresh.
Yeah, I can try putting just chicken. So that you can just follow the items on the screen so that you can find all the items to make the eggplant tomato pasta. That's how it works. Okay, thank you. So please go back to the screen, this slide. So as you have seen on the demonstration, by showing the recipe ideas and next item to add, it works just like a car navigator for the shoppers. So the shoppers can just follow the next item to add to fill the cart with all the items required to cook with a certain recipe. And that was the example of how the cloud can be empowering tool for the IoT devices, not only for collecting data, but also you can analyze it and learn some collective intelligence from it. It's not just an IoT anymore. It's an Internet of Smart Things. And this demonstration was actually built by a Google Cloud partner called GrooveNodes. And they have open sourced everything on the GitHub. So if you're interested, please go to the GitHub and search with Smart Shopping Navigator to find out what kind of code you would write. And this is also, they also provide a production solution called Magellan Blocks, where you can have the user interface to build the whole data pipeline for collecting the IoT data and analyzing it and learning, training the model. So with that, I'd like to back the stage to Lawrence.
All right. Thank you, Kaz. Pretty cool stuff, right? So now the third scenario that we wanted to look at was like on-device inference and training. And like there's a few different types of devices you can do inference and training on. So for example, you can do it on a mobile phone or a tablet. You can do it on a Raspberry Pi, or you can do it on an Android Things device. And there's a really cool video of doing it on a mobile phone or tablet that I've put at this QR code. So take a look at this QR code, watch this video. I'm not going to show it here, but the idea behind this video is that if you went to the TensorFlow Summit, you would have seen it, but it's farmers in Tanzania, in Africa, who don't have cloud connectivity and who rely on a plant called cassava, that if the cassava plant gets diseased, it can kill and impact an entire crop, and it's hard for humans to eyeball it and see it, but they built a machine-learned system that all you do is they wave their phone over the leaves, and they can diagnose diseases early. It's really, really cool. So that kind of on-device inference without any cloud connectivity is possible through something called TensorFlow Lite. With TensorFlow Lite, you can also do inference and training on a Raspberry Pi. And I have a car here that I'm going to show in a moment that's driven off of a Raspberry Pi. And if you were in the sandbox area, you would have seen cars like this one self-driving around. But basically, there's a little camera at the front here. And what I would do is I would manually drive the car, record what I'm doing, and then based on the telemetry that I'm sending to the car to drive it around and the corresponding video, that's giving us the features and labels that we want that the car will then remember and then use that to self-drive. If we switch back to slides for a moment. And then finally, there's the third one, which we'll show in a moment, is on an Android Things device. All this is made possible because of TensorFlow Lite. And I strongly recommend check out TensorFlow Lite and check out the talks on TensorFlow Lite. But the idea behind TensorFlow Lite is that if you want to train a machine-learned model, we have a bunch of converters that will then flatten that model and shrink it to make it more mobile-friendly. There's an interpreter core then, which is used to execute that model, so you can do inference on the model. So for example, things like if you want to do an image classification, it'll do that locally on the device without round-tripping to the cloud. And then there's all the stuff that's needed, like operation kernels and hardware acceleration, to take advantage of the mobile hardware that you have. It runs on Raspberry Pi, it runs on iOS, and of course it runs on Android, and it works really great on a Pixel. I have a Pixel 2 up here, and if you want to see a demo of it, come see me afterwards, and I can show like real-time inference on the Pixel. It doesn't really work on the stage that well. Now here's a video that I shot of me doing real-time inference, and you can see like it saw the coffee mug correctly, and here, you know, this coffee mug kind of looks a little bit like a mixing bowl, so it got like, at some points it felt like a mixing bowl, and I know that's a horrible product placement for my show, Coffee with a Googler, but I had to do it. And here it was able to recognize a mouse and stuff like that. So this is what it would look like running on Android. And so for the self-driving car that I've been talking about, so you can see on the right is the Raspberry Pi, and on the left is something called a pulse wave modulation controller. And that's what actually drives the car itself. So I have TensorFlow Lite running on the Raspberry Pi, and that's what will actually drive the car. And this is built on a project called Donkey Car. And if you want to go and take a look at Donkey Car and details about Donkey Car, they're at this URL. So should we take a look at what it would look like to actually train the car? So if we can switch to my laptop, please. And So I've actually started up the Raspberry Pi on the car, and there's a little web server running on that. So let me go and see if I can access it. Hopefully it'll obey. Oh no, it's refusing to connect. Hang on. Oh, sorry. CDD2. And so what I'm doing is it runs on Python, so I'm just running the Python code. Sorry, Kaz, to make you hold it so long. So this is actually booting up the web server that's on the car that I would then use to train and drive it. So it'll take a moment just to boot that up. But what will happen is, so if I want to control the car when I'm training it, obviously it's hard for me to do it on it, so it has that little web server. The web server is connected to a hotspot on my Pixel, and my laptop's connected to the same one. So it's starting up that server. It looks like that server's done. Yep, and here it is. So as Kaz moves it around, you'll see that one. And if I were to try and drive the car, I made a bit of a mistake. If you've been over to the sandbox, you would have seen the cars they're using are really small ones. And I didn't read the specs properly, and I bought this one, and it's an absolute beast. It goes really, really fast. I don't dare put it on the floor and start driving, because it will take off, and it will land about 3 rows back. So watch out, Kaz. And you see it's like, this is what it looks like if I'm driving and training it. I can steer, and I can control it like this. So it's, what it's doing right now, it's recording what it would see on the webcam from the car actually moving, and storing all that stuff that would then use to train a TensorFlow model for that specific area. So when you see the cars over in the sandbox, they're on that figure of an 8 track. So we drove them around that figure of 8. We trained them in that way. And then instead of launching it in training mode as I have it now, you just launch it in drive mode, and they go and they drive themselves. So you can build one of these as a donkey car. It's OK, we can put it down. We can build one of these using the Donkey Car project. It costs, this one is a little bit more expensive, but they generally cost maybe about $200 total for everything. And you can build your own little self-driving car, and it's all open source. It's really, really cool. So thank you. Can we go back to the slides, please? The motor on the car is really loud, so I'm going to turn it off because we hear it whizzing. OK, so that's what it's like to train a donkey car, and that's the kind of, with on-device inference, you can then have, believe it or not, a model self-driving car. I think that's really cool. Now, the next thing was Android Things that I mentioned, and did everybody get one of these? Right? So these are just so cool. So this is like just a little, this one isn't actually a Raspberry Pi. It's a different developer board, but a similar concept. And with Android Things being able to execute stuff, and with TensorFlow Lite running on Android Things, you can start doing inference. And has anybody done the Code Lab? Have you tried it out to do inference on these? Try it out and build it, and you'll be able to do things like this. So this afternoon, back in my hotel, on this device, I kind of pointed it at a water bottle, and I thought it was interesting that it gives you 3 things that it thinks it is. It thought it was a water bottle, a pop bottle, or toilet tissue. I don't know if it's because of the circular parts of it or anything like that. And then I tried it on this one, and it said a coffee cup, a coffee mug, a cup, or a measuring cup. And particularly the way the handle is placed, I thought it would be really interesting to try and fool it. With the handle the way it's placed, and I thought it might think it was a pitcher, because sometimes when I do mugs like that, it kind of classifies it as a pitcher. And then, of course, this one, I tried on my Android, my little French Android, and I thought he was a piggy bank, a teapot. I guess he's a little teapot, the way he's standing. Or maybe even a spotlight, and maybe it's the shape of it or something like that. But that's the stuff that's built in, and like when you assemble this device that you've got, that app is actually already running on here, and that app is open source. And one of the really cool things you can do is that the image model that app is trained for, you can actually retrain that for your own images. I've been working on a version of it that I'm going to add to the car, and maybe we'll be able to talk about it at a future I/O, where I'm retraining the car to recognize things like traffic lights. So if it sees a red light, it will stop. If it sees a green light, it will go. And all the code for you to do that is available with this kit when you get it. So give it a try. And for those of you watching online, just check out Android Things. You can buy these kits. They're relatively cheap, and they're so much fun to play with. So the Code Lab that I mentioned, if you're here at I/O, you can go over and try it out. If you want to try it on your machines at home, the URL for it is at this QR code. Go give it have a play with it. It's a lot of fun. So in recap, we spoke a little bit about Internet of Things and AI, and about the trends that are happening, that the explosive growth that is going on, the growth of actual devices, and the amount of data that they're producing, and then the things that you can do with that. We looked at, like with the sensor data on an Arduino, we looked at cloud scale AI, and we looked at on-device inference. Now, there's a whole bunch of things that you can do to go and take a look at. OK, come on, slide, animate, there we go. So things that you can try out, number one, writing data from your Internet of Things device to cloud storage. There's great details on it at this URL. If you want to explore the TensorFlow Object Detection API, which is what Kaz was using here when it was detecting tomatoes and eggplants or aubergines and that kind of stuff, you can find details on that at this link. IoT and the Cloud ML Engine, details for that are at this link and this one. And TensorFlow and TensorFlow Lite, and all of the mobile scenarios that I was showing here were based on TensorFlow Lite. You can learn about that at this link or attend the talks if you're here. And then finally, exploring Android things itself. I find it super cool. And it's really nice because if you're already an Android developer, you can start building stuff using your existing skill sets. When I was doing the thing for the Arduino here, I had to give myself a crash course in C, you know, but if you, like I said, if you're already an Android developer, whoops, and you're used to using Java or Kotlin to build your Android apps, then you can start building Things apps with that too. So with all of that, we just want to say thank you very much. Feedback is always welcome. We'd love to hear it, and it's at this URL. Thank you.
Show 2018, and it isn't over yet. Come back at 8:30 p.m. Pacific Time for our live concert with Justice. They'll be debuting their new song, Stop. Tomorrow, we'll be back here at 8:30 a.m. with more sessions, sandbox demos, and special guest interviews. See you back here in 1.5 hours. We'll leave now with Justice's new music video, Stop.